What I think happens is they're so conditioned from their 2015 propaganda that, yeah, you go in there, you say this, they're going to say that, then you say this, then they're going to pull out the AE map and prove to you that the Earth is flat, and then you tell them that. So once you get a couple steps off their script, they have no idea what to say, and it's just time to NPC reset and come back another day.
Yeah, I think the education system. I mean, I've flat smacked people, in the real world, and they go through the exact same system. Then Coriolis, then they do the whole thing, like in a row.
Yep, I've had the same experience as well. So the training and the indoctrination just immediately kick in, right? It's like a programmed response, and so they just go through all the things that they were once told. And since they've never thought through them, they're almost sure that you're wrong because it came from one of their high priests, and there's no way some rando on the internet could be correct.
Also, you got older, like, magazines or newspaper articles. I think it's the Flat Earth Review. They go through a list of typical responses to Flat Earth, and the questions are the exact same in the early 1900s, late 1800s as they are today. Well, if the Earth's flat, what about the sun? What about the moon? What about eclipses? It's all the same thing 100 years later.
Yeah, it makes perfect sense. That's what it's all built upon, right? Is celestial observations, and then just claiming relative motion and on all the lore that comes along with what they see in the sky. Oh, it's not just a light; it's a burning ball of gas, hundreds of light years away. That's why it looks so small, And it was plausible to me. I thought that seemed reasonable. I didn't at the time when I was a child. I didn't reason well. Hello.
How are you? Can you talk?
Good, how are you? Oh yeah, we can talk.
No, I just need admin I can't open my cam.
To turn your cam on? Yeah, I probably will give you perms for cam.
Oh, you admin or something?
I'm a moderator in here.
Oh. Just here, I need all server rooms.
Oh, well, yeah, I can't help you with that.
Really?
Nope.
Nope. Okay.
We are only granted permissions for this channel.
Okay. In the public rooms, I can't.
What do you need your camera for, anyway?
I just want to talk with the camera face.
All right. Well, hey, do you got any evidence for the Earth being a sphere?
What? What do you say?
Do you have any evidence, proof, that the Earth is a sphere, a ball, round?
Oh my god. Come on.
Yeah.
This is just... How can I explain? How you did think the sun is a galaxy?
The sun is not a galaxy. Not in any idea.
Is it a galaxy? Why you did think the sun is not a galaxy? Is it?
Because no one claims that the sun is a galaxy.
I think the sun is a planet.
It's a what?
Planet.
Say that clearly.
planet.
The sun is not a planet. Not in any idea or explanation.
Bro, I'm just joking. Bro, you can't get it again. That's a memes. Some Nick. Oh, can I say Nick?
Well, here. How about you give me something real and tangible that says the Earth
Okay,
is,
I will.
and I'll forgive you for your trolling.
If you travel from United States to Russia, you can fly from the oh, from the blue. Oh my God. I forget what they call. Wait a minute. You can fly from Sia and go to Russia. You know that?
All right. You can fly from
United
Tokyo,
States of
California.
America.
You can fly from Australia to Africa. This does not prove the shape of the ground.
That's the point. If you fly from Australia to United States, you can do it not from the map. You can do it from Sia. So that means like the Earth is the Earth is شو اسمه? Spherical.
You cannot derive the shape of the ground from flying. Traveling is always done in a horizontal direction according to the ground. Airplanes, they take off from the airport, they increase altitude, and they fly level for hours, hundreds or thousands of miles. Level flight. Horizontally,
Bro, do you think the Earth is flat?
above the Earth.
You think the Earth is... You have
Yes.
not
You cannot
knowledge enough, bro. In
shape of the ground
physical and in
from
physicals.
flight.
Thank you. In physicals, they have a proofs about this about the Earth. Is it
Who does?
not flat? And you say no.
Who has that? Who are you talking
And you say
about?
no. It is spherical.
Who are you talking about? Who has the proofs?
شو اسمه Greeks and 3,000 years ago.
The Greeks,
Really?
thousands of years ago, have proved that the Earth.
Greeks, not the Greeks.
What did they do?
Greek mythology, not the Greece. So, Greece, they prove it before 3,000 years. This is not flat. Is it spherical?
What we're talking about is Eratosthenes, and the story is that he assumed the Earth was a sphere. He assumed that all the light coming from the sun was coming to the Earth parallel.
Okay, like
And he
flat can't
assumed that
move.
the locations he went to, and he assumed that he knew the distance between the two, and they were north and south of each other.
You don't think the Earth is
Not the case.
circular?
Listen. It's not the case that the two locations he assumed were north and south of each other were north and south of each other. They were east and west and slightly north and south difference. They were not on the same longitude. He also got the difference in angles from sunlight, right? Because he looked at shadows and got an angle from shadows. He did not measure.
Can you prove this, please?
I'm sticking to this until I've reached the conclusion.
No, you can't prove about if you flying from Russia to United States, you can move.
I know. I've already addressed that. I'm on this now because you said this is the proof the Earth is a sphere and it's 3,000 years old. So, what he did was he calculated based on assumptions, he did not take a measurement of the ground. A lot of his assumptions can have different assumptions and come out with a different result. The Chinese assumed that the sun had diverging light coming from it, and their shadow angles were measuring the location of the sun, assuming the earth was flat.
But NASA says
That's nice. I'm
the
addressing your
Earth
3,000-year-old claim.
physicals, right?
Do you understand what I said about your 3,000-year-old claim?
No,
No?
sorry, no. Was my English?
He's not listening. He's not listening.
No, I'm
He's waiting
listening.
to speak.
I'm listening.
Oh,
but
okay. Tell us what
I
he said.
can't-
Repeat what he said then.
No, I'm listening, but I can't understand everything because English not my language. But
Well,
I
then
can
you say, hey,
understand
I
little
don't
things
understand that.
if
Can you
you say it
elaborate?
in.
Can you explain? And I'll explain, and I'll try to use more clear, basic English.
Okay, thank you.
You're welcome. You just have to ask and say, hey, I don't understand.
Yeah, because you say hard words. I don't know.
All right. Do you know what assumption is? Do you know what it means to assume?
So what?
Assume.
Again?
Here. Check the side chat.
Okay, thank you. Assumption? What? No. I guess you wonder where I've been. I guess you
My use of assumption comes from definition 3. Okay?
statement that is okay.
All right.
How
They made
ironic.
assumptions that are not true. Or you can change the base assumption. You assume,
Assumption, okay. Can I give you
I
assumption
assume that
about
you're
if
a
Earth
man. I assume that
circles?
you're a man based on the bass in your voice. I assume that you you did not learn English as a first language based on how clear you use English words and your sentence structure. Those are my
It's
assumptions.
not my first language. My first language is Arabic.
Right.
Right.
So you understand what assumptions mean.
Okay, I understand what assumption.
You know what I'm saying? Okay. Eratosthenes assumed the Earth was already a sphere. He didn't make a measurement.
If you talk to me in Arabic, I can tell you a knowledge thing you ever know in your life.
All right. Here's something you'll
Many of
understand.
people like you,
In your
I
book,
told him,
in the
and they
Quran,
said,
it
"Oh my
states
God,
that
you have many
Allah
knowledge."
spread out
Sorry,
the
bro,
earth
but I can't.
like a
I can't
carpet.
understand. I can't.
William.
Bro, just let me finish.
William, talking through someone is not really going to aid you in understanding what they're saying.
Okay, bro. Okay, good. Okay, now I will go to exit in the room from the room. Sorry, because I have
Maybe you should
no knowledge
practice
in English.
more English. Come back another time when you. Yeah.
Okay, thank you guys.
That's all right. Oh, you're welcome to just listen too if you want. You're welcome to come back here and just listen if you want.
Okay, I will come here and listen. So goodbye, guys. I'll see you later.
Okay, see you.
Yeah. listening can help improve your English skills as well. Anyway, moving on.
I think it can be frustrating when you can't understand enough of the words to make sense of it. So he was quite polite about it in the end.
Exactly. Also, he wanted to express what he wanted to say in English, but he couldn't find the words.
Yeah. People already have enough trouble keeping their cool talking about this subject.
Thank you for reminding me. Yeah, so as soon as that young fellow was talking, like Jimmy was saying his thing, anything that was said whilst the other fellow was jaw was moving, that's basically his ears not working. So you may as well have just said 3 words, Jimmy, and sat back and just went, okay, mate, go for it. Let's play some white noise.
I'm going to make a prediction. They say flat earthers can't make predictions. I'm going to make a prediction right now that within the next 24 hours, there'll be at least one other person that brings up Eratosthenes, and that'll bring it to a total of 3, if not more.
Well, that was self-fulfilling. You'd done it. You were...
I did. I mentioned it. Oh, shit, no. Excluding myself. And other flat earthers.
Oh, check it out. We've got another AJ. Welcome, AJ.
Hey, thank you. What's going on?
We're just ever so patiently waiting for someone to prove that they live on a globe. And so we can go, wow, we didn't know that. Are you the one that's going to do it for us?
I don't think so.
Why? Because you're a flat earther?
No, I'm not.
Oh. So if you can't prove the globe and you're not a flat earther, what are you?
I don't believe in flat earth. I don't believe in it.
It's not a belief. The globe is the belief.
Are you saying you know that the earth is flat?
No, I'm not saying. I'm not saying the earth is flat.
Then what is it?
I think it's circular. It's a globe. It's not flat.
You think it is, but you're not sure.
It's because about scientific proof. For instance, they've done lots of reports and they've done lots of. They have to prove. Have you seen those pictures? The globe picture.
Mate, I've seen more pictures of that than you could imagine.
No. I mean, when the astronauts they go to space, they take pictures. For instance, they take the Earth pictures.
And you believe
pictures.
them, right? You believe them, right?
Yeah, I do believe them. Yeah.
Why?
It's backed by scientific proof.
Have
And
you examined the
real pictures.
scientific proof?
And
Have
real
you
pic- and real pictures.
examined? Have you examined the
did.
scientific proof?
I was going through, I was reading about it for sure. It's been a long time I read, but yeah, I was going through it.
Can you give us an example of something you read which was convincing, and scientific?
Okay. So these days we have satellites, we have, people go to space. But let's say 1,000 years ago, 2,000 years ago, nobody had a chance to go to space. But they had lots of assumptions. They thought the Earth was flat. It's because nobody knows. Nobody had a proof. Nobody had the technology to go to space. But these days we have it. We can just go there. We can just, using satellite, we can take pictures. We can see.
Okay, can you go there? Can you go there?
No, I don't. I cannot go there.
No. But
So,
other people claim they can, right? They claim they can go there.
With your satellites, wouldn't they have needed to know that it was a globe before putting the satellites up?
Could you come again? I don't get it. I don't get your point.
You said 2,000 years ago they all knew it was flat, and these days they now have satellites to prove that it's a globe. Before they could put the satellite up, before they could launch the rocket, they would need to know it was globe then. How did they know before the satellite?
Are you just saying that 2,000 years ago, some people claimed it was a globe, it wasn't flat Earth?
So this is a story. How do we validate or verify or prove that this story is true?
Do you mean whether it's flat Earth or globe? Could
Your
you clarify
story.
it?
So, okay, let's go right back to the beginning. 3,000 years ago, flat Earth. Everybody knew it was flat. All of a sudden, what happened to change this?
Okay. Let me give you an example. Okay. It's just a general example. Let's say some things we think complicated. Let's say complicated. Why do we think it's really complicated? We are not sure. When it's complicated, let's say we don't have the knowledge about it. When we don't have knowledge about it, we think it's complicated. We try to assume things. We try to, make lots of. We try to make up things. So it's because so we can validate it. We used to do that. We never had a chance to, see the globe. We never had a chance to go out of the earth. We never had.
How did they get from flat to globe?
Okay, I believe when they had a chance to go to space, that's when.
No, they would have known before launching the rocket that has the satellite. So satellite inserted into long tube. We call those long tubes rockets. Before that rocket got launched, they would have had to know, not negotiable, they would have had to know it's a globe in order for this to even happen. Because you can't just go launching rockets up there and pray and then find out, oh shit, we're on a globe, it's a bit freaking late now, what are we going to do? No, that doesn't work like that. They must have already known. So somewhere between 3,000 years ago, everyone knowing it's flat and you telling me about these rockets, before the rockets, what happened? When did it change? How did it change? What did they do to make this change happen?
Yeah, you were right. Exactly. It's because they couldn't just launch a rocket and say, we have a globe. It's not flat. I agree on that.
But you're not understanding, AJ. I'm sorry to interrupt you. The timeline, the historical timeline that you're presenting to us, is that nobody knew. Everyone just thought it was flat until they launched a rocket into the air.
No. Let me clarify. It just like
Thank you. Thank you.
It was a debate actually. So let's say most other people they believed it was a flat Earth, but some people believed it was a globe. But it depends. It was a debate.
Why did they?
Nobody.
Why did they? Why did they believe it was a globe?
It's because some people brought it up. Some let's say some scientists, some people,
But
even
based on
even
what?
even some religion. If you just see some religion, it's been a long time I read that. Some religion brought that up.
Can you tell me? Do they need to know? Do they need to know how much fuel they need to put in the rocket?
If it's a first time, I don't think so. Nobody knows. It's just like they are trying it. To launching when they launched a rocket, let's say like to the space, it wasn't, they just tried it at first time. It just like they tried multiple times.
It didn't
wasn't
happen like that. It
Yeah,
didn't happen
exactly.
like that. It didn't
Exactly.
happen like that. That's
What
not what
do you
happened.
think then?
They needed to calculate how much fuel they'll need to produce enough force, right?
Yeah.
Right, to lift at a certain amount of weight into the air and keep it suspended in the air and propelling upwards, right?
Yeah,
to get far enough away to be able to view the Earth. But they already thought it was a globe.
How do they know
They
that?
weren't trying when they sent up a rocket. They weren't. Their ambition wasn't to see if it is a globe. They already thought it was. They're claiming that their knowledge of the Earth being a globe is what allowed them to be able to calculate how much fuel they'll need.
How do they know that?
What speed the rocket needs to get to break gravity, right, and all that stuff, right?
Yeah.
So your escape velocity, orbital mechanics, right? It's all based on this supposed knowledge that they have of the Earth being a globe already.
How do they know it was a globe?
You tell me.
Maybe it was an assumption. Let's say we never had a proof. We can make lots of assumptions. We can do calculations. We can try multiple things. When we think some things are, if you don't have a standard proof, we try to assume things. We try to validate it with some, let's say, with some information. That's what we did. Maybe that's what they did. They weren't sure whether it was a flat Earth or whether it was a globe. But some people assumed it was a globe, and maybe they were correct.
They assumed it was a globe, and maybe they were correct.
Oh, no. I'm not talking now. It was the time when they tried. That's the time they thought maybe it was a globe. But once they got the proof, they were like, yeah,
Okay,
we are
what
right.
proof?
So
how did they get the proof? So at some stage, you've got a group of people thinking flat, a group of people thinking ball. So
exactly.
How are we going to separate those two? What have they done to separate them and prove one or the other is correct?
That's when they had a chance to go to space. That's when it happened. Let's say
they needed that before then. So you've got this idea in your head that the conclusion to this is space. Everything was done in space. This is incorrect. In order for you to, number one, do this stuff, you must already have proven what you want to do correct before you do it, or it is not going to work. So at some stage, so back in history, a group of people think flat, a group of people think ball.
Yeah.
Something was done to separate this. Not space, before space.
So you're just trying to, yeah. There was a two group for sure. I'm just wondering, without having a proof, let's say, without going to the space, how do they know? Now, how do they? It's like
That's what I'm trying to get from you. You seem to believe that space proved this, that the satellite answered the question. The question should have been answered before the satellites. The satellite is just a byproduct of this proof. Go back 2,000 years. The claim on the table is they thought it was a ball back then. So 2,000 years ago, did they have satellites 2,000 years ago? No.
No.
Right. So we know it's not satellites that have proved this. So we can scratch that one off the table.
So
what did they do that proved? Rockets. So no rockets, no. So what did they do that proved that they were on a ball?
On
a sphere, a globe, a ball.
Okay. So you tell me, how do they get how did they get the proof then?
That's what I'm trying to get from you.
We're saying there isn't any.
No, it's just like, you've seen lots of scientists going to space. Let's say, don't
No,
talk
I
about
haven't. I have not seen that. Neither of you. Nobody's seen that. Never, never, ever.
How about rockets?
No, we've seen rockets go into the sky.
Really? You never seen rocket going to space?
No, I've seen rockets on TV go into the sky. I've never seen a rocket launch in person.
Yeah.
I saw it go into on TV. I saw it go into the sky.
You should see it in person. It's a good time.
Thanks, Josh.
So it's just like, if you don't see it, let's say in person, if you don't see it just by yourself, you don't believe in it. That's what you're trying to
No, I'm saying nobody sees it go to space. They see it go into the sky.
We have lots of space videos. If you just like Google it, if you just go on YouTube.
Cool. So how do you know where that footage was taken from?
You know about NASA, like the United States has NASA.
Right.
So
just because they said so, right? So that because they said so, they said we went this far away from the Earth and we turned a camera on, and here's the footage. Is that all? Is that it? Just someone said.
It's not about only them. It's about about Russia. Like Russia, they tried it as well, and China, they tried it. Okay. Multiple countries tried it. How do you not believe?
Yeah.
Like if there are multiple countries trying to justify it.
Yeah. So you have multiple corporate jurisdictions trying to give the illusion that they're going to a place called outer space. Does that mean that outer space exists because you saw it on TV?
Okay. Let me. I can ask you lots of things. Sometimes we have to believe in some things.
We don't. I don't have to believe it.
Okay, let's say. So you have.
What's the critical point? If we don't believe it, what happens?
okay, if you don't see something, uh, what I get from you, like let me be honest. What I
I
get
need to
from
know the
you,
critical point. You said sometimes we have
yeah,
to believe things, and you're putting this into that category where it's a necessity
yeah,
that we must believe it. What happens if we don't?
yeah.
Or what?
Let me
Or what?
let me give you an example.
Why
Let's
is
say,
it a necessity? Why is it necessary?
okay, so sometimes we believe in things. Some people say, let's say, I have mom and dad. Okay, so I have a let's say I have a elder brother. So when I just when I came in the world, I never knew I had a brother. But my family told me I had a brother. I have a brother. So that I believe in it. If they never told me, how could I believe that? I haven't seen my brother. He was, already in the world. So
I think
some things.
this is a good analogy. I like what you're saying. So you believe something even though you've never seen it. But is the government the same as your parents? And in this scenario, wouldn't you actually ultimately need to see your brother and touch him?
Say it again. I don't get it.
Wouldn't you eventually actually have to see and touch your brother? Otherwise, it just stays a belief the entire time, right?
Yeah, it's just like if my parents never, let's say, if they never told me, how could I know that's my brother?
Well, you actually don't know that you have a brother because you've
Yeah,
never seen him
yeah,
or touched him. It'll always be a belief. So with,
exactly.
this idea of outer space, you've never been there, you've never seen it. So how do you know that outer space exists? You believe it, which is fine. You're allowed to believe that, but I don't have to believe the same thing that you do I?
Yeah, yeah.
It's not necessary. It's not. It's
That's
not
for sure.
necessary. You said we have to. You said sometimes we have to. Or what?
Yeah,
We must. It's necessary. Or what?
sometimes we don't have the opportunity to,
What happens if we don't believe it? Why is it a necessity? Why is it needed
don't
to believe in it?
if you don't believe in it, it's
Yeah.
just like some things you just
Will
you
it have a
don't.
negative impact?
No, I don't think.
There's a cause and effect and relationship. If you have to believe in something, there will be a resulting action if you do not believe. The boogeyman will jump out from under the bed. Something will happen if you don't believe. So you're telling us we have to believe. Why?
Oh, there's we humans have bias, lots of biases. Like one bias,
Agreed.
it's called conservatism bias. So when it comes to conservatism bias, people don't change their opinion.
We're not talking about biases. We're talking about the necessity for us to believe. What will happen if I say, no, thank you, I don't believe? What will happen?
Okay, let me give you an example. Okay, you don't believe in it, so you just think, do you believe in space? Let me ask you the question. Do you
Okay,
believe in
how about we just clarify something? Is there a difference between believing something and knowing something? In your mindset, is there a difference?
You mean believe in something, knowing something? What do you mean exactly? I don't get your point. Okay,
Is
so
there a difference?
as example, right? Do you believe in the size of shoe that's required to fit on your foot, or do you know what size shoe you need in order for it to fit on your foot?
I have to try that, because if I don't try that, how do I know?
Well, okay. I'm assuming that you're old enough that your feet don't grow anymore, and that you know automatically when you go to the store, I need this
Yeah,
size in order for it. Okay. Do you believe that size, or do you know the size?
I I know the size. It's because like over the course of time, yeah, obviously, like my my food won't grow, so it's just the same. So
Okay.
I know my size.
All right. Before you measured your height, uh, did you know how tall you were?
No, no,
Okay.
I didn't know
Um,
that.
after you measured your height, did you believe that height or did you know that height?
I know the high.
Okay. So when we say we know the earth is flat, it's the same thing. We've measured the earth and we notice there's no curvature, so we know that it's flat. It's not a belief. You, on the other hand, are believing the earth is a sphere, but you don't know any um, proofs, or you're not presenting proofs to show that the earth is a sphere. You've never measured the ground to identify whether or not it is or is not a sphere, but you accept that you was told that it's a sphere, and so you're believing it's a sphere. Do you see the difference?
You have the proof. You're just saying you measured it. You have the
Yep.
proof, and have you really tried it? Like, have you just like have you
Yes.
just like measured the whole earth? How did you do that?
Necessary to measure the whole earth.
Yeah. How did you do that?
Okay.
Just show us the proof. Yeah,
I was
show us
in
the
the,
proof. What did you do?
I was in the, yeah, I grew up in the same system you did. I went to the similar school systems where they taught me things like math and
Mm,
how to read. And then I went
mm,
to a science class and they told me some things about the earth and the things around me. And amongst
mm,
those things, they said that the earth was a sphere. And then they say that the earth has radius value because it's a sphere. And then they tell
mm,
you that the radius value is 3,959 miles. And from this, using geometry, they can build everything else. They can give you a diameter to the earth. They can give you the circumference of the earth. They can give you the surface area to the earth, right? All because they have a radius value. Okay. Now,
mm.
the distance to the horizon with the sphere with the radius value of 3,959 miles can be calculated using 1.2 times the square root of the observation height in feet. This will give you the distance to the horizon in miles. Okay. Now, when I was in belief of the globe and I wanted to test that belief to verify whether my belief was true or false, I went out and I looked for an object in the distance, right? So that I could identify how far I'm seeing. And then I use the equation 1.2 times the square root of the observation height in feet. And that gave me the distance to the horizon in miles for that size radius, right? Now, the horizon was beyond the object that I noticed in the distance. For me, I was on a bridge and I looked out towards the mouth of the river, towards the Atlantic Ocean. And on the right side of the river was a pier. And the pier was about 11 miles from me. And so the distance to the horizon was beyond the 11 miles. Okay. Because the horizon was beyond the pier. I could see the pier and its base. Okay. Now, according to, my height above the water, about 15 to 20 feet, I can calculate the distance to the horizon, which I want to say is about that. I could use a zoom to try and see any objects beyond that. Maybe I could see a boat. People have done this for themselves. Okay, you can do this for yourself also. A lot of people, they shorten their height above sea level and look out across the water because they was told that water conforms to the shape of the sphere due to gravity. So then the water would be the perfect location to try and identify curvature of the Earth because the water is perfectly conforming to the shape of the sphere because of gravity. So some people decide to look 1 foot above the water, which if you're 1 foot above the water, the distance to the horizon should be at 1.2 miles. Others are putting their cameras on tripods at 3.5 feet and looking out. That puts the distance to the horizon like 2 miles and some change. Some people are 6 feet above the water. That puts the distance to the horizon at 3 miles. Some people decide to get on the plane, and that's anywhere between 212 miles distance to 250 miles in distance. And people are seeing at those altitudes 700 and 1,000 miles away with infrared lensing. So people are seeing the horizon being farther than the geometric claim. Okay, that's measuring the surface to try and identify the curvature rate. There's one instance where the guy puts the camera 1 foot above the water and looks out at 2 oil rigs, and you can take the height of the oil rig and the angle to the height of the oil rig and your height above his height above the ground, 1 foot, and derives the radius value of 200 and I think it's like 64,000 miles when the radius value is 3,000. So people just going out and making observations, they're finding radius values that are orders of magnitude larger. That's what I mean by it being measured. Does that make sense?
You mentioned some mathematical calculations. How did you get the radius?
Well, the globe claim for the radius is derived a handful of ways. Typically, they say, well, this person did this method. Eratosthenes, for example, assumed he was on a sphere and that light came in parallel from the sun, and he went to 2 locations at the same time, not really at the same time, and he was able to
Did you take the radius? Did you take the radius? Did you take the radius by yourself?
I told you what I did.
He doesn't
Right?
understand.
No,
AJ, at school, that's the radius they teach you the ball is. So we're using the informations we are given at school. We are testing that information to see if true or false. That is all that's happening.
Right.
Do you believe in the radius you have? For instance, he mentioned.
Okay, it does not matter if we believe in it or if we know in it. We are given a number at school. They are the ones that give us the number. Where they got it from, I don't know. Please go back to school. Feel free to ask your teacher. They gave us the number. Right. So the second part. Okay, we've given a number. The second part, we go and test the number to see if the number is right. Now, if the number is right, we live on globe. If the number is wrong, we don't live on globe.
Okay. The first question I asked him, have you measured the globe? He said yes. He said he measured the globe because he had some values. He did not, measure it, but he had some values from, let's say, from school. So
Yes.
So if you haven't done it by yourself, it was given by someone else. It's just
Correct.
like you're believing it. You're just believing that they did the right thing.
Bro,
Agreed.
we're not believing the value. We are testing the value. Somebody else gave us the value.
Yeah. So let me ask you that question. Do you believe the Earth is flat?
No, we know it's
No.
flat. We've measured it.
Okay, so you don't believe that the Earth is flat, and you don't believe in the Earth is globe. Am I right?
Okay, this is why I questioned earlier. Do you know the difference between believing and knowing? Because they are two separate things.
Yeah,
Do
yeah.
you believe
for
in
sure.
Santa Claus or do you know Santa Claus?
Yeah, exactly.
Exactly. Right. So you understand there's a difference between believing and knowing. And watch this.
Yeah.
Who we've got? Jimmy, do you believe
Yeah.
the Earth is flat or do you know the Earth is flat?
I know the Earth is flat. I do not believe that the Earth is flat.
Okay.
There you go.
Yeah. So he said he
I
knows
know my
the Earth.
shoe size. I don't believe my shoe size.
Okay. So how do you know the Earth is flat? It's because like when Jim said, let's say, he said he had some values, right? Radius. So he you guys are just saying you were trying
No,
to
no,
test
AJ, you're missing the point. You were taught something at school. What were you taught at school?
it.
You were taught things at school about the Earth. What were you taught at school? What did you learn at school about Earth?
When I learned, they said it was a globe. I wasn't
Excellent.
sure about.
Now,
Yeah.
that's all right. Did they back that up with any empirical data, or did they just say you live on globe and you should accept that? And they give you no more information.
No, they had some data for sure. They had some scientific data and
They had some scientific data.
Yeah.
In a geometric discussion. That is amazing. So what data did they back it up with? Maybe a globe sitting on the table, a map on the chalkboard.
Okay. Before going into it, that's the reason he said he
No, that's the reason why I'm questioning this. The reason I'm questioning this is because you've missed the point. You keep referring back to the data. The data. He must have got the data from somewhere. He did get it from somewhere. The same place you did, from school. So what we're doing, we're grabbing the data and then we test the data to see if true or false. That's all that's happening.
Let me tell you one thing. Let's say I'm mistaken, okay? I'm wrong. So I'm wondering whether you guys are saying the Earth is flat, okay? I'm trying to find it. I'm just trying to find it, whether it's true or not. It's because you guys are trying to say, I don't.
Well, the only way you're going to find that is to go and test it for yourself. It doesn't matter
Maybe
what I say.
No. To test it by myself.
You able to clarify what I'm saying?
I have to do the measurement. I have to go and do the measurement. I have to do everything by myself to believe.
You can get help.
You don't have to.
Yeah.
You don't have to.
No, if you don't, let me just.
No, let me clarify because I've been trying to clarify and you keep dragging the conversation down the street. I'm wanting you to stop and wait for a moment, okay? Whenever I said they gave me a radius value, right? The method I use to verify that radius value to be true is to take the claim that's being said, which is objects in the distance disappear bottom up due to the geometric shape, right? This would be where the horizon is, where the earth and the sky appear to meet, okay? So that's why I said the horizon is the thing that I'm looking for, and I use an object to identify the distance to the horizon, okay? Now, I've noticed where the horizon was beyond where the geometric claim should be, okay? Now, I know that the Earth is flat because I watched the horizon change distance, okay? So when the horizon, listen No, hang on. Because the horizon changes distance, I then either have to choose one of two. You could maybe make your own third option. The Earth is expanding and contracting because the distance to the horizon is changing. Or I'm looking over a flat surface and watching the horizon, which is an apparent thing, change distance due to different reasons, not due to the shape of the ground.
And what about the observation errors? Like the horizon test is the main test to check if the Earth is flat or round.
This is the
And-
means in which to do that. This is a
and
direct
like,
measurement. This is not me looking at something and making a correlation and assuming. Okay. Apparently, I see the ground and the sky meet into the distance, right? That would be the horizon. By definition, that's the horizon. Okay. Now, sometimes we see things disappear bottom up. Sometimes we just see things become too small and we stop seeing them altogether. Sometimes
Mhm.
weather causes them to disappear into the distance. What I'm verifying is when the object disappears bottom up, that's the horizon. Is that due to the shape of the ground, or is there another reason that would explain what's happening?
what's
So-
the reason?
I assume that that is going to be due to the shape of the ground. Now, I need to verify the distance to the horizon so that I can
Where's the
make
baby?
sure that the math is accurate, right? That is why you pick an object in the distance of known distance, and then you reference the horizon to that object, that distance.
You gotta fill it up then. Take the thing off. Take the no. I'm gonna teach you how to.
Josh, hot mic. Josh, hot mic. Does that make sense, AJ?
No,
No,
really, it doesn't.
You understand that there'd be a consequence, necessary consequence of the Earth being a sphere with a radius value of 3,959 miles, right? There'd be a necessary consequence of that figure regarding the
What is the
horizon and the
consequence?
distance. The distance to the horizon would be a necessary consequence. Specific
Yeah.
distance.
Mhm.
Well, the tactical
Um,
droid here is pointing out that he's observed the horizon distance not conforming to that claimed geometry, and in fact, it changes.
Yeah, and I'll say observation.
If it changes, how do you know that it's the exact radius number? So how do you just say that? Like, it's because it seems like we are
It's a-
assuming it.
That's why they're testing it.
Yeah.
Well, okay,
No, we don't
let's
live on
try
a
another
globe.
one.
He's not
If I
getting
tell
it.
you, AJ, that my table is 6 foot wide, how do you test that?
It's because, let's say you have table. If
Yeah.
there's a table,
It's right there.
we can just see the whole table. With
Yeah.
your eyes, you
Yeah.
can just see that.
But how do you test that? The claim on the table, AJ, the claim put forward is 6 foot. How do we test that? It's the 6 foot we're testing.
Okay.
How do we test that 6 foot claim? It's like at
Okay.
school. They've given you a number, and what we're doing
Yeah,
is
because
testing
it's
that number. How are we going to do that?
Because
Okay.
it is used by a thing called as an absolute metric, where you have been using the
V.
foot as a metric.
Hey, V, your name is not AJ. AJ was
Oh,
answering
sorry.
this, not V. Thank you.
So,
So, AJ,
Go ahead.
number on the table is 6 foot. How are we going to test that?
let's say two things. Before answering these questions, I have to tell you two things. So, to know exactly, I have to, let's say, go and see the table and do the measurement. Then I know it. the other thing.
No, I'm not worried about seeing it or knowing it. I'm asking, how are you going to test it? And you've already said the word. You're going to do what?
Yeah, I'm going to see the table. If there's a table, I would go there.
And seeing it, how does seeing it verify that it's 6 foot?
I would, obviously, I do have a measurement, tools.
You have to measure it. Excellent.
Yeah.
That's all I wanted you to say. In order to validate or verify a numerical claim, and that's what's on the table, a claim, you measure it. Excellent. And that's what these guys have done with the ground. If there's a claimed radius, there would be drop over distance. So, for example, a tangent to a curve or a tangent to a circle. From that tangent, as you get further and further along, the gap between the straight edge and the curve gets bigger and bigger. And that's what they're measuring, that gap over distance.
Okay, so let me ask you a question. So the thing I told you, it's a table. You mentioned it's a table actually. So I told you I'm gonna go there. I see the table
and measure it
in front of.
We're not worried about you seeing it. It was the measuring it. That's all we were worried about, my friend.
Yeah. I'm measuring it with measuring tools for sure. So I know exactly it's 6 feet, like 6 foot, like whatever. I can see that. I can, I can see the information in front of my eyes. When you climb, you measure the globe, like measure the earth. You just say, you just take an object and you try to, based on the object, you try to measure the earth, the distance, like the distance to the horizon. So it's just like, let me ask you, can you see the whole earth by your eyes? Can you just see it?
I don't see the relevance of that.
No, it's because if you cannot see it,
this has got nothing to do with measuring the ground.
Yeah, that it has to do with that.
No, it does not.
In this situation, the whole table is the horizon. That's the end of the end of the table, the horizon.
It's just like, I'm not assuming it. I'm not taking an object and doing the measurement or calculation. I'm just going in front of the table. I'm having a measurement tool. I'm measuring it. So when
that's it. So you're measuring it. What that story was about, AJ, I'll make it nice and simple. That story, that analogy, right, was about you measuring something. Somebody puts forward a claim. So my claim was 6 foot table.
Yeah, exactly.
Right.
Yeah.
So somebody puts forward a claim, and then how you're going to test that claim. And you said you were going to measure it. That's correct.
Exactly.
That's how you test claims that are put forward. So at school, the claim put forward was we live on a ball with a radius of 3,959 miles. So how do we test that claim? We go and measure it. And that's what these people in this room have done. They've gone out and measured it. They're expecting to find the ball. They're expecting to find the curve. They're expecting to find that we live on a globe. All of a sudden, they do the measurements and it's not working. Why is it not testing like a ball? Why is it different? What went wrong? And then they find out there's no curvature at all. So if there's no curvature at all, we can't be living on a globe. We can't be living on a sphere. Not possible. That's why they're testing this.
So let's say Matrix tells you that he has a table that is oval shaped and it's 6 feet long. And you go over and you look at his table and you measure it and you see that it has, it's actually 7 feet long and it has 4 square corners. So by necessity, it must be either a square or a rectangle. And it is also not the size that he claimed it to be. So you've debunked both of his claims just by measuring and making an observation. So the globe has given us a claim size, a radius value, and we went and checked to see if that was correct. And guess what? It is not the size that they claim. It's totally bogus, right? So we have went ahead and debunked the claim that the Earth is a globe. The size of the Earth, we make no claims. We're talking about the surface and the description of the surface being flat, horizontal, level.
So the radius you got, 3,959 miles, was it was it true or false? Like, it's because you guys had tested it.
False.
Okay, so then what's the right answer?
Not a sphere.
The right answer is it's not a sphere. It cannot be a sphere.
No.
In fact, the horizon is not even the curvature of the Earth. We've also debunked that claim.
Okay. If you was in class and they asked you the question, what is the radius value of Earth? And then they gave you multiple choice, 3,959 miles, 10,000 miles, 264,000 miles, or 5 miles, which is the correct answer. If you choose 3,959 miles, then you would answer that question correctly. If you go out and you check for that radius value by taking measurements, you do not find that radius value in your observation. Therefore, it's false. If you're checking the radius value according to the claim, then it is correct according to the claim. If you're checking it to observable reality, it is not correct. So which form of is it correct are you referring to?
Let's say, to figure it out, have you done a hypothesis testing?
Okay. I need you to open up your Google or whatever search engine you like to use and ask it for an equation to the distance to the horizon. Or you can ask it, is 1.2 times the square root of the observation height in feet a valid equation for identifying the distance to the horizon?
So do you think, let's say, do you know it's a valid distance?
Yes.
Valid equation?
Ask the search engine if the equation is valid. 1.2 times the square root of the observation height in feet equals the distance to the horizon in miles. Ask if that equation is valid. Let me know what it says. Because I've asked and I've taken a screenshot. And if you need me to post the screen.
Yeah, let me take a look at it. Just a second. So the formula, it's x is equal to r minus r cos.
Okay, you're assuming R already. We're trying to validate R. Okay. This is what we
Radius,
do.
yeah, for sure, yeah,
Validating
yeah. We are trying to find, radius, yeah.
So I can't use an equation that already has R.
You can just reconfigure it. Let's say if you just take the formula the other
Can somebody
side, and
ask- Because I can't post images and I'm home.
so let me ask you: do you think the formula you just sent is it you or someone else? Let's see. It was sent by Matrix. So can you see the last picture he has sent?
So what are you asking? Us to validate the claim that we're given in school? That is what
No.
we're doing, my friend.
No,
Hey,
no.
AJ, I just want to just let you know, like, all the people who argue for a globe, they don't deny the math that the guys are giving you right now. They accept it. They say that is the math for the globe that we live on, and that is the size of the globe we live on. Are you arguing against that? Nobody denies it.
No. I can get that. Everyone has a different. They think
No, they don't. That's what they don't have a different. That's what I'm saying. There's no different.
The people I see here, they think they know exactly. Let's say, like exactly, the distance, the equation. They have a. That's what they are trying to say. So I'm trying to find out. I'm trying to find out the thing they are saying. They know that, whether they know that by themselves, it was given by someone else. Let's say if they are talking about any equation, they're just trying to think if they get any value from the equation, they think that's true. They think they know that's the right answer. So I'm trying to find out whether whether they are trying to say, is it true or not. That's what I'm trying to figure it out.
Yeah, but the distance to the horizon for a globe isn't a flat Earth thing. That's something that has to be there on a globe with the size that they give us.
Okay. If you know the Earth is flat, tell me why. But
It's measured flat.
if you just talk about if you talk about calculations, for sure you must have
Measurements.
equation.
AJ, measurements, not calculation. Measurement, different.
Measurements.
Okay, so for your formula and equation, you have numbers. Those numbers come from somewhere. Where do those numbers come from?
Yeah.
Okay,
Yeah,
excellent. So we agree. We agree, 100%. So when they tell us radius 3,959 miles, that means someone has measured from the middle of the Earth to the outside. Do you believe that?
No.
Excellent. Yes. Now we're starting to get it. Nobody's measured that. That's right. Nobody.
I can say I can believe in it, but I cannot say I know that. The difference. That's what I mean. I can believe in
Excellent.
it. But
in the side chat, AJ, let's go back to the side chat. See the one that you wanted everyone to look at with the big sphere on it? You can see that? The tube up above that. White images that say laser, deviation, one says curvature, one says no curvature. At 47 minutes past the hour. That's when they were posted.
What are you referring to? I can see lots of informations in the chat.
Okay. This idiot here can go away. Get off. Go right to the bottom. Now we're going to scroll up. One of them has a sphere with a chart next to it. Then above that, there's two images side by side. White. Timestamp, 47 past the hour.
Okay, 47. Could you just resend it if it's possible?
Guys, it won't be the same for everyone. Everyone has different time.
Yeah. My time is quite different.
Use the last two numbers.
47 past the hour. Unless you happen to live in there's a certain spot in the middle of the United States that has an offset, half-hour offset, you're probably going to be the only ones that are not going to get this right.
Just try to get the let's say get the post and resend it again.
Okay, AJ, let's just do this. 1, 2, 3, 4, 5, 6, 7, 8, 9 posts from the bottom.
Okay.
Exactly.
1, 2, 3, 4, 5, 6, 7, 8, 9. Has anybody accepted?
No, I'm not asking if you're accepting it. I'm asking if you can see the images inside chat. We just want you to get there first.
I can see some YouTube videos there.
Okay, you've gone too far if you're looking at YouTube videos. So underneath the YouTube videos, two white images, side by side.
Yeah.
You may be on your mobile phone.
I can see that. I can see...
Excellent.
Curvature. Deviation.
That's the one. That's the one. Excellent. So see how on the left-hand image, it shows laser, deviation, curvature.
Yeah.
And on the right-hand image, laser, deviation, no curvature.
Yeah, I can see both.
Right.
Yeah.
So on the left-hand one, when the guys go out and do the laser tests, that is what they are expecting to find. Now, the measurement is the deviation. That's the bit that gets measured from the laser to the ground. Now, what happens when they do the laser tests? The second one, the second image, the right-hand side. That is what they find when they do the laser test. Now, if you want the laser test, scroll up a little bit more. That's the YouTube videos that people have filmed themselves doing the laser tests.
Did you just say, let me ask you one thing. Did you just say deviation means measurement?
No, deviation does not mean measurement. The deviation was the bit that is getting measured. That is what they are measuring for.
Let me watch the YouTube video then.
Yeah, there's quite a few. And there's plenty more if you wish to see them. And it's not just one video, there's a whole string of them there, my friend. Welcome, Cyclone. Nice of you to sneak in the back door there.
Yeah, what's up, guys? How you doing?
Oh, not too shabby. Our little friend here is just having a bit of trouble understanding.
Nothing new.
We've also got V in the chat. V,
Yeah.
piped up earlier. You can ask your question now while our friend is looking at the videos.
Yeah, I'll say that if you are trying to do the horizon test on land, then you're already wrong. Horizon test is supposed to be done on the sea or the ocean. Because if you're calculating the what was that route to RH, so it depends on the height. That's why the sea level is taken as the basis for this test, horizon test.
Yep, that's correct. That's what we do. We use a sea horizon. Good job.
Already switched on. So I take it you're a flat earther, V.
Nope, I'm not.
Oh, why not?
Because like I have been to the sea and I've calculated, because I did that in my physics major, and
You calculated. Say again. You calculated.
Yeah, what we did was we calculated the distance to the horizon, and then we calculated the deviation from it for the laser.
That's weird. You guys are in a physics class looking at the horizon of the Earth.
No. It was a project that we did just to prove that actually the shape of the Earth is not exactly a sphere; it's a spheroid.
Okay, so let me get this straight. You used a laser, or you were told about this? You actually went out and did this, or you just told a cool story?
We were given like obviously we didn't have that much of a strong laser, but like what we used was the already the this value of the horizon, and we used
So
the
you
laser.
calculated the distance to the horizon, so based off of your height. So, for example, 1.22 times the square root of the observer's height in feet, 6 foot tall. What's that? 3 miles?
Something like that, yeah.
Something like that, yeah.
But it was correct that time.
So, how did you validate that distance? That's the bit that I'm interested in. You've done the calculation. This is where the horizon should be. Now, what did you do to prove that the horizon was in the spot that it should be?
Oh yeah, this is called as a parallax method, in which you can get a rough estimate of the horizon.
A rough estimate? No. We don't want a rough estimate. We want to guarantee that it is where it is claimed to be. We don't want rough estimates.
Like, yeah, you can be off by a meter or so, but it won't make a difference.
Oh, that's awesome. Hey,
that's good then. 1 meter? Yeah, that's good. 1 meter, that's
Matrix. Yeah, Matrix. I was going to say 1 meter. That's pretty good. So what they did was they calculated where that horizon is. They calculated. You heard them tell you that. And then they all sat in a class because they didn't go anywhere. They just sat in a classroom and calculated this. And that's how they figured out the Earth is a ball. They didn't go out and measure. They don't measure things because it's physics class. They don't measure anything. They don't measure anything in physics, do they?
Because obviously people measure things in physics.
That sounds interesting.
Well, you verified your
we better run another physics class.
Yeah, you verified your calculations then, right? Like a real scientist.
Yep.
So who went out to the horizon line? You or the other person?
Nobody did, because you don't need to go
so
to
that was the end of it. That's the end.
Yeah.
So it was not verified. So that's what you're saying, V, is because no one's gone there to validate that or to prove that what you have calculated. So you have done the calculations. That's awesome. But what you've got to do now is go and prove that the calculations are correct. And this is, from what you've said so far, this has not been done.
Okay.
Did you have a distance marker to validate the distance?
Do you believe in Pythagoras theorem?
V, did you have a distance marker to validate the distance? Since nobody went out to the distance?
Like, why would you want to like actually verify the distance? It's simple math.
So you know your calculations are correct.
Yeah,
See if it's
How
true,
did you
'cause
know?
what if-
Okay, V.
Yeah,
Let's
exactly.
say
What
you
if it wa-
messed
what
up
if it
your
wasn't?
calculations. Let's say you made a mistake with your calculation. How do you then test and see if there was a mistake?
I'm curious, V, why did you say, why would you want to verify your calculations? You know,
Like,
what I do for a
obviously.
living, if we don't verify our calculations where I work, people will die. So we have to verify our calculations.
No. You're over exaggerating. If my reason for the research is to calculate the deviation of the laser, I don't need to verify the distance to the horizon.
Well, we were talking
Well,
about.
that's
the
what you
horizon,
were
and
verifying.
saying you were calculating
we
the
were
horizon.
calculating the
And then
deviation of
you
the
had
laser
a
that came out right.
you had a question asked to clarify what you were saying. Did somebody go out to the horizon and validate? Hey, this is where the horizon is. And you said no.
Okay, so like
So then I asked
you guys,
again: was there like a marker or an object in the distance that y'all used as like, verifying the distance that you're looking?
okay, so like,
And then you're saying
you
I
guys
don't
have
need to
seen.
validate the distance. Then what? All you're doing is putting a laser across a flat level surface of water, and then watching the laser travel across that horizontally. And then you're saying, okay, well, I'm allowed to have a meter of deviation. All right. Well, how far away was the other end in order for you to say, yeah, this was actually deviating a meter? And was it like 10 miles, 20 miles? Were you 13 miles? Were you a mile away and you had the meter
Hey,
deviation?
Jimmy, it sounds like what he did was prove the Earth was flat because he shot a laser over a flat surface, he said. Thank you, V. Congratulations.
No, I didn't.
So then tell me how far away the other end of the laser was from the laser, and you had your 1 meter of variance.
I think it was around 4 kilometers, something like that.
What kind of laser did you use? What color was it?
What color was it?
Hang on.
Yeah, the frequency matters.
I don't recall the color.
Nobody did a laser test.
Yeah,
Sure.
Or V, maybe you could
try to lie to us,
run
bro.
us through the formula.
Yeah, like.
V, do you remember what the
test I
formula
did
was
2
that
years
you
ago,
used to calculate this?
All I remember was the test was right. I don't need to remember the
How did you
specifics of
verify it was right? Who went and verified your calculations? Nobody?
You don't have to reach the end of the.
You do have to verify things or people can die in real life.
Yeah, like that's why GPS system works in this world, right?
Hold on, brother. So here's the thing. Who was at the other end of the laser measuring between the surface of the water and the laser beam? Who did that?
Sorry, can you repeat?
In your laser test, who was at 4 kilometers measuring the deviation between the beam and the surface of the water?
It was someone of the staff, maybe. I don't know.
You don't even know? So somebody was there and they added the deviation between the laser and the surface. Okay, so how did they do that?
Shit, I remember the color of paint from machines 2 years ago.
Yeah, but I don't, because I don't work in that field.
Oh, okay. So how about this? How about, since instead of you giving us nothing but hearsay, can you provide us the documentation of what you did?
Oh, yeah. I think I can.
Okay, just go ahead and post that. Okay. It was only 2 years ago. I'm sure you still have it.
Yeah. I think I have it.
I have a question.
Give
Is
me-
that right? Would you take it in the chat?
Sorry?
I have a question. I just wrote that down. The things you mentioned. So far, is it right? To my understanding, I'm just wondering.
Yeah, we've measured with lasers. We've also just measured with distance. Distance demarcations.
Okay, when you say distance, did you measure the Earth from one end to the other? From one.
Sorry. Dude, why are you doing this? Are you trying to troll us at this point? Did I tell you that we measured the entirety? Okay, so if I didn't tell you, okay, so why are you asking me a question about something I didn't say? Are you not listening to me?
Maybe I missed your point. I couldn't. Maybe.
Yeah. We measured distances between points. I at no point said that we measured the entire Earth.
Yeah, that's my questions. Did you measure the entire Earth?
Why would we do that?
Dude, he just said he didn't do that, and then you said, well, let me ask you a question. Did you measure the entire Earth?
Okay,
Exactly.
okay.
We're not trying to.
Okay.
We're not trying to measure the dimensions.
Okay, so
size.
you have never done that. You have never measured.
Neither have you. You didn't even verify your
It's not
calculations.
necessary.
Yeah, I haven't. Yeah, I haven't done that.
It's not
that's what I'm
necessary.
trying to
It's
say.
not. Hey, relax. Hey, relax, man. It's not necessary. We don't have to in order to know that the surface quality is horizontal.
Yeah, I can just say it's not necessary. I can just say that the.
No, I'm not just saying it, bro. It's not a necessary thing that we need to do. It's not.
Why would we need to measure the size of the Earth when we are only dealing with the surface description, flatness, usually described between two parallel planes? So I'll tell you what, I think the tallest mountain in the world is somewhere around 7.5 to 8 miles high. The deepest trench in the ocean is somewhere around 8 miles deep, as far as we can measure. So the Earth rests between those two parallel points. 8 miles above mean sea level, 8 miles beneath mean sea level. It is a horizontal plane. It is flat.
But what if you have, let's say, you just measured something under the ocean, right?
Yes, from a horizontal datum. Yes, called mean sea level.
Okay.
We've measured the depth.
Okay. It just because you measure up to that point. What if you have like more than that? Let's say if you have how much kilometers or miles it was, like when you got the data you measured underneath.
What's the question?
So you say you measure the tallest mountain.
AJ, you're super confused right now.
No, I'm not confused. Like I'm getting.
This is where the physical. One sec, bro. One sec. Relax. This is where the physical properties of water comes into it. Okay. All right. So we can understand that the nature of the surface of water when it's at rest is horizontal. There's no deviation from horizontal. All right. It's actually a reference to horizontal. You can use liquid at rest to establish a horizontal plane of reference. That means that in building and in construction, right, in engineering, you can use water to establish that two things are at the same elevation in a straight line. Okay? That means that the surface of the water is not curving. It's flat. It's level. It's horizontal.
Yeah. That's not my question.
If we can establish that over a short range and then a larger range yet again, it's okay to then infer that the rest of it is going to conform to that as well, especially when we've measured it over large bodies of water such as like 20 miles where there's no deviation from horizontal. right, over large lakes where you
It's
can
not
just
my
see straight
question.
across to the other side from shoreline to shoreline and shine a laser directly across its surface and hit a target on the other side.
It's not my question.
Okay. Try again then, I guess.
Oh, someone just mentioned we human measure the tallest mountain.
Okay,
And
AJ, you got it confused. What he said was, because we don't have to use mountains and valleys in the ocean to get mean sea level. All he said was, there's a tall mountain and there's a deep ocean, and in between there is about where mean sea level is. That's it. That's all. Yeah. We can just average it out. We can go paint a line on the side of a rock that's in the water and call that mean sea level. And then the next day the tide changes and then there's another one and it's slower. You can paint one there. And then the next day it's higher than both of those. Paint one there. And then what you do is you count the distance between them and average them out. And you'll get the mean sea level. If you keep measuring that over and over, you'll get it closer and closer to the actual number 0 of mean sea level. Of course, you can never hit 0, but you'll be close enough.
Get an average. And did you know that mean sea
you can never be accurate.
It doesn't matter. Mean sea level is actually a horizontal plane of reference.
Yeah, you're accurate within a meter, like your buddy said, within a meter. He's like, within a meter, you're golden. You can fly to Mars. So we're way within a meter.
Yeah. Extending hundreds of miles inland, we're gauging the elevation change of the land mass in relation to that horizontal plane of reference from sea level. So when you go 100 miles inland and someone says that mountain there is 1,000 feet above sea level, that means that the base of it, from the base of that mountain in a straight line out to the sea, that's its height.
I fear we may have just confused him.
No. I'm just like nobody answered the question I asked. I was just asking.
Ask it again. Maybe we misunderstood you. Go ahead and.
Yeah, it's because you were trying to say about measurements, everything. I get it. I get the point. But when it comes to, let's say, measuring, you say you haven't measured the entire Earth so far. Yeah.
No.
So, yeah, if you haven't done that, it's like an assumption. You can just say you're just doing calculation. You are taking an object and trying to measure it.
Okay, stop for a second. Listen to this. Okay, if the Earth is a globe, okay, they tell us the size of the globe. If the Earth is a globe and we have 20 miles of water, okay, a section of 20 miles, we can calculate how much curvature there should be over that 20 miles.
I'm not saying the Earth is globe right now. I'm just trying to find out.
We're not claiming to know the size of the
He's
Earth.
not saying you. Just listen to DJ for a minute. Please don't interrupt him. Just listen.
We're not claiming to know the size of the Earth. We're not claiming to know the shape of the Earth. The globe Earthers are claiming to know both of those things. When we test it, it doesn't match reality. Okay? So there is no globe. The Earth, right, is a flat stationary topographical plane. That's what we experience, and that's what we test it. That's what it. The results show every single time.
The thing I'm trying to say, there's no flat Earth.
What are you talking about?
It's because you say you measured it.
We're not claiming. What did we measure? What do you think we measured?
Yeah, you say you've done laser measurement.
Yeah, over like 40 kilometers and similar distances.
Yeah, based on that, you've done some calculations and
measurements.
Measurements. You've done measurements.
There's no curvature.
Hey, DJ, he's confused. He thinks measurements are calculations. You can tell by the way he said, yeah. He thinks they're the same thing.
How do you measure? Let's say you said it's measurements, it's not calculations. Okay, I get it. So when you
We're not saying we measured the whole Earth. We're not
Yeah,
saying that.
that's my point. If you
You don't
haven't
need
done
to.
that,
There was
You don't
no
need to. You don't
AJ.
need
Wait
to.
a second. Wait a second. AJ, the globe was never measured at all, so it's not a globe, correct?
it's just like
Uh-uh.
that's why in the beginning I told you.
AJ, answer my question.
I
Is the Earth a
believe in
ball or is the Earth a ball?
I believe in it. That's why I told you.
So you're just allowed to believe, and it's not a ball. You know why? Because your beliefs don't count. So there, you have to measure the surface to be curving, and then you can do some calculations to figure out if it's a ball or not. You don't say it's a ball. Let me go measure, and that's the calculation. That's weird shit when you do that, don't you think?
You don't need to measure the whole thing.
Yeah, the thing about spheres is that they are curving away from you in every direction from the point that you're standing. So we can measure a small section over water, by the way, not land, over the sea, and see that that section is completely flat. Well, guess what? If it's completely flat, then the ball is already debunked. It's over because it's not curving. It's very simple. And this is not just one area. It's not like we're measuring one flat spot, because even with one flat spot, it still wouldn't be a sphere. This has been done everywhere, over lakes, over the ocean, everywhere it's flat.
Exactly, and the surface of one body of water, like one lake, is not going to have a different quality to another lake. It's going to behave the same. The water is going to abide by its physics, okay, by the physics, which it dictates that its surface is horizontal. Right? If you can show through measurement that the surface of a body of water is curving at a rate which conforms to the Earth being a sphere with a radius of 3,959 miles, then you've got something to work with. But you don't. Nobody's ever measured that, and all attempts to measure that show that it doesn't deviate from horizontal. Therefore, measuring the entire Earth is not necessary. We're not saying that we measured flat Earth. We measured it to be flat. It has that property of being a horizontal plane. Let me put it to you this way, okay? You've got a pool table. Do you know what a pool table is? A snooker table?
Yeah.
Okay, all right. You don't want it to be tilted, do you?
You mean
you don't want it to be sloped. You don't want it to be uneven. Right. You want it to be level, right?
Yeah.
Right. I can get a level and put like a spirit level, and I can place it all around on the table, and then adjust the legs accordingly until at each point that I place the spirit level on the top of the table, that bubble is in between the two guidelines, right? That establishes that the table is as close to level as I can get it, okay? Do I need to know the dimensions of the table to do that? Do I need to know how big the table is?
It's a good analogy.
I do not need to know how big that pool table is in order to establish that its surface is level.
You mean?
Thank you very much. I'll be here all week.
Like, what do you mean? For instance, like if it's tilted or not? So you said to find out you don't need measurement. Is that what you said?
Do you need to know what the size of the table? No, it's not level.
No. I don't.
Okay. There you go. So, if we can see that the Earth is not curving, then it's not a ball, and it doesn't matter how big the Earth is.
Okay, still, you guys are coming to the same point. I get it.
Yes, the earth is flat. That's the point. We keep coming. That's what happened. That's how we all got here. We kept doing this over and over, and we finally kept coming to the same conclusion. The earth is flat, and here we are.
Yeah. That's what you're trying to say. But when I ask you the questions, like, don't talk about globe. Don't ever talk about globe. Just talk about flat earth. It's because that's what my question is. But whenever I ask you questions, you're trying to say Earth is not globe. It's flat. That's what I'm getting. I'm not getting the answers from you. For instance, when you say it's flat, let's say when you say it's flat, you told me you know that. So when I asked you how, you said we've done measurements. When I asked you, how did you do the measurements? You said we were using lasers, let's say 40 kilometers. So based on that, you're trying to figure it out the entire, let's say the entire Earth's distance. Am I right? Just to clarify.
No.
Okay. So
not
explain
distance.
that.
Not the distance. Not the distance. Just for flatness. So when we measure for flatness, we find that it's flat. Is there any place that we should be looking that we haven't checked where it would be curving?
Okay. So let's say we don't need to go back, to the first place. So you said when you do the laser test, it's not for measuring, it's for flatness, like to figure it out whether it's flat or curvature. Am I right?
Yeah. So we measure for flatness. We find it's very flat.
Okay. So up to 40 kilometers, you say it's flat. It's not curving at all. Am I right?
No. Correct.
So the data you got just 40 kilometers. Okay? Okay. So when you just see let's say we have different countries, one country has, across the globe, like across the earth, let's say. So sometimes we know the distance, let's say 5,000 kilometers, let's say, 6,000 kilometers. You just measured 40 kilometers, 40 kilometers, and you're just saying.
Are you saying that it's curving somewhere between 40 kilometers and 5,000?
No, it's not 5,000. Let's say, what if like 10,000, 15,000, 20,000?
Okay. Do you have any evidence that it's curving between 40 kilometers and 10,000 kilometers?
Do you have evidence?
I'm asking you, apparently to you, 40 kilometers is not enough. But within the 40 kilometers, holy cow. In 40 kilometers, you will have hundreds of feet of deviation between horizontal and the curvature of the earth, right? Hundreds of feet. We found none. So the point is that if you're claiming between 40 kilometers and 10,000 it's curving, I would need to see the evidence of that.
Okay, the thing you are saying, let me give you an example. Okay, I have a let's say I have a football. When
is the earth a football now?
No, it's an example. Like that's what.
Well, why don't you use an example using the earth? Because the earth is claimed to be a sphere.
Checked.
So when you have some data to validate it, you have to have to justify it. Just having
what do we need?
We have 1,100 verified data now. 1,100. How many do we need? 1,105 or 1,200?
No. When you just said 40 kilometers, you've done 40 kilometers. Just 40 kilometers.
No. Yeah, 40 kilometers, 1,100 times.
He's saying that it's flat.
You can do 1,100 times. Let's say,
bro.
Let's say 20,000.
You're starting to really upset me at this point because it almost seems like you're trying not to understand. How much is the Earth supposed to be curving in 40 kilometers? Are you just going to go ahead and say because we haven't the entire span to see if it's curving or not, that it cannot be flat? Is that what you're saying? Is it all of a sudden going to become a ball? Because after 40 kilometers, there might be some curve somewhere.
No, what I'm trying to say, the data you have, 40 kilometer, sometimes it's an outlier. That's what I'm trying to say.
Yeah. Okay, so this outlier would have to fall between a range, right, of margin of error. We're talking about hundreds of feet. There were essentially no feet.
How can you say it's an outlier when you don't
when you have
to the contrary?
Could you speak?
Good question.
Could you speak louder?
You're a little quiet, Cyclone.
I'm saying, can you hear me?
Yeah, yeah, it's good.
Yeah, I'm saying, how could you say that that's an outlier when you don't have any measurements to the contrary that show any curvature? Measurements of flat is the standard. There's no, it's not an outlier because you would have to have loads of measurements of curvature for the flat one to be an outlier. The flat is all we have.
Okay.
Understand?
Let me give you an example.
Dude, wait. If you understand the football example, do you understand that the football is round? It's a ball, right? You only have to measure a section of it.
It's not a sphere.
If that section is curving, if the section you measure on the ball is flat, then you can safely assume that it's not a ball anymore. Do you understand? You only have to measure a section of it. You don't have to measure the whole thing if it's a ball.
Yeah.
Now, when we do measure a small section, let's say 10 miles, and it's not curving, then we know it's not a ball. Why can't you understand that? It's so easy.
Okay.
Think about it.
So let me give you an example. So let's say to figure out something, when we have some, when you talk about measurements like having 40 kilometers, I get it. To get the right conclusion, you have to have the proper data. What I mean by proper data, let's say sometimes what people do, they take sample sizes. What I mean by sample sizes, let me give you an example.
You don't have to. We're not retarded.
Yep. How about this? Every day.
It just doesn't work. Just doesn't work. 40 kilometers flat debunks the globe. That's it. You maybe don't understand that yet, but that is the situation.
So does 20, so does 60, so does 100, so does 5.
It's about the nature of water, right? If the nature of water is as they've told us, then over 40 kilometers, it must curve. If over 40 kilometers, the water is not curving, then it shows us that the nature of water is not to curve, and therefore not to be a ball.
Who told you it has to curve?
If you believe the Earth is a ball, then it has to curve.
Mathematics.
Yeah, it's a geometric consequence of a sphere, man. I told
Indian space.
On a sphere, the Earth should be curving, or in this case, the Earth should be curving away from you in every direction.
So that's a good question.
Okay, let's say
who told you that the water must curve?
So
you told you that the water must curve.
Maybe you both sides are wrong. Let's say the people who believe in flow, the people who believe in.
Hey, listen, guys. Listen, hold on. I got to tell the audience. Listen, he doesn't want the Earth to be flat no matter what. He's even willing to throw the globe out now as long as they're both wrong. Just Earth can't be flat.
Yeah. That's not going to work, AJ. It's measured flat. It's not measured curved. You're going to need something for a globe to even start the question of a globe. You don't have it. It's just flat. It is what it is. We're sorry. We know it's annoying. We know you don't want it to be flat. That's inconvenient, but it is what it is.
No, it's not. What I want.
It is what you want, because we're telling you it's measuring flat. You've got nothing to the contrary except flat, and you're saying, well, we just don't know what it is. No, we do. It's flat. You're even agreeing it's measured flat over 40 kilometers, which debunks the globe model, but you're still saying, we don't know. No, we do know. You maybe don't know, but we all do know.
Okay, all right. Okay. Just like,
But hey, listen, don't give up. Try and find that curve. Maybe you can find some curve measurements somewhere. We've been looking for like 10 years. Maybe you'll find them. Do you think you could do that?
It's to do, like, you're just saying I could find something.
Yeah, like curvature. You'd have to find curvature.
What I think, and the questions I'm asking to you, like you guys are not answering.
Yeah, we've answered it. I heard them answer it 10 times over. You keep pretending like it's just a small section. No, mathematically, this is a sufficient section to debunk the globe. You don't understand that.
How do you believe the mathematics? How do you believe the mathematics? That's my point. How do you believe it?
We test. We don't believe the mathematics. We test the mathematics, and we find them to be false.
How do you know that the mathematics are right?
We test the math that NASA and the space agencies are telling us is true about the Earth. That's it.
Space agency. You just said like.
Yeah, we test their story. We test their story. Their story is the one you believe, right? We test that.
No. That's my whole point. That's my whole point. Right now, you just mentioned it. When I asked you, how do you measure it? You said using laser. You said 40 kilometers. So when I asked you the 40 kilometers.
Yeah, that should be curved on the globe, right?
Wait, AJ, I think you don't understand. We're measuring the drop over the distance of 40 kilometers, and that comes to 91 meters if you're 2.75 meters tall. 91 meters of drop, which isn't there. That's what we're measuring, and it happens everywhere.
Okay, the mathematics. Let's talk about the mathematics. He said
you don't like math before.
From agency, he said like some space agency.
AJ, if you don't like the mathematics, if you don't trust the mathematics, welcome to the club. They're not real, but that is what they're claiming.
Oh, he's about to throw mathematics under the bus.
Yeah, that's my whole point. It's because when you believe in something like mathematics, it's because you never know that's my whole
that's incoherent, AJ. You're now making no sense.
Whoa.
AJ,
you never know anything. He's turning into that already.
Listen, AJ, it's not that we believe it. It's they are making the positive claim. They're saying that the Earth is this size and this shape. They're the ones that's saying it. They're supposed to be the experts telling us that this is the size it is. We're just taking that information. We're not believing it. We're taking the information they've given us as experts, and we're going out and checking to see if the drop over distance exists in reality, and we found it doesn't. That's all there is to it. There's no drop over distance.
Okay. Like what I thought, and the mathematics you have, it's from people who believe flat Earth. I never thought,
No.
Mathematics.
Hey, hold on, AJ. You understand that they give us a size of the sphere, of the globe?
A claim.
Do you know what that size is?
A number.
What size is it? What size is it?
They have some, numbers, like,
Okay,
I get
the number. Give us
I have to check that. I'm not sure exactly.
This is the problem. You don't know it, right? And you're projecting your ignorance of it onto us. We do know it. That's what we're testing. I don't know how you're not understanding this.
So, what's the question? Say it so I can search it.
What is the size of the globe that they claim?
The radius.
The radius, it's 3,959. I believe
Okay,
that's it.
that's the claim we're
That's
testing.
what they are trying.
Okay, that's the claim we're testing. Do you understand?
Yeah.
That's it. So when you're saying where are you getting the mass from, it comes from a sphere with a radius of
I get it.
3,959 miles.
Yeah. So
okay, so you understand. There should be curvature over a certain distance based on that radius, and it doesn't exist. Do you understand that?
Oh, yeah. You're just trying. Yeah, based on that, it doesn't match up. I get it. Like,
Okay, there you go. So that means okay.
The
So stop there.
Yeah.
AJ,
yeah,
that's the whole point. That's the whole point. Don't skip over that. That's the whole point. So that means that the globe that they've shown you in school, on TV, the solar system, all of that, it's untrue. That's what that means.
Okay. I get it. I get you. I get your whole point. But since you believe they may be wrong. Let's say
it's not a belief system. It's not a belief. It's measured flat.
We tested the belief. It's not a question of us having a belief. We tested the belief, found it's untrue.
Yeah, it's untrue. But how do you prove it's flat? That's my question. Like if
that's it, because that's what we experience by default. So there's no curvature. There's only flat. So that's it.
No. What you're trying to say
is Earth is
the radius. The radius they gave, it's wrong. Like I get it. I get the whole point.
There is no radius. There's no radius at all. There's no curve at all.
Yeah, there's no curve for there to be a ball that's ever been detected, right? No one's ever measured any, so why would we assume any?
Yep, the surface of water is level, like the pool table.
It would make no logical sense for us to assume curvature if it's not measured anywhere. You understand?
I mean, the people that survey, that do this every day, they're measuring it to be flat every day, everywhere. The people that make your topography maps, so it's not just 40 kilometers. And their firsthand experience and measurement is of a flat Earth. Everyone, even you.
So why like I get it. So are you just rejecting the people who are going to space? Let's say the radius wrong. Let's say the radius wrong.
Yeah, the whole story.
Are you just saying no one's been to space yet?
Listen, if the radius claim is untrue, all the rest of the story is based on that, right? Space, the planets, the size of them, the story that they tell us about the solar system, the galaxy, and all that. It's disproven with the radius of a globe.
No, how do you just let's say we cannot just measure accurately everything. Sometimes it's accurate 80%. Sometimes it's accurate 90%. You know the probability, right? When it comes to the probability,
that doesn't change our situation.
You cannot get 100% probability. If you know, like when we talk about probability,
we know. I mean, there's no chance that there's curvature, or it would have been measured by now.
So you're just saying 0% probabilities, like zero probability
of there being a globe, as they tell us. Yes, because the claim has been tested directly. They give us the numbers.
When you talk about probability, you're just saying there's.
We're not talking about probability. We're talking about a measurement that tests a claim, and the claim is proven to be false by direct measurement. That's not a question of probability. It's like saying my table, I think my table is, I don't know, 2 meters long, right? And then you measure it and it's 1.5 meters. You now know it's 1.5 meters because you measured it It's not a question of probability of it being 2 meters. No. You now know it's 1.5 meters.
AJ, you got to understand, NASA came out, they gave us pictures of a ball from space, right? We took this picture of Earth. This is what it looks like. This is how big it is. What we did, we was like, okay, let's see if that's the case, and that's why we measure it down here. And when we find flat water over long distances, we know it's not a ball. So that takes the, I mean, we can grant you the pictures initially, and you say, hey, let's go check it then. Fine, it's a ball. Let's measure it. And then we find some flat surfaces, and all of a sudden it can't be a ball anymore. Did you get that? And then we can throw those pictures out of the window. They don't mean anything because we can't confirm them. We tried.
Yeah, they're provably false.
So if you're going to appeal to a probability, number one, that's not going to work in this particular topic, but let's just play around with this for a second. Let's say that there's been many measurements of Earth curve, and maybe a few places were out of whack, right? Maybe we're mistaken. Well, here's the problem. There are no measurements of curvature, 0. So the probability of there being Earth curve measurements is 100% no Earth curve measurements.
A few dubious calculations that can't be reproduced and don't match measurements.
Okay. Let me.
That would make it even worse. That's like negative percentage.
Okay. You know the straight line, right? Like, you know the straight line. Is it right? Like, you know the straight line.
We know what a straight line is. Yes.
Do you know circle? Like, let's talk about circle. Okay. Let's talk about the circle. When you look at the circle, let's say, like you're just trying to zoom in, like you're trying to zoom in the circle. Like when you go really like deep in it, you just see the point, the dot. Okay.
Yeah, but that's not the claim. That's not the globe claim.
Let me tell you, dots, dude. Lines are not dots. The Earth is not pixelated. Mathematics does not operate on pixels. Points don't even have any dimension.
So the thing you're trying to say, it basically it says like you're just trying to figure out 40 kilometers. So 40 kilometers, it's just like a point. That's what I think,
No, it's a stretch of curved line according to the globe.
Yeah, you need a measurement of an arc.
Yeah, exactly. It's an arc over 40 kilometers according to the globe belief. When it's measured, it's flat. Like,
so that's the reason I was talking about probability.
No. It doesn't. That's not a question of probability. We just told you it directly measures flat, not curved. So there's no probability of it being curved when it measures flat.
So when you look at a straight line, like it's straight. Like when you look at a circle, that's
not comparable. We're not looking at a circle. We're testing line of sight over a surface. How far we can see. If it was to go below the curve like they claim it should, it would affect what we see. We're not detecting that. It would detect how far the laser can be received. We're not detecting that. So no, the whole zoom into a circle and it looks flat thing doesn't work. That's exactly what we're testing with the math. So we're not just eyeballing a flat horizon and being like, oh, there we go.
AJ, if everyone, including yourself, when they measure the surface of the Earth and they find out that it is flat, what is the probability that the whole Earth is flat?
Okay, let me summarize it. You just say, the people who are trying to find out, all the people just got let's say the mathematics or something, like the Earth is flat. Is that what you're trying to say?
No, I'm telling you that everybody in every industry measures the Earth as flat. Everywhere across the Earth, they're measuring the Earth flat, horizontal. What is the probability that the Earth is flat if every industry and everyone's firsthand experience is that the Earth is flat? What do you think the probability would be? Could you give me a number? Maybe a percentage?
So I can ask you a question before that, before answering it. Okay.
Holy cow.
So it's because you just assume, like it's an assumption. Like when you assume it, everyone does it.
No, that's not an assumption. I don't like being accused of assuming this. If you ask a planar surveyor how they measure the Earth, they level their tool and they measure angles to points along the surface in reference to or in respect to that horizontal datum of the tool. So everyone is measuring sections of the Earth within reason, right? Because these tools you can't see forever or measure forever. But in the sections that they're measuring, everyone, not just the flat earthers, everybody is measuring the Earth flat. It's not an assumption. It's what's being done. So what is the probability that the Earth is flat if everybody measures it that way?
So you mean everybody means, the whole population?
No, just anyone measuring it. Anyone measuring it.
Everyone who does that. Like, I mean, like we have more than 8 billion people. You mean?
Yeah, and you can find one that's measuring curvature. So what does that tell you?
Okay, you mean curvature just for 40 kilometers, you mean?
For over any distance conforming to the globe.
Or if they can find curvature, let's say 20,000 kilometers, not just like 40.
They can.
Like 15,000 kilometers, 20,000 kilometers.
They can.
How would they do that?
Yeah. So
okay,
to figure it out, they cannot do that with a laser.
They can't do that anyway.
It's because they don't have the equipment, right? Equipment to measure it.
No,
that's my.
It doesn't exist.
You can use laser up to 40 kilometers, but you cannot use laser up to 30,000 kilometers. You cannot use laser up to 20,000 kilometers.
Yeah. Okay. So you're saying
sound like a flat earther now.
Yeah. So you're saying no one's measured curvature over 20,000 kilometers. Yeah.
No. So, like, when you have long distance, it's because we don't have the right equipment to do that.
Okay.
Right.
This is why I asked you about them. That's why I asked you about the probability. So if everybody is, what is the probability that the Earth is flat?
100.
Well, I don't know why you won't answer this. It's like you're avoiding the question. What is the probability?
Okay, so nobody has a tool to measure it. If we don't nobody has a tool to measure it. But
why are you being? You're being rude now. I'm asking a very simple question. You won't answer it. You refuse to answer it now.
Yeah. Go ahead. I'm not trying to disrespect anyone. I don't want to do that. Yeah, go ahead.
What is the probability that the Earth is flat if everyone measures it that way?
When it comes to probability, if you talk about probability theory, there's no 100% chance. There's no 100% chance. So
give me one. Give me a number.
Yeah, what is it?
You could be, let's say, you could be 90% wrong, 90% right. Sometimes you could be 95% right, but you cannot be 100% right.
But he's saying in the instance where everyone who measures the Earth is measuring it to be flat, what is the probability that it is flat? That's what he's asking.
When you okay, before talking about probability, just go and search about probability.
You brought probability into this conversation. You're the one that brought this in here, and now you don't want to talk about it. I asked you what the probability was. You will not answer my question. That tells me that you actually don't want to have an honest conversation with us, because I'm asking you if it's not going to be 100%, then do you think 90 is close? Do you think 90% probability that the Earth is flat if everyone's measuring?
Okay. So when we measure a table, we know that we have the right equipment.
Oh my gosh, dude.
Could you just give us the number?
So when we have that, like, we know it. But when you talk about long distance, we don't have the right equipment to measure it.
Okay, but that's not what he asked you. He asked you if everyone who measures the Earth is only measuring flatness, regardless of the distance they're measuring, what is the probability that the Earth itself is in fact flat?
Okay. When someone does that, it's just like, then the probability theory is wrong. Okay.
Right. So now you're throwing out probability instead of answering the question.
Yeah. If let's say when you talk about probability theory, it
but you were the
shouldn't
one
be
that brought up
100%.
probability, and now he's asked you that. You're saying you want to throw away probability as a thing.
Yeah, he's arguing with himself.
No, I'm not trying to throw it out.
Well, then just give us your opinion. We know this is a subjective number. We're just asking you to give us your personal opinion, what the probability is that it's flat if everyone's measuring it to be flat. Is it 1%? Is it 50%? Is it 90%? Is it 100%?
My thing, when you talk about it, cannot be 100%. That's what
so it can't be 100%. We've ruled that out. So what might it be?
50%? It could be 50, 60, 90, 95, but it cannot be.
What would you say? What would you say? That's a pretty wide range. What would you say?
I would say 50. It's because, like, we don't have the
50%. So you're saying if everyone measures the Earth flat, it's 50% potentially true that it's flat. It's 50% that it's curved. If everyone's measuring it flat, wouldn't that tip more? You're saying that's like 50-50, but surely it would tip more in the side of flat at least if all the measurements are only flat.
How do you know everyone's gonna measure it?
Well, but how can it be 50-50 if everyone who's measuring it is measuring it flat? How could it be 50% chance that it's curved if everyone's measuring it flat? Surely it would at least be 51%.
So the probability is much higher. I get it. Like, if probability is much higher, but
okay. So what do you think it would be then? Not 100, not 50. Somewhere between there.
Just like you're assuming, everyone's gonna do that.
Well, that's all we have evidence for.
Assumption. It's like when it comes to, I can just say, I can say 60, 70. It's my assumption.
Okay, so we're at 60-70% flat Earth. That's not bad for a first time in the channel. I'm assuming it's your first time.
No,
60-70%.
It's an assumption. I told you it's an assumption. I'm not, I'm not saying I know it.
I know you're just saying 60-70% likely that it's flat if it's being measured flat everywhere. So now you have to go and figure out, is it being measured flat or is it being measured curved? That's what you need to do. Also, I think you're almost getting a bit hung up on the term flat, right? Us saying that it's flat really it's not much of a claim to everything. We're not claiming to know the size of the place, the shape of the place, or where it is. We're simply pointing out that the surface nature is not curved, right? It's just flat. I mean, that definitely rules out the globe and all of that, but that doesn't mean we know what it is, right? So don't be sitting there thinking that we're trying to say we know all about reality and what the universe is and all this. We're not saying that at all. We're making a much more humble claim than the globe side, who do claim to know what the luminaries, the sun, moon, and stars are, how they got there, how old this place is, how it got here, where it's going. They make all those claims. We don't make any of those claims. We simply talk about what we can observe, measure, test, repeat in reality, right? Empirically. So that's a logical basis to pursue the truth. And that's what we're doing here. So don't get too hung up on the fact that we're saying it's flat, not curved. That's not
No,
making
no,
like
no,
some
no, no, no. It's not. It's just like
supernatural
I
claim.
get it. Yeah, I get it. Based on the data, or else like whatever you're trying to be logical. Based on the information you have, you're trying to say it's flat. I get it completely. Like it's
Yeah, you 60 to 70% get it. That's good.
so based on the information I have, I just say the globe is like it's globe. It's not like it's based on the
But
data
you don't have any information that proves it's a globe, though. You've just got images that you've been shown.
I
just
like,
just a quick question, AJ. Just a quick question for you, my friend. I just want to just ask about this probability thing again, really quickly. Okay, just say I have a nice flat floor in my house, okay, and I measure all these different little sections of the floor, you know, across all of these sections, and you know, I've confirmed that the floor is flat. Okay, what's the probability that my floor is flat and not a globe?
You know, you could be, let's say, you could be.
What's the percentage?
You could be 99% right, but 1% wrong.
So there's a 1% chance my floor could be a globe.
Yeah, or else like no.
Okay.
You maybe
Thank
90,
you. All right.
99.
Yeah. All right, bro. All good.
All right, we're up to 99% flat. Good going, DJ. Bumps him up a good.
So
15,
it's not like it's a mathematics. When you talk about probability, it's just mathematics. So I'm not just saying it. Like I'm
we just
talking
keep
to you.
chipping away till we get right at that
Let me tell you.
99.999.
I'm saying based on the mathematics. Like when it comes to probability, it cannot be 100%. That's
Okay,
what I'm
AJ,
trying
AJ, that's fine. That's fine. You don't believe anything for 100%. Fine. So now you understand on the curvature side. Sorry, before we go on, I was just going to suggest, now that we've done the curvature side and he gets it to 60, 70, 90%, what about the motion? You want to do the motion? You think the Earth's in motion, AJ?
Motion. Like, what do you mean?
Like, is the ground spinning around?
You mean the Earth, whether it's orbiting around the universe, on like orbiting around the universe?
And,
What do you mean?
Yeah, and spinning in itself. So it's a ball. It's a ball that's spinning, and that ball is spinning around a bunch of other balls. So, is that what you think? Is that what it seems like when you go outside?
I haven't, you know, I haven't.
He's never thought about it.
I haven't tried it. Let me tell you.
You haven't tried it. It's just as simple as going outside, AJ. I bet you've tried it a million times.
When you don't have, let's say, why people say some things are complicated.
What's complicated? You go outside. Does it seem like the ground is moving?
So, do you ever think some things are complicated in your life?
Some things are complicated.
Me personally, no, not really.
Is going outside complicated and experiencing what you're experiencing? That's not complicated.
If you think complicated, could you tell me any examples? Like, why do you think it's complicated?
Well, we can get to what's complicated generally in life later on, maybe. But for the moment, could we focus on what we experience on the Earth? So when you're outside in reality, doing your thing, does it seem like the ground is in motion in any way?
When, you cannot just take.
It's just a simple.
Take yourself. You cannot just take yourself and assume the whole thing.
Yeah, so I'm just asking you what you experienced, right?
So when you talk about,
you feel like the ground is.
So it's like it's called representative bias. The thing you're trying to say, it's called representative bias. Like what does
you're how do you know what I'm trying to say? Because you're not really responding to what I'm saying. You're just saying other things.
Okay, so the thing you're trying to find, let's say,
try like a yes or no, like really simply. So if I say, do you experience the ground moving? Yes or no?
It's not a hard one.
if I just like look at the scientific
my
data,
God.
they, like, not scientific, like when
just like in reality, when you go outside, when you're living your life.
Space agencies, like when they say
No, bro, no. You're making too much of it. You're making things more complicated than they need to be. When you go outside and you're looking around at the world, is it obvious to you? Is it immediately apparent that the ground is moving?
that's the reason. Like, do you know
Just
about?
answer yes or no. Is it? Is it obvious to you? Is it obvious to you?
To answer it, do you know about representative bias?
Oh my God! Use your mouth to answer it.
So let me tell you. Let me tell you what is representative bias. Before answering,
Okay, dude. When the teacher asks you a question, you can't do this in school, right?
And you definitely can't do this in the workplace because you would be fired next week when we have our meeting. You won't be in the meeting.
But
let's see if you can answer even very simple questions. AJ, are you on the Earth right now?
You have to consider all aspects.
All right.
You cannot just.
Oh my
God. 2 seconds. Well, while AJ's trying to figure out reality, I'm gonna say peace out. So have a good night, guys. Good chat.
See you, Cyclone.
I'll mute for a bit.
Good night.
Bye.
See ya.
AJ, are you on the Earth right now?
Yeah, I am.
Are you 100% sure? AJ, are you 100% sure?
No.
Okay, so you can deal with this guy. He's not even sure if he's alive.
So,
do you have hands, AJ?
AJ, do you have hands?
I can. Yeah, I do have hands. Yeah, for sure.
Wow. So you have
So
hands for sure.
Are you trying to say whether you believe you have hands 100%? Like,
Yes. Do you believe 100% that you have hands? Holy crap.
It should not take this long. It really shouldn't.
Just say yes, AJ. Please say yes.
Have fun. I'm going to listen for a bit.
Let me.
You
let
might
me
not have hands, you guys.
Let me tell you two things. I can say.
Shit, sorry, dude. We didn't realize you actually didn't have hands. You should have said, no, actually, I don't have any hands. I'm sitting here talking with my tongue, pressing buttons on the keyboard.
I can give you two answers. Let's say if I talk about
you can't. It's only one answer. It's a yes or no. Do you have hands?
No. Hey, you cannot just ask open-ended questions just like that.
Who told you that? Was it your physics teacher or was it your math teacher?
Nobody told me. I know it's because like I'm trying to figure it out. I'm trying to figure it out by myself.
Oh, okay. Well, that ain't gonna work. Obviously, you need our help.
AJ, we're not trying to trick you, bro. We're asking you just a very closed-ended question. Do you know whether or not you have hands 100%?
We're just trying to get you to say yes or no one time to a question. Just a starting point for us, not 99.99999% sure. That's retarded.
Not a trick question. Very simple. But since you did answer the question earlier, whether or not you were 100% sure you were on Earth, that kind of ends the conversation that we can have with you. Because if you're not sure, this could all be an illusion in your mind. And so there's no real basis or foundation for any knowledge.
Where did our physics professor go that was in here before? Or is that you, AJ? Are you the guy who took physics?
No, he gave up. I asked him to, show his receipts, and he bounced.
Oh yeah, that usually happens when people claim they're physicists and stuff like that. They usually just quietly disappear from chat as soon as they can't come up with any proof for us. Except we always have proof for everybody else. We have to always present proof to these people. We ask them for one thing, and now they're not 90. They're only 99% sure.
We do have a math professor in here. I mean, I bet even Matthew would say that you can measure a section of a ball, and if that section is flat, you can no longer call it a ball. Am I right, Matthew?
Right. I'm just like, is he 100% sure he's not a woman?
I think there are some properly basic beliefs, like the fact that I have hands, the fact that I live on Earth. Those I'm 100% sure.
What about, are you a man?
Yes.
AJ, are you?
What?
Uh-oh.
Ladies and gentlemen, we got him.
Can I?
All right, the floor is open. You've given up. That's congratulations.
No.
Yeah, it's wide open for everybody now.
No.
Oh, you didn't give up? All right.
No.
Oh,
So
well.
Can I ask you a question?
Yep.
Do you believe in God?
Nope.
Are you 100% sure you can ask that question?
Oh, you don't
believe in God. I believe in God.
Yeah, Matthew does. He believes in things. I don't believe in things. I know things are actual facts, but
okay,
I don't believe in them.
I believe in God, and I know God exists. Both
so I know already, but Matthew just believes. He's hoping he's
not just
in a way because he's going to get slapped on his hand for being in here telling lies to other people.
It's because I don't believe in God. So the thing is, some people believe in
Maybe
God.
that's what's wrong with you.
Oh, it's opinion. Okay, it's my opinion. I don't personally believe in God. But
no, this isn't a religion room. Yeah, nothing to do with God in here. It's measured flat. God has nothing to do with measuring things. So there you go.
So
yeah, you're not even 100% sure of your beliefs, so why would we entertain them?
So it seems like nobody's sure. Like the thing you're saying,
we're 100% sure. We are sure. You're not sure at all. That's what you keep telling us. You said you're not sure at all. We say we are 100% sure. You say you are not sure at all. There's a difference.
It's just like you think you're 100. Yeah, like it's your belief, or like that.
No, it's a measurement. It's not a belief. You don't believe in measurements. You just go and do them and write them down.
AJ, the majority of the flat earthers in here have done our own tests, okay? I did it over a 6-mile wide lake. It was flat. Other people has done it over 10 miles. We have 20 miles. We have 40 miles. If there is a flat surface on your ball, it can no longer be a ball. Why can't you get that? Your ball has to curve everywhere. It doesn't. It's not
AJ, maybe this will be easier for you, AJ. Ready? This should be easy for you. AJ, are you there?
Yeah, I'm listening. Yeah, I'm all ears.
This should be easier for you to understand flat Earth. Ready? Earth is flat and stationary, and space is fake. You can't go to outer space ever. You can't fly to the moon. Mars is made up. Things flying around in outer space vacuums is all made up. So you can forget about that. Now you can start focusing on flat Earth because I took all that away from you. Is that okay?
So when you just say that,
space is
it's
fake.
an assumption. It's an assumption.
I own a vacuum chamber, and I debunked outer space. So we got that out of the way. I got that out of the way. It's not like dealing with gravity. It's not like dealing with gravity. It's something. It's not. It's something I can actually do. It's not an assumption. I don't assume I have a vacuum chamber. It's right behind me.
No, it's an assumption. How could you just say that? Like, you can just say it, but it's your assumption.
What's the assumption part?
You just said space is fake. There's no object flying around. You know, you can just say, like, you know, you have only flat Earth. The other things are fake. It's an assumption. I can just say that.
I didn't say the lights are fake. I said your outer space vacuum is fake. You can't have gas balls and water balls in a vacuum chamber. I have a vacuum chamber. I can prove it. Can't do it. You can't have a floating earth ball with water and air around it in a vacuum of outer space. So I debunked the vacuum of outer space with the vacuum chamber. What do you think of that? What's your opinion on that one?
It's just like if we keep on assuming things, but nobody's giving the exact thing. Like, we keep on assuming it.
Okay, AJ, ask anybody else in here where I assumed vacuum chamber at. I'm going with what NASA said about the sky, and I own a vacuum chamber. What did I assume?
To assume.
It's a great conversation. I feel like I'm hungry. I have to go and have my dinner. I think, I have to eat something.
That one usually knocks him out when you tell him space is fake. He's getting hangry.
No, it's not about angry. It's a great conversation. It's because
hangry, H-A-N-G, not angry. I didn't say angry. Yeah, I didn't call you angry. I said hangry, H-A-N-G-R-Y.
Yeah, it takes me to the foundational level. The topic we are talking about. It's like it's a debatable topic for sure.
Well, it's actually not a debatable topic because you don't have anything to prove globe. We only have flat Earth, so there's no debating it. You know what I mean?
AJ, you should go eat and think about this a little bit. We've given you a method, so you know you can go out and test this yourself as well. Maybe after you eat, then you can process it. So have a nice day.
So okay, let me ask you the final thing. So not right now. When we started talking, I think Jim, he told me go and find something on Google. Okay, is that right?
Mm-hmm. Yes, I had asked you to ask a search engine, and then I said you could pick Google, you could pick whatever you want. Ask it this question. Is 1.2 times the square root of the observation height in feet A valid equation for identifying the distance to the horizon. And then I'll post my screenshot of what I got when I asked that question. And I purposely misspelled height so that my question can be seen in the screenshot. Because typically the search bar on a phone doesn't show everything that you asked.
The pictures, did you take the picture from Google?
Yes.
Okay, you took the picture from Google, and the definitions you got, did you take it from Google?
Yeah, let me show you what I took a screenshot of.
So if you take it from Google, like let's say if you take it from Google, if you ask Google the Earth is flat or round, it will say it's round.
I know. And then there was also a point in time where you could ask Google if men could get pregnant or if men could give birth, and then it would say yes. So what's your point?
Google is a search engine. It's not an authority. So when you search Google, you find links to actual different sites. So Google isn't telling you anything.
The data you share over here, like when you say you don't believe in it, like you cannot get data from there.
No,
it's
your
because
problem
to be
is you have
accurate,
an all or nothing fallacy. Like just because something on Google says one thing, it doesn't mean that that's true just because we also use Google for other things.
Right now, what you're trying to say, Google says two things, like Earth is round.
AJ, stop, please. Stop for a second, okay? Look, this is Google saying that the Earth is round and that the horizon would be a certain distance away because the Earth is round. We're going and testing that in reality and proving Google wrong and proving you wrong and proving everyone that claims that the Earth is a globe with that radius wrong. Okay?
But you believe the data, you took it from Google. Like
No, we don't believe it. We don't believe it.
We went and measured it. It's not a Google belief.
Google is wrong, right? But Google's parroting the globe mathematics. Then when we test the globe mathematics in the real world, it doesn't match reality. That's the problem. This is based off a globe, right? The horizon would be at a certain distance away, right? You can use that formula, and it's a globe formula based off the globe, and then we go test that, and it doesn't match reality, so it can't be a globe.
Yeah, I posted another screenshot of combined screenshots. Is the Earth flat? Google says no, Earth is roughly a sphere. Ask it again. Can men get pregnant? Yes, it's possible for men to become pregnant and give birth to children of their own. Now,
All right, I can't use Google anymore. I can't use it anymore now.
Well, the reason Google said that men can get pregnant is because at the time it was a hot topic and people were Googling this thing, and this specific search result was a popular result for people to click on to support the claim. And so Google was offering this as a first response because it was the most popular according to the algorithm.
Yeah, algorithm. Yeah, that's right.
Right.
What?
So, just because it says Earth is sphere doesn't mean it's actually a sphere. You would have to test that in reality. Just because it says men can get pregnant doesn't mean that it's the thing. And then you can test it in reality.
AJ, I don't want you to get hung up on this idea because you've mentioned it multiple times. You know, Google gives us a claim made by somebody else. Your elementary school teacher gives you a claim made by somebody else.
Yeah.
We don't believe them. We don't even accept them. We take the claim and we test it. It's not a matter of believing or disbelieving. It's about testing claims. So, okay, you say that, I'll take what you say, and I'm going to go put it into a situation where I can test it in reality and see if there's any validity to that particular statement or claim. And when we test it in reality, it's found to be false through measurement, observation, testing.
Yeah. Yeah, I'm trying to
That's why.
understand your perspective. Yeah, I'm trying to understand, people who believe in flat Earth, their perspective, their point of view. Yeah, I'm trying to understand it.
Okay, well, here's a synopsis. I use my senses to experience the world around me. I trust my senses to give me the truth of reality around me.
So when you say trust, what does it mean, trust? You're just trusting it. You're not 100%
I
sure.
accept it as it is, right? Like, I know how tall I am because
You're
I can
trusting
see that there's a unit of measurement that was made.
You're
listen,
trusting
you
it,
ask
right?
me a question and you want to walk all over me while I'm talking and giving you the answer.
You haven't
Am I saying the wrong thing?
No, when you just said trusting it, so
Yeah.
why did you say trusting
I accept it. I accept it.
So when you mean you trust something,
is there another definition of trust that you want? When I say I accept it as an answer to your question, what do you mean by trust? Do you want another answer?
When you say trust, it's not 100% sure.
This is your issue because you don't trust your senses and the world around you. You have the trust issue. I do not.
Basis for empiricism, friend. First, you observe or experience directly, firsthand, through your senses.
Your mic's not working properly, T-Dub.
Oh, crud. Sorry.
Yeah, there's some crackling. Yeah. So my senses tell me whether the environment I'm in is hot or cold. My eyeballs tell me whether there is light or darkness surrounding me. I can look at an object and identify it. I trust my eyes that there's a couch in front of me. I trust my vestibular system that my house isn't moving right now. When there's an earthquake, then I trust my vestibular system that the earth is moving, my house is moving. I can also use my eyes to validate the motion that's being sensed by my vestibular system by watching the pictures swing, by watching the water in the glass that I have slosh back and forth. The dogs around me are freaking out also, so I'm hearing them freak out. I'm watching them freak out. I'm trusting my senses through the whole experience of an earthquake.
But still, aren't there some things that we can't sense?
What would you like to throw in the gears?
Unicorns. I can't sense unicorns.
Yeah, unicorns.
No, we're not talking. Yeah, we're not talking about Wi-Fi, are we?
We discover those things that are immediately apparent through the use of our senses. Maybe with a tool, like a thermometer or something similar. But we learn about their existence, like infrared light, through our senses.
We used to have a gentleman who would come in chat. Hang on. We used to have a gentleman who would come in chat and make this particular argument all the time, and I was always wondering why he would make this claim, right? He would say it simply, you stand up, you're vertical, okay? If you lean forward, you feel yourself leaning forward, you're no longer vertical. And when you walk forward, you're walking horizontally and perpendicular to vertical, okay? And you can tell when the floor or the ground underneath you starts to increase or incline in height, and then you would begin to feel yourself come up, or whenever you're going down a decline or going downstairs, you're now traveling in a different direction from horizontal, from perpendicular, from vertical. And I wondered why he would make this, and it was because he was blind. So the blind man is recognizing he's standing vertical, he's straight up. When he walks forward, he's walking horizontally. He knows when the ground underneath his feet is level or not. It's based on his senses. He never experienced the earth as a sphere. And he would never argue, the distance to the horizon or angles of shadows from the sun, because that wasn't part of his experience. His walking and his experience around him was his proof of flat earth, because it went with his senses.
Okay, AJ, you're up. What's going on?
Yeah.
I thought he was going to go eat.
No, I know I'm hungry. Literally, like it's been. I had my food at noon. I haven't eaten anything, and so yeah, I will just talk about this. I'm gonna talk about this later for sure. But right now, I feel like I have to go and get some food.
All right, we'll chew on the topic.
Go eat and come back. Okay, it's gonna recharge your brain a little bit. It's fine. Just go eat.
Yeah, for sure. But I'm not satisfied. The Earth is flat.
All right,
that's
good.
for sure.
Go eat.
That's fine.
Yeah. So, but it was a great talk, and yeah, it was a respectful conversation for sure. And yeah, I'll be back. Maybe I'm not sure today. And yeah, later for sure I'll be back.
Sounds
Thank
good.
you.
Thank you.
Have a good day, man. I appreciate the cordial conversation.
Yeah. Bye-bye. Have a nice day.
Peace.
Amir.
Hello.
What's your experience of the world around you, bud?
I don't know. I mean, it's a flat world. Flat Earth. What do you think?
Something?
I like when they come in and take the safe answer.
Is that something you know, or something you believe, or?
Yeah, I mean, I've seen enough of this world to know that it's flat. I mean, when you just look at the look outside, and you'll see that everything is flat. There's no curve, right?
Well, when I look outside, I see curvature of the Earth. What are you going to tell me? Yeah.
Where? Can you take a picture? I can see.
Yeah, here. I'm going to just search up a random GIF, because it'll support my claim.
Yeah, I don't think just looking outside is a sufficient answer to determine that the Earth is flat or a globe. I look outside, I have forests and mountains, valleys, all kinds of stuff.
The best way is just hop in an airplane and look out the window. It's definitely flat.
Yeah, definitely.
Yeah, but if it was a globe, would it not look flat from the height of an airplane?
Yeah.
Well, that's what Neil deGrasse Tyson says.
No, that's what the geometry says, bud.
Yeah, that too. Sometimes the people like Tyson are actually telling the truth.
Right on. Yeah, Matthew does that sometimes as well. Like a globe will say something that's completely false about the globe, and Matthew will call them out and say, hey, it's not right. Yeah, they do it sometimes.
Maybe I'm not using the right words, but it is really difficult for me to find a boat on the horizon in the GIF search.
So guys, is it flat or not? I need.
Oh yeah.
Answer.
I mean,
oh my god. Can we just vote? So that was easier. Who votes for flat?
Definitely flat.
Go ahead. I want to hear.
Well, if Amer says it's flat, then it's flat, right?
I don't know. I'm just looking for the answer. I need you guys to tell me if it's flat or not.
Well, you said it was flat, dude. So I'm gonna just take you at your word right now.
Do you think
Find someone else to vote. How would that work?
I mean, what was your opinion before you met me? You thought it was flat, or?
I don't think it's flat. I know it's flat.
And William, what do you think? Think about what? Is it flat? What? I don't know. Tell me.
You don't know? Why don't you know, Boot? Why don't you know?
I don't have knowledge like you, bro. I'm sorry.
Well, okay. Let's think of it this way. Do you know how tall you are, or do you think you know how tall you are, or do you believe how tall you are?
Oh my god. Oh my god, this room make me laugh.
How tall are you?
Sorry.
You don't need to open your mic every time you want to giggle. You can do it yourself quietly.
William, are you on like magic mushrooms or something? Like, what's the deal?
No.
William, did you saw the photos from International Space Station without fisheye, without fish leads? It looks kind of flat to me. What's your opinion on this one?
What is my opinion on photos from the ISS?
Yes, without fish lens, because without fish lens, photos looks kind of like the Earth is flat. What's your opinion?
Right.
So basically, all the photos from the space that's giving us that Earth looks like kind of globe. This is basically just like a GoPro lens, fish lens.
Right.
So then,
well, it's true that with a radius of 3,959 miles at the altitude of 250 miles, the horizon from that observer would be flat. They are seeing 3% or less of the Earth from that height. So, even on the heliocentric globe Earth, the ISS sees a flat horizon. So if the ISS sees a flat horizon, how is it that anybody has ever seen the Earth as a sphere?
Well, there are about 24 people who claim to have gone higher than the ISS, and they claim to have seen the Earth as a sphere, or at least circular.
Correct. So then the entire modern population is trusting how many people?
24 Apollo astronauts.
Okay. So everyone's trusting 24 Apollo astronauts when they say, yeah, I saw the Earth as a sphere. Everybody else has not seen the Earth as a sphere.
That's right.
They've seen flat horizons.
Right. I mean, it's not hard to trust those 24 because it fits within the paradigm that we already believe to be true. So, it's not a stretch.
Right. Well, now you've got the dilemma of globe believers denying that they actually went to the moon.
Yeah, some globe believers do
goes along with it.
and I saw some guy was going for these astronauts, for these guys who went to moon and asked them to give the God as something on the Bible, put their hand on the Bible and say that yes, the Earth is not flat, something like this. And most of them just say fuck you or no, or was very angry about this.
Oh, violent.
No, they weren't asked if the Earth was flat. They was asked, did you go to the moon? Did you walk on the moon? And they wouldn't do it.
Oh, yes.
So, not even the guys, the 24 that are claiming to have gone to the moon, will put their hand on the Bible and swear to the God they believe in, allegedly, that they walked on the moon. They would rather punch the individual rather than do the thing that would be the easiest. Right? So.
Oh, yeah. That's what Buzz Aldrin did once.
He should have asked him to swear on a square and compass.
Matthew, did you see the recent interview with the Russian astronaut?
No, what did he say? I don't speak Russian, but what was it about?
It was translated, yeah. He was saying if anyone tells you they've been to space, they're lying. I'll see if I can find the clip.
I thought that clip was a Polish astronaut from like 20 years ago.
No. This is a different one, a different astronaut.
Something more recent?
Yeah.
Has any Russian speaker verified what's being said? Because I don't speak Russian either. I'd like to see it anyway.
Ask ChatGPT to translate it for you.
I speak Russian.
Right. These days, AI is
right.
You guys use ChatGPT for everything else.
His name's Igor Volk. I'm not sure about the exact date that interview was conducted. It was some foreign TV station.
Did you call me you guys?
I don't know. Do you accept?
You guys, Globers.
Yeah, that's okay. I don't normally talk here, but I've been on for a couple of years now, pretty consistently. You probably haven't noticed, but that's fine. I've been a flat earther since 2017.
What convinced you?
Oh, I'd been hearing about it for a couple of years, and eventually I thought I'd have a good laugh and listen to a debate. And I don't know who it was, but it was with Stéphane Molyneux. He's a Canadian philosopher, and he's very good at debating philosophical ideas. And he debated a flat earther and completely got wiped out by him. He was, arguing from an emotional point of view. And so I looked into it further from there, looked at Eric Dubé, Math Powerland. But I started looking into it hardcore. Didn't take long to realize.
Nice, I think, yeah, that was when I got into it as well, 2017. Hearing Eddie Bravo talk about it on Rogan's podcast.
Just look into it, man. Just look into it.
It was easier to find information than you could actually do a search and find something.
Getting back to that now, if you go on YouTube and search something up, it comes up now. It's changing. Also, a lot of people have been telling me that they get recommended flat earth content from channels that they're not subscribed to, which is another good sign. But yeah, if you would, a few years ago, if you would type in the specific name of a video, for example, Eric Dubé, the history of flat earth, right? It wouldn't come up at all. You would have to scroll through pages and pages and pages of the propaganda playlist that they put up. And then you would go and find Eric Dubé's channel and then go into his video section and then do a specific search in there. Type the exact title in, still wouldn't come up. You'd have to scroll and scroll and scroll to eventually find it. But now if you type in Eric Dubé, Lost History of Flat Earth or whatever it's called, it comes up with that, and it comes up with, all his videos if you type his name in, or any other Taboo Conspiracy or anything. So definitely the algorithms just changed recently for the better.
Yeah, that's good. I haven't done any searching for a while. I just have them subscribed, but that's good for new people for sure.
I always hated it when my subscription list would reset and then I'd have to find everybody again.
Yeah, or when they just get banned or deleted. I think Discord, though, this is actually the most informative of all the flat Earth material there is. Of course, you have to sit through a lot of difficult conversations sometimes with Globers, but there's a lot of knowledgeable people here.
Well, I looked into flat Earth around the same time, 2017 or so. Maybe a little bit on Twitter before that. In the end, though, I decided that I think the globe model still has the best explanation for the observations we see.
Yeah, like all that flat water everywhere. Yeah, the globe explains that the best for sure.
No, the flat Earth explains the flat water better, but the globe Earth explains like the stars and astronomy stuff better.
Well, that's where the globe Earth would kind of came from, wasn't it? It was people like Pythagoras and those that follow him that inverted the celestial sphere into a terrestrial sphere, right? Not by going out and actually doing any empirical tests, right? Just through philosophical reasoning and things. So yeah, of course, it's based off the sky. That's what the globe is. It's like it's a sky coordinate system, essentially.
Like, well, how do you know the sky? Well, because of the sky. Well, how do you know what the sky's doing? Well, because of the globe. Globe, because sky, because globe.
Yeah, like even Atlas, like even before, like way before anyone even suggested that the Earth was a globe, right? They had the celestial sphere, and you've got like the sculptures of like Atlas and things like that, and he's carrying the globe on his shoulders. But that's people have changed that in more recent times, like. The original sculptures, like what he was actually carrying is the celestial sphere, right? Or even these flat earth cultures, right? They had celestial spheres. Like they, I forget what the word is for it, but they loved celestial spheres. It was like very like a symbolic thing, and you know, and then that turned into a coordinate system and whatnot. And then eventually they, you know, like Pythagoras was kind of like a crazy person. Okay, and him and his cult, they kind of allegedly, right? They thought spheres are the perfect shape, and because of the celestial sphere, that therefore the Earth must also be divine, like the celestial sphere, and also be a sphere. He also thought crazy things like that the universe was a musical instrument, and the planets gave out music and things like that, right? And then there was another Earth called Counter Earth. All sorts of crazy stuff, crazy model, crazy person, had all sorts of
right. The music of the spheres.
Yeah. But then I listened to some interviews with some historians from Cambridge and stuff like that. And they're like, basically everything that you get told in school about Pythagoras is just nonsense. They're like, we can barely find any proof that he existed at all. He's like the things that he was claimed to have came up with, right? Like the Pythagorean theorem and whatnot. He's like that he couldn't have even come up with that. They had a completely different numerical system, and I'll post the video in the side chat if anyone wants to have a look. It's not a long video. It's interesting though.
Yeah, that's the problem with ancient history. It's hard to find primary sources, and we just sort of have hints about what happened that long ago.
Yeah. Mm-hmm. Seems the Greeks love to make up these like mystical figures, like Eratosthenes, and you know the historian. He says like it is likely like that this Pythagoras guy did actually exist, but whether he actually did anything or said anything that they claimed, right? They have no idea. And whether he even suggested that the Earth could be a globe, there's no proof of that whatsoever. started an event. Hopefully some people come
Welcome, Harsha. What brings you in here today? Goodbye, Harsha.
Guys, there's nothing to discuss about it. Earth is round. Fuck you all.
Pussy.
Yeah, that was a pussy flex. Yeah, he's like, he comes in, I can beat you in an arm wrestle, and then just leaves. my mic still crackly?
No, it sounds better now, T-Dog.
Cheers, mate. Thank you.
Well, scroll back. You said planet. That's what you're getting questioned on. Nothing more, nothing less. You're assuming because ball's in sky, we are on a ball. I don't care what you call what we stand upon. The simple facts of it are, there is zero measured curvature. So if you wish to call it a sphere, an oblate spheroid, or even a curved landmass, you are incorrect. Muhammad, please understand, we don't need a model. We have reality. We don't compare models to models. We compare reality to your model, and then we show you it's wrong. For example, when you sit a globe or a sphere on a tabletop and we can witness that it has curvature, then we get our little legs and we run outside and test for the curvature. We prove that there is none, and that falsifies your ball tard. It's that simple. Why is he hung up on this model shit? If we give you a model, what is it going to do? Are you then going to compare it to a model of your ball tard? This is what I don't understand. Every one of these Glober kids comes in here bitching. You don't have a model. Cry, cry, cry. Where's your model? I want a model. We need a model. What is the necessity of the model, Muhammad? If you don't talk, I'm going to knock your text capabilities off you. So you're forced to. Why do you require a model, Muhammad?
To debunk it, I guess.
So, have you tried looking at the globe and debunking it?
Yes.
And how did you go?
There are graphics on the internet, you know.
So you're just gonna... The answer to have you tried debunking the globe is there's graphics on the internet. Holy shitballs. What has that got to do with the price of eggs in China?
You're not even giving me a picture to debunk it. I mean, that's insane.
Hold on. We're talking about you debunking the globe. How did you go with that? What was your results?
Okay, I'm not talking about globe. Let's say it's nonsense. Let's say it's a nonsense.
I was.
Okay. Let's say
okay,
it's
stop sidestepping. No, stop. Shut up. I'm not giving you a model. I want to know your requirements. Why do you need a model? And you said to me to debunk it. There is no model. Reality, outside, that is the model. Go outside and measure it if you want to debunk it. That's how it works. If you want to know how far it is across a lake, you measure it. If you want to know how much deviation there is across a horizontal over that particular lake, you measure it. This is up to you. That's the model. I don't know how or why you cannot comprehend this. So now let's press your globe against reality, because that's what's going to happen. Now, have you done this? Yes or no?
Oh my God. I just
I'm
wish
not going to help you.
Okay.
Have you compared the globe to reality? Yes or no?
Yes.
And what was the results?
It made sense.
So what did you test?
I didn't test anything.
I just asked you if you tested it. And your answer was yes.
I think you asked me that if you seen the globe, if you
If I ask, listen carefully. Have you seen the globe? Have you tested the globe? Or have you tested the globe against reality? See, they don't even sound the same.
Okay, I have not tested the globe. I have not seen the globe. Okay, that's the answer.
So here's you crying, begging, screaming out for a model, and you haven't even tested the one that you've already got that's claimed to be true, accurate, and real? Why wouldn't you go and rip that apart first before trying to beg for something else?
I don't need even to test them like Earth myself, you know? There are graphics that... Yeah,
no, why not? I'm not worried about the graphics. Let's just put that aside. Why not? Why don't you have to test the Earth?
Because the phenomenons I see and I observe in my daily life pretty make sense with the
So you see flat, you don't see any curvature, and you're telling us that it matches to a globe model. Are you on drugs?
Okay. First of all, you're
seriously
disrespectful. I'm so yeah.
No, you think about it. Use some logic. If you're telling me that you're witnessing a flat surface, if you're telling me you're witnessing a flat surface,
I have done this multiple times in this channel.
I know, and you're going to train up nicely. If you're telling me that you witness a flat surface and then that surface is curved, normally someone would say, you are crazy, you are on drugs, you have mental problems. If you tell anyone that you see a flat surface and then 5 seconds later tell them that that surface is curved, you have some kind of breakdown, my friend. There's some kind of gap between point A, I see a flat surface, and point B, I'm telling you it's curved. I don't know where the disconnect is, but you need to comprehend that, not me. I'm telling you about it. You can't see it.
Matrix, can I give it a shot with Mohammed?
No,
I'm having a hard time hearing where he's at there. Mohammed, do you want to just go give a quick recap where you are? Because we spoke the other day, right? You, DJ, and I, and some others, and it went very well. I'm curious where things went awry. Go ahead.
First of all, I want to say that dude have some serious problems in his personal life. I can assure you that. Okay, he gets so angry and so offensive at
dude.
The reason is you're thick as pig shit. If you can't understand something so simple as you saying, I see flat, but it's curved, and you can't see that's broken, I can't help you, my friend.
Mohammed, recap. What's going on?
Oh my God. Okay, listen. I have so much respect to you and Mr. DJ and people like that in his channel, but come on, that man. Listen, I have already... I'm not even here to talk about like globe Earth versus flat Earth. Okay, I'm just saying that how logic doesn't work against.
No, your logic is you require us to give you a model. I've instructed you to go and check reality. You don't like that. I don't know why. And all you can do is bitch.
Okay.
Maybe if you weren't a freaking child, it wouldn't happen. Haven't you worked that out yet?
Bro, just address the points, okay? If you don't want to talk globe or flat, then there's no real point talking here. Okay.
All he wants is a model. I've told him to go and measure reality. I asked him if he's questioned his reality next to his globe model. First off, he says yes, then he says no. Like, he's all over the place.
I'm sorry.
He can't track his own stuff. How the hell are we supposed to?
Okay, you said your point. May I ask who is muting me right here?
Doesn't matter.
Who is? No, because I want a reason, okay? Because I wasn't disrespectful or anything.
Doesn't matter, dude. I'd
love to know what your definition of disrespectful is.
Mohammed, as far as I know right now, there are these three hang on, let me finish, dude. There are 3 mods in the room right now.
Give me 2 minutes and
dude,
and mute after that, okay? Give me 2 minutes
I was mid-sentence, dude. I was mid-sentence. Okay. At the moment, there are 3 mods in the room. It could have been any one of us. It doesn't matter. Okay. I'm trying to ask you to clarify your point so we can move on. Yeah, Matrix is very loud. We get it. And a lot of us love him for it. Okay? Who cares?
Okay, first of all,
where are you at, man?
As much as I know, there had been lots of models of flat Earth. Each of them had been debunked by facts.
Okay.
But you, now that I asked for a model or graphic, which is the very basic request for someone that has an ideology. You guys have an ideology, okay? You guys have a theory. I'm just respectfully asking to show me how does your model work? A
Go
basic
outside
graphic,
and witness it for yourself.
I'm not talking to you.
That reality is it.
Mohammed, Matrix, give me a sec, dude. Okay. Mohammed, here's the thing. When you talk about all these models have been debunked and stuff, okay?
Yes.
All in question, for example, like the AE map, you know, where the little ball sun kind of goes around and shit. People have criticized that. Yeah, I get that. Okay. The problem is, dude, even if those models were debunked, okay, that enough is not sufficient to say that the premises are false, because the base premises, i.e., the ground is measured flat. Okay, you can construct a model from that if you want, or if somebody wants to do that. The sheer fact that somebody hasn't put something together like that is accurate does not negate these base principles.
Okay, may I answer?
So if someone comes to you and says nobody has an accurate model, okay, if that's not palatable enough for you, you want to wait till somebody does that. If anybody ever does, you're going to miss out on the fundamentals.
Okay, may I answer, please?
That's why Matrix is encouraging you, go outside, right, and get the fundamentals for yourself, because those are what are important. Go ahead.
Yes, may I answer, please?
Yep.
So previously, when I talked to you, you just said that if you somehow that in NASA or whatever institute is out there would allow you to give in this space and observe the globe Earth, you would say that, oh, it's cool. The Earth is globe.
That was not me. That was not me. That was
okay. It was another guy. So based on that, yeah, I don't know who was that, but it was in this channel. So I'm just saying, based on that claim, those measurements that you guys did might be wrong, right?
Yep. Sure.
So there is no certainty.
So I'd ask you. Well, hang on, dude. Hang on. We'd ask you how you would know that if they are. Now, if you're going to appeal to some point in the future where, you know, something may or may not even happen to back that statement, doesn't get us anywhere. But if you can show how you guys measure something, the method is erroneous, you know, you're doing some math wrong, or your instrumentation is not precise enough, blah, 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 we can talk about that in the here and now. The appeal to the future thing, oh, you might go to space, we entertain that just to kind of grease the conversation a little bit, okay? Because like the odds of that ever happening doesn't even really matter. Okay, so if you're gonna pivot yourself on that or anchor yourself to that, it's not going to take you very far.
Okay, first of all, to reach that point, we should actually argue what logic is, because I have already done logic in this channel, and this egg guy just got aggressive. Okay, so
your logic failed. We've already covered that quite comfortably.
I just want to
your logic, Mohammed, listen carefully.
Listen,
your logic. I see flat. I say curve. That's your logic.
I want you to consider an animal in your head, okay? Like, for example, horse. Consider horse in your head.
Why are we entertaining this, Mohammed? You see flat, you say curve. How is that logic? Please link that for us.
I'm not talking to you.
You're going to preach to him about logic because you're a freaking coward. You are preying on him being a nice guy. I'm not putting up with your bullshit. You've just said our logic fails in this channel, and I've just smashed your logic out of the friggin' ballpark. So, I see flat, I say curve. Explain that.
I don't talk to you, man. Why are you even talking? I'm not talking to you. I'm talking to a dark.
Then you have no right to speak logic in here.
You don't know logic, how logic works, so just silence.
Your logic. I see a flat surface and I think it's curved. That's your logic. Fucking broken.
Matrix, can I hear him how he would word it? Because I know sometimes we condense it. I want to hear his phrasing of it.
Okay, listen, Mr. 20 Cups. I don't know what your name is. Consider horse in your head. Okay, the animal horse. I'm now going to ask you 5 questions. Just assume that I don't know what animal in your head is, okay? What animal you're imagining. Okay. Does that animal live on land? Answer me.
Yes.
Okay. Does that animal, for example, I don't know, is tameable?
Tameable?
I mean, yeah, we can tame him and use him.
Oh, yeah.
Okay. Does it, like, for example, eat like vegetable?
Yeah.
Okay. So my point is, the way my logic works, one of the way that logic works is, from all those animals that live in this planet, okay, with these questions and these matchings, I'm trying to eliminate the animals that doesn't match to that question, okay?
Yeah,
deductive.
Yeah, you're using a deductive law, a deductive approach. Yeah.
Yeah. So question to question, I'm going to eliminate all of those animals, and only a few acceptable results will remain that perfectly match our concept. See what I mean? I mean, yeah. For example, there could have been, assume that I ask you, for example, 100 questions about that animal, and we reach the point that, okay, the answer is perfectly the horse, nothing else. Yes, there might be some kind of animal in this planet that match those questions too, okay? But we haven't discovered them yet. So all of us can agree that the perfect answer could be horse. It's a very acceptable answer. So yeah, I think the logics of how globe Earth works is kind of the same thing. Okay, let me explain. We match certain phenomena.
Hang on,
like,
dude. I get your point though, but can I interject quickly?
Yeah. I will just make my point in 1 sentence or 2 sentences. I don't want to talk too much. Yeah. For example, there are lots of phenomena that, for example, 24-hour sun in Antarctica, day and night, seasoning, I don't know, the rotation of stars, clockwise, counterclockwise, okay? With these questions, with these matchings, we eliminate other models. For example, we eliminate flat Earth. We eliminate triangle model.
There's no flat Earth model that's been given to you. So how can you eliminate something that has not been given to you?
Come on,
I mean,
come on.
It has been.
20. I'm just going to inform you. Yeah, we're just going to. I'm just going to inform you that this is just rinse, freaking repeat of last night.
I know. Of last night. I wasn't here last night with him. He was here 2 nights ago, I think.
It was the night before.
And he was actually
2 nights ago. My bad. Sorry. It's just rinse, repeat.
Okay. He was very cordial that other night. We were going over shit. I think he brought up something about a discussion between Whitsitt and no, who was it? Who was it, Mohammed? It was Professor Dave and somebody else, right?
What do you mean? What flat earther? What?
Remember when you were here the last time? you had some questions about a particular discussion between two individuals, one of them being Professor Dave and somebody else, right? That conversation went very, very well, man. Right? I'm just highlighting that to Matrix. We had a good time. So I don't see. I'm curious as to what would have made you flop and kind of get all panicky and shit and come back in here and ask us all this stuff and be accusatory and whatnot. You know what I mean? But before we get to that, though,
he's hung up on a handful of phenomena.
Yeah, let me answer your question, Mohammed. I just want to address something. Okay. So here's the problem with the analogy of the horse. Okay. You're asking me, okay, to come up with something in my head. Okay. Okay, you're asking me to come up with something in my head, and then we're trying to break it down of what it might be. Okay, it's not exactly analogous to what's going on the outside, because outside, it's not subject to the interpretation of people. Okay, like if I give you an apple, okay, or a fruit or an object, and ask you what shape it is, you might ask these series of questions, okay, but you're going to eventually apply some sort of methodology to check yourself, for example. Right? You take a ruler, you get certain dimensions of the thing, whatnot, and then based on certain definitions, all right, it's this, that, or the other thing. Right? You're kind of asking like does it quack like a duck? Does it walk like a duck? It must be a duck. That's kind of the approach you're taking. The issue is with this, though. Okay, if you want to go that route, if it curves like a ball, it would be a ball, but it doesn't curve like a ball, so it can't be a ball. If you want to simplify it to that, maybe you can critique that point, right? Because all the other things that you talk about, shit in the sky or whatnot, these are not the surface. Whatever's going on up there might not be happening on a curved surface if the curved surface is not there. However, you might want to conceptualize it. So if you want to go down that kind of simple A equals A, B equals B, or A equals B, A equals C, therefore B equals C type of thing, you have to address the main characteristic, which is surface curvature.
Yeah. First of all, I want to say
here's the thing.
Whatever.
This is what Matrix. Hang on, I just want to point out. This is what Matrix has been telling you. Okay, this entire time. You go outside. You get the measurement. It's not curved. It is curved. Whatnot. Now I just have a little bit more of a fluid way of expressing it to you. So hopefully it's stuck.
Okay. First of all, I want to say this in parentheses. Okay. Just not my whole point, just something in parentheses. So in response to that guy, it doesn't matter what kind of proof I bring on the table. Whatever, please don't interrupt me, okay? I just want to say this and move to my main point. Whatever proof I bring on the table, he would just say, might go and measure the flat earth. Whatever you say doesn't make sense. Just measure the flat earth. Okay, that's exactly what he says. So it doesn't matter what kind of proof I bring.
That's incorrect.
So
the proof that you can supply is measurement of the ground, is measurement of large bodies of water. If you go and get that and you show something contradictory to what we've got, then we have to look into it.
Okay. I said that in parentheses. And second, my main point. Whatever is happening in the sky, okay, is not some kind of magic or, I don't know, teleportation of sun or whatever. I know what you say. You say whatever is happening on the sky is happening above the flat earth, okay? But what I'm saying, whatever is happening right there is not some magic. It's happening every year for millions of years. We have observed it. We have observed the 24-hour sun for years, for millions of years. So it's not a trick. It's not a magic. It's something that we can use as an illusion. See what I mean?
Let's investigate this too. Jenna, do you want to take a shot at it?
Yeah, just very quickly, on the logic standpoint, you're talking about deductive reasoning. Sorry, we're talking about deductive reasoning. You're talking about inferences. inductive reasoning. You look up at the sky and you make an inference. We measure the floor. That's deductive reasoning. You have to understand the difference. Now, we're not making claims that the sky is magic. We just can't use deductive reasoning to figure out what it is. We can only make suggestions. Right? You understand the difference?
Yes, because you're saying that why just go and like talk about the skies when you can simply measure the ground. Okay, that's what are you saying? I'm saying
because that's the question.
Yes, and I'm saying with looking at the skies and observing the phenomenon year by year for like millions of years, there are lots of phenomena that show actually why they require the curvature of Earth for them to happen. You know what I mean? For example, the 24-hour sun in Antarctica needs 6 months. Okay, I'm sorry. Go on. I'm sorry.
No, that's fine. If there is a curved surface, we should easily be able to measure it. We don't measure any curvature. So whatever your inference is about the sky, and I don't know how you've come to this conclusion, to be honest with you, that it requires a curved surface to operate over, that's still your subjective opinion. We're going to have to deal with the surface because that's what we can have access to and that's what we can measure. You say it's only happening on a curved surface, so we should be able to measure that curved surface. We don't. That's the problem.
So as that phenomenon doesn't match your measurement, can't we say that maybe your measurements were wrong? For example, the 24-hour sun.
What does a thing in the sky, its motion, how does that change a surface?
Okay, that's literally what I said, because I said in order for that phenomenon to happen,
how it depends upon a surface.
Okay, I'm sorry if I'm not quite getting your question, but I'm just saying in order for that phenomenon to happen, it literally requires the curvature of the Earth. So I'm just saying.
Sorry, that's my question.
I'm just saying. Just finish my point. I just want to finish my
conclusion. How have you come to this conclusion?
Of how, for example, that phenomenon needs curvature?
Yeah.
Okay, so we have a big step forward right now because you are just literally saying that what I say matters, not just just throw them away because we have measurements. I appreciate that. So it needs curvature because, for example, in the North Pole, okay, in summer is pointing toward the sun. At the exact moment in the South Pole is having pure darkness, okay? While in North Pole, we have months of daylight and we can literally see the sun is circulating above us and not setting down. See what I mean?
Yeah, I'm aware of the phenomena, dude. Dude, I'm aware of the phenomena. Right?
Yeah, I just want to...
Let me help you. Let me help. At the moment, it feels like you're going to try and affirm the consequence. Right? You're going to point at the phenomena and say that this can only happen on a sphere. The Earth is a sphere because of this phenomena, or whichever way round you want to use the formal logical fallacy. It's what you're trying to do.
Yes, I'm trying to say that. If you give me just 30 seconds, I will just finish my point and give you the time. Okay?
Indeed, carry on.
Okay, thank you. So, this phenomenon happens exactly 6 months apart. Not exactly 6 months, maybe 4 months and stuff. But the thing is, in order for that phenomenon happen, we need a shape of something like a sphere. Not exactly maybe a sphere, or maybe, I don't know, a cube or something. Because that phenomenon needs this kind of model to work. In a flat Earth, it doesn't work. So,
what do you mean? Sorry, hold on. In a flat Earth, it doesn't work. Okay, when you've got a flat Earth in your head, what's that then? Because I'm assuming you've compared and contrast to reach your conclusion. Because at the moment, it just feels like your hand waving it away. You've got this thing that you keep saying, it won't happen, it won't work on a flat Earth. You keep saying that. I'm asking you how you've demonstrated that to be true.
Not only that,
You haven't done anything, have you?
I was going to ask about
Okay, I'm going to answer on a globe Earth.
No, dude, you say it couldn't happen on the flat Earth. I'm asking you how you've come to this conclusion. What tests have you done? What do you think the flat Earth is? You haven't done anything, have you?
Okay, so I'm going to answer your question of what you think the flat Earth is. First of all, I have searched and, like, for example, got multiple examples of flat Earth given straightly by the flat earthers themselves. Not, for example, some stupid guys trying to mock the flat Earth philosophy. Okay, those flat earthers themselves gave that models. So yeah, those models don't work. Like,
okay, well done for noticing that those models don't work. Okay, and so
that's wrong.
That model that shows an AE map with the north at the center and the circumference around the south like a disc is a straw man. That's really not what we in this channel claim. Yes, other people have said that they think this might be what the Earth is, but it's a map. It's a map of the globe. It's a map of the globe that's projected out from the north, so the circumference is the south. That's a globe map. It's not a flat Earth model. It's not a representation of what anybody thinks in here. What you're doing is what everybody's been doing for the last 10 years, burning down a model that no one really has made a claim to. Because you're probably late to the party, this model that we're claiming or you're claiming was already here when we got here, right? On YouTube videos and people talking about this and people talking about that. So that is a straw man. Just hope you understand. So when you're trying to say that it doesn't work on a flat Earth, yeah, on this straw man.
So let me just ask this question, okay? All of you guys believe that the Earth is flat. I mean, yeah, your main purpose is to fight the concept of the Earth being globe. I get that. This is your main fight. This is your main concept to prove that Earth is not globe. Whatever they are showing us is fake, okay? But all of you agree that the Earth is flat. So, as what you said, that you have measurements, you have logic, you have I don't know, tools, okay? So I think that's not much of a big request to just give me what you think the flat Earth is. A basic graphic. That's not much to ask. See what I mean?
That's really hard, dude. I personally don't have the skill set to do that. I can't make you a conception of a flat Earth. It's just horizontal and not moving with the stars in the sky above, in motion above the stationary Earth. Whatever motions they have, it's above a stationary Earth, dude. Now, I can't model this. There are loads of models out there that don't require the Earth to have any geometry, especially when we're making predictions about things in the sky, like the path of Jupiter, when we're going to see it, eclipses, both solar and lunar, don't require any Earth-based geometry. It's an observer-based system. So what I'm pointing out to you is, what I'm trying to point out to you is, you don't actually have a model with geometry in it. You've got an idea of a solar system with the Earth being a sphere, but that model doesn't make predictions, and that geometry isn't necessary to make the predictions of the things in the sky.
I'm sorry to cut you right there. I'm because I don't want you to get exhausted and make back and forth. I just want to search what literary geometry means, not just in common belief.
Earth measure.
Okay. So I just want you to just want to came into one conclusion, even it is so little, so unimportant, because I think it's even better than getting back and forth and just getting angry of nothing. So can you just admit that by not having a graphic acceptable by lots of the members of this channel and the whole flat earth community, you guys have just admitted that you have the lower hand compared to Globe Earth, because they have a graphic and you don't.
No. Do you understand what a my friend? Do you understand what a reification fallacy is?
No.
Okay, a reification fallacy, also known as the fallacy. You understand what I mean by fallacy, right? Bad logic.
No.
So it's also known as the fallacy of misplaced concretism. So to keep it simple, it's taking concepts and giving them physical attributes. Like, for example, love. Now, love isn't physical on itself, right? But if I was to reify it and gave it physical existence, I could maybe hurt somebody with it. Same thing with like a coordinate system, like height, width, and length. Now, that's just a convention to explain reality. It's not reality in and of itself. Same with a map, same with a model. The map or the model isn't the reality in and of itself. It's just a conceptual idea. Now, you should probably Google this, reification fallacy, because one of the first or second examples is the map is not the land. So the idea of reification fallacy is what you keep appealing to, which again is based on your subjective opinion and not based on empirical measurements. I'll put it simply for you. If you're actually going to make a model of reality, you're going to start by measuring the reality to then base your model on. You're going to make observations, you're going to make measurements, and you're going to want to know your location. To do all of these things, you're going to measure a flat Earth, because that's the base standard, right? When you make a map, you measure the land. When we measure the land, it's horizontal. So from that point onwards, you have to create something, I guess, either out of conceptual ideas and not based on the obvious reality that is measured. You keep relying on fallacious reasoning. We keep relying on the empirical measurements.
Okay, let me just ask you a question. I just want to know how a discussion with a flat earther actually works. So you're literally telling me that whenever I'm discussing with you or any flat earther, I should not bring any kind of phenomenon that happens in the world and only talk about measures. That's right?
Sorry, it depends on what you're questioning. What phenomena are you talking about?
Day and light, seasoning, 24-hour sun, the rotation of stars, whatever.
Yeah, you're going to beg the question of a model.
No, just answer me simply, because I think, don't overcomplicate anything. So I only have to talk about measures, not phenomena, right?
If the question
the way
is,
he's saying is like you
my
can.
friend.
Yeah.
Okay. The question is, what is the surface of the Earth? Not how do seasons work, not how do day and night cycles work. What is the surface description and measurement of the Earth? We answer that question by measuring the surface of the Earth. We don't make a claim to the sun, moon, and sky, why these things operate. You ask us those questions. Our claim's the Earth's flat.
So
But like if
your
if you're on a
simple
plane, you can
answer
see the
would
curvature.
be so your simple answer would be yes. Your simple answer would be yes. So
Yeah.
I should not talk about any kind of phenomenon and just talk about measures. Am I right?
Yeah, because the question is about the surface of the Earth, not about the
Nice.
sky. Yep.
Amazing. Finally, I get a simple answer from a flat earther. That's amazing. Thank you. I appreciate it. So we
No
will
worries.
not waste our
If you
time
want to
of
debate,
any
you can
kind of
just
phenomenon.
like you're not
Oh my
supposed to
God,
say
that's
like something
amazing. No,
like
I
that.
really appreciate it. I really appreciate it.
Yeah,
So
yeah,
I just
yeah.
found out that
What's
when
your
I'm
question?
talking to you guys, we should just talk about measures. I got. Thank you. So I'm gonna just research for these measurements and will talk to you back. Thanks for giving me a basic yes or no answer. Thank you
Okay,
so
okay.
much.
You can't use the internet
Hold
to.
on a second. Tombstone, give me a second, dude. Mohammed, I just want to reiterate, okay? The other night when you were in here with myself and DJ, I could tell you, man, that that's all we were trying to bring up and address to you and put forth to you. Okay, so for you to say, "Oh, the first time I got an answer," it's like, bro, what the fuck are you talking about? We spoke for a long ass
Bro, you
motherfucking
never.
time, man.
No,
What are you
you never
talking about?
directly told me. You never directly told me that all of that stuff doesn't matter. We should only talk about measures. If you said that to me, I wouldn't waste your time and my time talking about these obvious phenomenons. Okay?
You are joking.
My God,
You are
no,
100%
dude, that's not the
joking.
case. That's not the case, dude. Every time you've brought something up, we're like, dude, we can't necessarily talk about that because number one, it's either non sequitur or it's indirect or whatever. We should go to the Earth itself and measure it. Shit like that has been had been reiterated to you several times in different ways. Now, if we didn't phrase it with the word, we should measure it every time, it was certainly indicated that. Now, if you don't believe me, go back on the live stream, okay, and point out where we didn't do that. Okay? The whole effort was to hone in on this reality. So, I mean, dude, if you didn't understand it, then you didn't understand it, that's fine. But to say that, for example, that entire conversation the other night was fruitless for you because we didn't do that one thing, I think it's a very disingenuous move, but that's just my take. All right? Carry on.
Yeah, I appreciate it, but if you just directly told me that Mohammed, stop talking about anything. Whatever you are talking about might be correct, might not be correct, but let's please talk about that later and just talk about measurements. If you said that, the thing would be way more easy. You are telling
I
me that
did.
okay, we tried
Multiple
to tell
times
you
in a row. You cried about it. My next level is to get a piece of paper and draw it in crayon. Go outside and measure it yourself and then hand it to you, making sure I didn't give you the crayon so you'd eat the fucking thing. That's the levels I was at with you. And now you're telling Jedi that he's done the right thing by telling you to go and do measurements. Well, obviously he likes Jedi more than everyone else. Thank you, Jedi.
Because
You got through to him.
Yeah. I just got a very, very constructive and productive conclusion in my head that I'm not talking about other guys, just you as Mr. Egg, think that everything that's happening in above the skies is magic and could be Superman or I don't know.
I never mentioned anything about magic, you fucking liar.
Okay. So yeah, I will talk about.
This is weird. No one said anything about magic, dude. At best, we spoke about the difference between inductive and deductive reasoning. The fuck?
He doesn't like me because I'm how do we word this? Oh yeah, very straightforward. I suppose as a brutally honest is another one I get every now and then. I get that a lot actually. Loud, I've been called that a few times. But that was just a downright lie, Mohammed. You know that as well as I do. I at no stage have mentioned anything about magic.
Simply
Mohammed,
said,
can you
he doesn't.
Sorry, man. Go ahead.
Simply said, he doesn't know. How is it that he can make a claim on how something works if he does not know how it works? If he's never been there to measure it, take a sample of it, test it, actually see what it looks like, other than just having the position that everybody else has, which is just standing on the surface of the earth and looking up at the lights in the sky. How is it he's supposed to say this is what it is and this is how it works? He can't. The globe claims that they know exactly what everything is in the sky. They know all of the whys, all of the whats, and they've never been there to take the measurements, to take the samples. The only thing they did was look in the sky, make a story, and then use some math to reify what they're saying.
Mohammed, can I ask you, dude? Since we last spoke, right, in the last 24 hours or so, how much fucking Professor Dave did you watch?
Nothing. Literally nothing.
Nothing? Did you watch any
Yeah, I promise.
other kind of like, big wig, discussions on this?
Not discussions. I just watched some reacts. Some reacts.
Reactions. So you just you flat Earth and then started watching what you found.
Yeah. First of all, I want to apologize for the last sentence I used. I mean, that's a little bit emotional, but yeah, I think I know what to search for. So yeah, thanks.
Could you answer me this? Could you give like a short list of names of the channels that you watch? So we may or may not be familiar with them.
I mean, I forgot the names, but it was a black dude, black like flat earther, some globe earthers. I forgot the names, but one of them was, for example, Austin Whitlist, if I'm pronouncing his name right, and yeah, stuff like that.
Okay, so you watched some Witsit.
Yeah.
Okay. And that's it?
No. Other flat earthers too. Not much, but I forgot the name. There was a black dude. I forgot
What about Globe?
the name.
What about Globeside?
Globe Earther, one of them was obviously this Professor Dave guy, and the other was, I again forgot the name. He was a and a middle-aged guy. I forgot the name too.
Okay.
That's my fault, actually.
All right. I just asked because the arguments that you've been putting forward are very, very common, right? And a lot of people that would use them would cite some of these guys, right? At least the other night when you came in and brought in Professor Dave, right? You were open about, hey, look, this is something I heard. I want you guys to hear the conversation so we can critique it, yada, yada, yada. Right? It wasn't you adopting his argument as being true and then trying to argue it on his behalf, so to speak. But the way you were speaking this evening did sound like that. So I was just curious, if you had seen something else and you're like, oh shit, this is a slam dunk, and then tried to come in here with it or something.
First of all, this whole 24-hour sun thing that I brought on the table was not just from him. I, watched lots of reels and shorts and videos that, made sense to me personally. And when I said that, okay, guys, let's listen to his debate, Professor Dave, it wasn't because I was hiding behind him. First of all, my English is not that good, and I apologize for that. And he could literally, say things in a more fluent way that won't take the discussion to nowhere. I thought in that case it would be something pointful.
Don't worry about that, man. It's coming through just fine, I think.
Yeah.
But do you recognize that pointing to the sun, right, and trying to argue from there is at best boring It doesn't say anything. It's non sequitur. It's tangential to the topic at hand. Do you understand that part?
I mean, to be honest, I don't want to but no, it doesn't make sense to me because, as I said, in order for that phenomenon to take place, they literally require the curvature, and I know that you guys say that could be anything. That could be anything. But what matters is measurements of the ground.
Hang on, dude.
I get it. I see your point of view. But
so, if these things literally require curvature, right, Mohammed? You just said that these phenomena literally require curvature, and we don't measure curvature. What does that say for your phenomena?
I mean, obviously there had been some measurements by scientists, not by me, but
if your phenomena literally require curvature and there is zero measured curvature, what does that say about your phenomena?
Yeah, that was the conclusion. I just want to prove that your measurements might be wrong. That's it.
That would be a fair.
You said that scientists have measured.
Yeah.
Is that what you said, Mohammed?
That was off topic. Yeah, that was off topic. I'm sorry about that.
No, it's fine. If you say scientists have measured, our flat Earth measurements are incorrect. Other people have measured the surface of the Earth and measured curvature. Have you seen those?
No, personally, no.
Okay, so why'd you say it then?
I was just trying to say that.
Sorry, dude. Before I get upset, at best, I'll give you that's anecdotal. Now, that's at best. At worst, you're just lying and making stuff up now.
No, I don't need to lie.
So you have seen it then. The measurements that the scientists have taken that prove that we're wrong, that the Earth is curved, you've seen those measurements. Be honest, dude.
Yeah, I mean, okay. My intention was that, very probably those scientists must have measured. Okay, I haven't seen them.
Okay, yeah. Very probably you hope that someone has measured Earth curvature. Okay. We thought that too 10 years ago, and we haven't found that yet. It's not like we're not looking down certain corridors or not Googling certain terms.
Yeah,
when we look for the proof that they should have when they say the surface of the Earth is curved, which would be them directly measuring the curvature of the Earth, we don't find any. At best, we find reification based on presuppositions and calculations, never measurements.
Yeah, that makes sense. Yeah. Okay. Yeah. I mean, and that is exactly what I'm trying to do, to find those measurements and say that your measurements were probably wrong.
Okay. Just before I disappear, they're not our measurements. They're everybody's measurements. Me, you, and everybody on the surface of the Earth measure a horizontal Earth. That's how we get level with the Earth. When we build, constructions and so on, we build from a level. We get that level because that's what we measure from the Earth. So it's not just me and Matrix and the people in this channel saying when we measure the Earth it's flat. It'll be you as well. It'll be everybody all the time because that's how surveying's done.
Yeah. Just I'm just being curious. I just want to clarify myself. Okay, it's not like I'm debating or anything because I don't know much about this stuff. May I ask how just you measure? It was with calculations or like with tools and stuff?
With tools, with surveying tools. So electromagnetic signals, direct line of sight technology, usually known as lasers. So surveying
would you
tools.
please Yeah, would you please write the resource for me that the time that event happened and you measured the Earth, so I literally search for it.
Posted. I gave you a huge list. And I gave you the citation saying that the distance to the horizon can be measured with 1.2 times the square root of the observation height in feet. So it's not our measurement, it's geometry. They've given you a radius value, it has to fit the geometry.
Yeah. Okay, I get it. So this is the last one, is it? The global geometry and measurement.
Go to where I posted, right? At 11 minutes after the hour. I gave you a screenshot from me asking the question to the Google, and the AI gave me the response. Okay.
Oh, I see. Yes.
And right after that is a laundry list of people using lasers and checking the Earth for curvature.
Yeah.
In each of their videos, they go into detail on what they did. If it says Dr. John D., he's extensive in his explanation and the descriptions of the environment he's testing. If you see the FE core, that's 25 miles. That's field engineer core, not flat earth core. And they extensively measure the environment and get great details on the environment. They even lay it out in a PDF. And in their video, they use the PDF to describe the thing that they were doing.
Yeah, I see.
All right. And then the point of what we're saying is that you can do this yourself. You can scrutinize yourself as much as you want.
I see. Yeah. I will search for them. Thank you. And for another time, I just want to uh, apologize for the last sentence I said about Magic and Superman and Wonder Woman and stuff like that. It was so unconsiderate about me. I apologize. And yeah, thank you guys. Thank you so much.
Thank you.
I mean, there's so many different directions that we could go in this conversation, just because a lot of us have researched a lot over the years. But typically in here, like we can expand a little bit on Sundays, but typically in here we like to stick to the nature of the earth.
Mm-hmm. So, like, is it like a recurring sessions that you guys talk about stuff, or like?
Oh yeah, no, we probably have about 100 people a day coming in here, different people. Some people are repeat people, but we'll have anywhere from like 20 people one day, and then we'll have like just people all day long coming in and having conversations with them. And we live stream 24/7, just so you know. There's not always a bot in here, but whenever there's a conversation going on, there's a few of our guys that own these accounts that say YouTube on them, and they bring those bots in here to record and live stream out to YouTube. We do it for other people, as an outreach, so other people who are on YouTube can watch us and find us. But more importantly, like, you wouldn't believe how many people actually lie in these conversations, and we have to go back to the YouTube bot and screen record what they said, and then come back and show them what they said. So, and it's there for your protection too. If you think we're lying, you can go to the YouTube bot, rewind, and find out where we were lying at.
Hey, Sonic. So
But
I kind of go by Occam's razor on things. So when I'm looking at the sun and moon, there's a couple things that I see them. They measure the same angular size. They cause objects to cast shadows that are the same size. They cross the sky at almost the same speed, and they leave the same analemma patterns over time. So what would you tell me to prove that the sun is 400 times larger than the moon and 400 times further away from Earth than the moon?
Okay, so about the first, I said start point by point. So you mentioned the speed is the same for sun, the moon, in the sky, right? You mean it's during the day, right? So during the day, if you like during this day, like sun almost moves with the same speed as the moon, and this is not just for these two. Like during the night, all the stars and the moon and the sun, they all move with the same speed. That's why, because they're not moving. Actually, the Earth is rotating during the day. So, but in general, larger scale, we also are rotating around the sun. So that's why the speed of sun is not exactly the same as the speed of the moon. And also, the moon is rotating around the Earth. So that's for the speed. So if the speed during the day looks the same because we are rotating, they're not moving. For the angular size, I don't have any reasoning why the angular sizes are the same. I don't think there's that much. It's more like a coincidence, which is fine that I say that. But angular sizes just depend on the size and the distance. So it happens to be that the distance of the moon is such that the angular areas become the same. And there was another point you mentioned. What was the other one?
That if I have a tree out in the front of my house and the sun and moon are at 45 degrees angles in the sky, and if I measure the shadow that they cast at daytime and nighttime, they're almost identical, the same size on the ground.
The shadow of the moon and shadow of the sun, right?
Yeah. When the moon's light hits a tree, it'll cast a shadow of the tree on the ground, and during the day and during the night, that shadow is almost identically the same size.
Yeah. So let's say you have a light bulb in your room, and you put it like an object on the table, and you cast a shadow with the flashlight, whatever. And as you move away the flashlight, the shadow becomes smaller, right? Because of the angular area, right?
No, but as the shadow get larger, they don't get smaller. I've never seen a shadow decrease in size. You'll never cause your hand. You can never cause your hand to cast a shadow smaller than your hand. That's what I'm saying.
No, not a smaller. No, exactly. Not smaller than your hand. But it's always bigger than your hand, right? But as you move with the flashlight, it becomes closer to your hand. So, but the thing is that when the flashlight is closed, the difference is large. So, you move the flashlight a little bit, and the shadow decreases. The size of the shadow decreases a lot. But as you go away, the difference becomes less. So the farther you go, the relation between the distance you travel and the way that shadow gets smaller is becoming smaller. And at a very large distance, almost infinity, let's say, not infinity, of course, but at a very large distance, you don't see the difference in the shadows based on the distance because they're so far away. Now, if you move the sun 1 kilometer away, you don't see change in the shadow because it's so far away that the shadow of your hand is almost, if it's also perpendicular, is almost the same size as your hand because it's so far away that the light rays you see, they're not angled, they're parallel. So you almost see light as a parallel lines. So all the shadows are the same size.
So if I put a flashlight above my hand, 1 foot above my hand, and I look at the shadow of my hand on the ground, and then I do the same thing with a street light that's 30 feet up, they're not going to be the same size, the shadow of my hand. I've done this.
Yeah, but if you continue, you said that it's not going to be smaller than your hand, right? The shadow is not going to be smaller than your hand, right? Always.
Right.
But it becomes smaller and smaller. It is always bigger than your hand size, but it's going to become smaller and smaller. So let's say I take the lamppost and move it like thousands of kilometers, like vertically, so it's like far, far away. The shadow still is bigger than your hand, right?
Yeah, so you think it'll be the same size as if the flashlight was a foot away? You can think it's possible for them to cast the same shadow size of my hand? Is that what you're saying?
No, but when the lamppost is 1,000 kilometers away, and when it's 2,000 kilometers away, the difference is very, 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 very small. Because as the farther you get, the difference in the distance, the difference in the shadows becomes smaller. It is still becoming smaller, but because as I said, it can't get smaller than your hand, it should change less and less. So it's not a linear thing. It's not that like, oh, if I moved it like 1 meter away, the shadow became like half. If I do it again, it's going to become half again. No, it's going to become like two-thirds. Like the ratio is going to be closer to 1 every time. So at the limit of very, very large distance, the ratio is almost 1. Did I make my point?
Sure, I got you. So I wanted to ask you a question after this one, but are you familiar with the Analemma patterns of the moon and sun over time?
I have to, and how do you spell it? I'm not sure if maybe
ANALEMMA. It's like the sun and moon. They'll create a figure 8 pattern in the sky when you do a time lapse. You take a picture every day at noon for like 6 months.
Back and forth. I know. Yeah. I know that. Yeah, I mentioned it when I was talking about Mars. I think similar to that. But yeah, go ahead.
So the sun and moon create the same Analemma patterns, and basically pretty much the same size. So considering those 4 things I said to you, why should I believe that the sun is 400 times larger than the moon and 400 times further away?
That's a very good point. Let me just look at the Analemma. History, attribution, globe.
Yeah, like the moon will create that figure 8 Analemma once a month. It'll do it like 12 or 13 times a year, and then the sun will do it once a year. But they're the same size.
Okay. What's the reason behind it? Showing the position of the sun. I have to look up the moon one. Here is just the sun's declination to. Okay, let me just check the. This is just sun. I have to check the moon Analemma.
Because I'm a simple guy. I like Occam's razor, and those 4 things lead me to believe that these 2 objects are about the same size and crossing the sky at about the same speed.
Yeah. So the problem with that is that also you have eclipses, right?
Sure. You mean like when the moon turns red? Is that what you're talking about? An eclipse?
I care about the sun version. The solar.
Well, there's problems with that, with the 2,000 mile wide moon only casting a 60 mile wide shadow on Earth. That's that's not possible for something to cast a shadow that is about 20 times smaller than its size. For example, that would be like me holding up a bowling ball and then having it cast a shadow the size of a marble on the ground.
Because it's so far away. Because so far away. It's all these values are astronomical, no pun intended.
Well, I mean, you're saying the light rays from the sun are parallel when during the solar eclipse. So then the moon should be casting a 2,000 mile wide shadow across Earth, but we only have a 60 mile wide path of totality.
So you have the sun, you have the moon.
But hold on, we got a little off in the weeds.
Yeah.
I was just. Did you check out the Analemma patterns?
I'm reading about this to measure.
You see how they create that same figure 8?
So here it says that this is because of tilt in the axis of rotation of Earth. So again, this is something about the Earth rotation. So if it's going to affect everything within the sky the same, because it's about the Earth rotating differently. There's a tilt in the axis of rotation. And so it's
Okay,
gonna
well,
be the
there's
same
quite
for
a
the
few
stars.
assumptions there that are unprovable: tilt and axis rotation. And you also said the moon was, or that we were rotating around the sun. That's three things you said that are all assumptions. But my question is, why should I believe that the sun is 400 times larger than the moon and 400 times further away, considering the four things that I said that would lead me to believe just the opposite, that they're very similar in size and velocity across the sky?
Yeah. Okay. So you guys sent a lot of videos. I try to watch some of them. I'm gonna send just one video, and I would appreciate if you want to watch it. This interesting video is from a math guy. Is you know Terence Tao? He's like probably, I'm not gonna glaze him, but he's probably one of the smartest people alive. But he talks about distances in cosmos and how do we measure. And I know like you guys have problems with this type of reasoning, but I just would love you to also watch this one.
Fair enough, I'll watch it. But you don't actually have anything to prove that, then, right? You want me to watch a video? Is that what you're saying?
Guys, you sent me like 20
Did you see
videos.
the one where he fucked up the math? Did you see the Terrence Tao one where he fucked up the math when talking about Al Baruni? It's pretty pretty hilarious.
Sonic, you're gonna love
Fields
India.
Metal when I can't do geometry.
What are they talking about?
Yeah,
Yeah,
in this little series he does about the heliocentric cosmology nonsense. So it's a whole series that he did. And in one of it, he talks about Al Baruni measuring the radius, and he fucked up the geometry.
Terry Tao or
I'll find it. Yeah, Terence Tao. Yeah, guy you're idolizing.
Okay.
Let me ask you this, Sonic. If the first cosmic rung is wrong, or is the rest of the cosmic ladder completely wrong?
Yeah, of course. It just breaks the. So yeah, all of this video is based also on the coverage of the Earth.
What's the first cosmic run?
It's the radius of the Earth, which also I have one for that. Have you guys probably heard of it? It's like the most famous one. I want to hear your opinion on that. But it's the angle of the shadow thing, that different places have different angle of the shadow. So if you assume that
Eratosthenes?
Yeah, probably yes.
When Eratosthenes did the observation, was he on the same latitude or the same longitude?
I believe he did it in two cities on the same. I'm not sure what he did, but he was close to the value we have, and now we can also do that every position we want. Like we have the map, and we can look it online, like what are the angles of the sun at a given point, and we just can do it ourselves. But
yeah, they don't use a globe for that, though. They don't use a globe for that. There's a lot of things, I've been listening for a while, and there's a lot of things you believe to be true which actually aren't true. So if you use like time and date or some calc, there's no globe in the mathematics to figure out where the sun's position is.
No.
And in fact, latitude and longitude has nothing to do with the surface of the Earth.
So no, he mentioned the cosmic ladder, and he said, what if the first step is wrong, so everything else is going to be wrong? I said,
radius that no one ever measured. Yeah, that. So the first step isn't even known because no one's ever measured the radius.
So I'm saying you can measure it with the angle of the shadow, right?
Yeah, how are you going to measure the radius of the Earth from the angle of the shadow?
So you see the light.
Don't you have to presuppose a couple things?
Okay, let's start. Okay, first.
Do you have to presuppose a couple things?
We talked about.
You have to presuppose a couple things, dude. Yes or no?
Can you talk like a human? I'm getting
yes or no.
I'm getting it's obnoxious. Okay, what do you mean by that?
Do you have to presuppose things to measure a radius if you're just measuring? Because what you're actually measuring is right? The length of a shadow, and then calculating an angle that triangle creates, right? Okay.
Yeah.
But you have to assume certain things about the source of light.
Yeah. So okay, I'm gonna say I'm gonna say my assumption. I'm gonna say my reason for my assumption. So I'm gonna assume the light ray is casting. It has almost parallel light rays. And the reason for that is that the shadow argument, right? At the noon, if you look at the shadow of your hand, it's the same size as your hand.
That's circular reasoning, dude.
Yeah.
How is it
Here, I'm gonna show you an image. Put in you.
Well, I was just going to say, like, you're saying the shadows demonstrate their parallel because they're different, what, angles? But that's the thing you're trying to prove in the first place.
No, guys.
I'm gonna show you a picture of my countertop in my kitchen, and I just want you to tell me whether or not my countertop is spherical or flat. Hold on, I'm almost got it.
Okay, that's interesting. I want to take a guess.
Here we go, right here. If you could do me a favor and tell me if because the shadows are 3 different lengths on my countertop.
Yeah.
We're presupposing my countertop is a sphere.
No.
Can you tell me the radius of my countertop?
Okay, the thing I said about the different sides of the shadows, I was first telling that the light rays on the surface of on the Earth, on our scale, humans that we see are flat, are also almost parallel because.
How do you know that?
Why would you?
Yeah, but how do you know that?
Okay. So I say it's parallel. Okay, so how do you know that like there's a relation between this as
that's not an answer, dude. How do you know they're parallel, bro?
I'm saying there is a relation between the distance and between the light rays being parallel and the relation between the shadow, right?
How do you know that? How do you know anything you're saying? You're just jumping assumption. You're piling assumption on assumption on assumption.
I can't go back. I can't draw lines and triangles and do some.
Yeah, that's great.
Crazy man. That's crazy.
Yeah, light's not rays, and the light doesn't pass through the air in a straight line, right?
No, if the area, like if you're at on the surface and you're looking at constant density, is not gonna refract, so it's fine. It's only when you are
constant density. Where's that at?
Up here.
I want to go do some laser tests there.
Yeah, you have to do laser tests. Yeah, but it's almost a line, right? Like when you point a laser at the back of your yard, like it's line, like it's already enough. So
look, all I'm saying is there's a lot of things that are happening here, right? So you're presupposing you're presupposing that the rays of light are parallel, and you're getting the distance. See, this is the problem with the cosmic distance ladder. You're getting the distance to the sun from the radius of the Earth, and you're getting the radius of the Earth from the distance of the sun. Circular logic. The rest of the cosmic distance ladder is built off this the astronomical unit, right? Parallax, size of the orbit, Cepheid variables, the redshift. All these things are built upon. They're founded on the radius, right? But that radius is not actually known. It's never been measured and can't even be measured in principle. Has to be assumed to exist. You have to assume the Earth's a ball and presuppose there's a radius.
Okay, can you say anything about Earth without pre-assumptions? Okay, say something about Earth.
Earth looks flat.
Why?
Why? Doesn't matter why. That's what it looks like.
So you see something, I think it's like, why do you think the light goes
this straight? This is a qualitative description. I don't need to know why.
So you believe that qualitative description only, like there is no quantitative description that you can have about.
Well, we have that too. We have that as well. We can measure the surface of the Earth and see if it's curving, and if it's not a ball. It's pretty simple. Doesn't matter what the star, suns, moon, and the whole thing you've been talking about. I've been listening to 40 minutes of this puke, right? You talk about tilt of the Earth and orbits and distance of the sun. I hate to tell you, no one in the history of mankind has ever observed an orbit of anything ever, not even once.
That's what they do.
Okay. Show me. Post the video of actual video of a full orbit right now.
Post orbit of the
anything,
like a planet.
Literally anything.
Okay, dude, lawyer, like you don't have to yell, okay?
Dude, I said anything.
I'm looking it up. Okay, we want to orbit of Mars, let's say. Time lapse. Should be good, right?
Yeah, so you're going to show Mars orbiting the sun.
Okay, I'm not on the sun. That's the thing. I'm not on the Earth.
Where would you have to be to see that?
You never see it because you're on the
Okay,
on the Earth.
exactly. That's what my point is. No one's ever actually observed an orbit, ever. No one's seen the Earth orbit the moon. No one's seen the Earth orbit the sun. No one's seen a planet orbit the sun. No one's seen a moon freaking orbit a planet. No one has ever seen and observed an orbit. Period.
I mean,
that's not an opinion.
Moons of Jupiter also orbit, but whatever.
But you don't see a full orbit, do you? You see you see lights pass in front of Jupiter and then disappear. You don't see them go back the other way. You don't see them go behind Jupiter, right? You only see them for a period of time going in one direction.
But again,
for all you know, they could be in a big circle in front of Jupiter. You have no idea.
Yeah, but it's like
the fact is, no one's ever observed an orbit. That's a fact. It's not my opinion. But you take it as holy writ that there are orbits. But science is empirical, right? It's based upon empirical observation.
Okay, have you looked at the rings of Saturn? They do like that's also light, right? Although it looks like that's also light. I just want to make sure like everything is just a light source on this model. Even
what model? We're not talking about models.
The flat Earth model.
There is no flat Earth model.
So what's
in fact, there's no globe Earth model.
So there's a model.
What we're talking about right now is a heliocentric model. Right?
Yeah.
Which is a model of planets and orbits and all that crap. All circling the sun or orbiting or making elliptical orbits around the sun, except for the Earth is making a circle and the moon's making a circle around Earth. Kind of weird. Those two things happen to be circles, but everything else is ellipses. But never mind that. The point is that the fundamental claims of the Keplerian model has never actually been observed, not even the first thing. Now, you can construct a mathematical model assuming that these things orbit the sun, but there's other ones. So Travis just posted epicycles. There's another one called Tycho Brahe's model, in which the sun orbits the Earth and the planets orbit the sun, which also works. So for any data set, there's potentially an infinite number of models.
Yeah, that's correct. But there is like some I don't want to say philosophical, but there is some reasoning that people believe some. So let's say on your house, like you use electricity, right? And if I ask you why do you use electricity, like how do you believe in electricity? Like how do you think this works? Like what's electricity? Like do you have explanation of electricity?
I have access to electricity.
Okay, what is electricity?
I'm not looking at my wire from a billion light years away.
No. So what's in your wire? What's in your wire? What's creating the current?
Well, technically, the electricity comes from outside the wire.
So what's in the wire?
There is no current in the wire. It's on the surface.
So what's on the surface? What's current? That's what I'm asking.
Well, depends.
Like on what?
What's current?
Pressure.
Yeah, what's current? Pressure of what? Do you feel the pressure?
Well, there's electrical potential created between a positive and a negative.
Mm-hmm.
And that creates a force. Well, this is just a model. So this model, it creates a force that makes all the electrons pull in one direction. Okay, and that flow creates a current. Now, the drift velocity of the electron is pretty slow, but it's the combined action of all the electrons, which are in the probably quadrillions in a 10-foot wire.
Yeah. Have you seen an electron?
No. What's that got to do? You're making listen, okay? You're not going to construct this false equivalence nonsense. The fact is, no one's ever observed an orbit, okay? People have observed direct electrons. We have access to the things you're talking about. We have physical access to them where we can touch them, manipulate them, do cause and effect experiments on them. You can't do any of that with the heliocentric model or any of the other models. They're purely observational. We're going to sit there and say X causes Y when we can't even do the experiment to figure this out. And you know what? Copernicus admitted this way back when. It's only the modern people that are denialists and claim they have causes.
So we also have our understanding of orbits is that the gravity.
What understanding? You don't understand anything. You don't understand anything. You just tell yourself you understand. You understand your own bullshit. That's what you understand. Or somebody else's bullshit because you didn't invent this stuff.
I didn't invent this stuff. You didn't invent this stuff.
Yeah, I know. That's what blows my mind is that you guys white knight for ideas that aren't even yours, which is crazy.
I spent my whole life with these ideas. That's the thing. I believe in them because I spent my life with them, and
me too.
See how some of them explain some stuff and some of them they don't. But I think because the reason that we have electricity is that we believe in that the electrons exist, that the magnetic field exists, that the electric field exists, and we never see them.
We don't need electrons to have a theory of electricity. It predates when J.J. Thomson discovered the electron. We had whole theories. We had models of electricity way before. We don't need the electron for it.
So who invented
J.J. Thomson discovered the electron with a cold cathode back in the late 1800s.
But you need electric field and magnetic fields, right?
It's just a model. That's Maxwell's model.
Yeah, Maxwell's model. So he believed
there's other ones. There's other ones as well.
Yep.
So there's the Weber model where there's no fields and it's all particles or whatever.
Yeah, there's Weber
charges.
Model. The problem with Weber model is that I'm not studying that, but I believe that it doesn't predict electromagnetic waves. For waves, you need fields. So radio waves.
It doesn't predict what? Doesn't predict radio waves?
Yeah.
Why would it?
So radio waves, light, all of these guys can be explained with electromagnetism. So that's how radios work. You just have a wire that takes the oscillation of the field, which is the radio wave, and turns it becomes a current. And when you measure the current, you get the signal. So you need the EM theory. You need to believe that there's a field because you can send radio waves with it. You can listen to the radio with it. You never see it. You will never see the field.
Well, I mean, I don't know. There's more modern versions of it. Weaver's model's been worked on, so there's more modern iterations of it. I don't know where the state of that's at. A guy that's been working on is a physicist named Andre. What the fuck's his name? Andre Agassiz. He's a Portuguese physicist. He's written multiple volumes on this shit.
Sorry, man. Andre Agassi's a tennis player, Indio. All right.
Oh no, dude. Fuck you, bro.
I can't believe
it's the same name, dude. Telling you. Hold on, we find.
Yeah, if you read Maxwell's work, starting on mainly he mentions Weber dynamics predicts Maxwell dynamics, and he actually praises the model. He's it's a very nice mathematical theory, self-consistent. But Maxwell believed that he didn't like the idea of particles having action.
Because he believed in an ether.
Each other. Yeah, and actually he believed in ether, and he wrote a theory based on ether, and now we don't believe ether.
Yeah, so that's the funny thing is now here we are, and all this came down to my whole point. Maxwell made a model, based upon a mechanical model of the ether. The model is correct, but nobody think that model is physically real anymore.
So we take the same idea, but without ether. So Maxwell couldn't imagine that it's possible to.
Doesn't the model's existence, but listen, because the model works and it's based upon a physical model of an ether, doesn't that prove an ether exists?
That's a very good point. But if you were Maxwell, you would believe ether exists.
I'm asking you, doesn't it prove ether exists because we have a model with it in it? So that makes accurate predictions?
It doesn't prove it.
Oh, why not?
It doesn't prove that the ether exists. But when you see the contradiction, it disproves the existence of something.
Okay, you're not getting it, dude. There's a model The model has a mechanical model of the ether.
Yes.
The model works as in it makes accurate predictions, but you're saying even though the model has this component in it, the model making accurate predictions doesn't prove that the model's physically real, namely the ether part.
Yeah. So it turns
what do
out
you think I'm saying? I'm saying the exact same thing about the heliocentric model and the Tycho Brahe model and the epicycle model. Just because you have a geometric model that will predict where the planets look like in the sky doesn't make that model physically real. That's what I'm trying to tell you.
Yeah, that's a good point. But the thing is that we are improving. We are getting closer. About the thing about Maxwell theory is that he didn't believe it makes sense without either, and now we're doing it without either. So it's like he built a car, and he believed that he needs car muffler for the car to work, and we removed that. We're like, oh no, you can actually remove the car muffler, and the model works. So I mean, it was a bad analogy, sorry, but what I'm saying is that you should. It's not that if you see the model working, you should believe that the ether exists. It's just that you should gain trust in the reasoning. So we are making progress. At some point, we didn't know why. There is lightning. Then we said, oh, it's because of the potentials. And we said, oh, there's a field in the ether. And then we said, oh, actually, sorry, there is no ether. But there are waves. We found the waves, and we understand electricity, and we made everything. We made this. The fact my Discord is working is that I'm on mobile data, so I'm connected to cell tower, which works with Maxwell's theory.
Well, they're not using Maxwell's theory for any of that crap.
No, you need to need antennas. You need to that's what electrical engineering people study.
They're not really at the engineering level, and they're not using Maxwell's theory. They're not.
I don't know. You
stupid. It's simple. It's overly simple. But they're using basically electrical engineering that they would use in the electrical industry, right?
Yeah, but
they're using imaginary numbers. They're using the square root of j, the square root of minus j. They're using that crap. They're not using Maxwell's.
Okay. I think also imaginary numbers is an interesting topic. We can talk about a different tangent. So let's put that aside. But I think they also do a lot of it depends on the university, but
in kind of design, right? So they they'll. It's hard to do. So you'd get an app called Ansoff Maxwell 3D or something, right? So you'd get that, and it would model. It would do discrete element analysis of all the fields, right? The E field and the B field and the H field. And you would model it all out, but it's super complicated.
Yeah.
It's idealized. That's what I'm saying. You can make an idealized antenna from that, but whether you can actually engineer one and it'll work like that in reality, that's another story altogether.
Yeah, but also the people who wrote those stuff were probably somewhere along the line, someone should understand the Maxwell equation to fully understand what's happening with the antenna. That's all I'm saying. That's why we didn't figure out radios before that. That's because we did.
They were doing 10,000-mile radio transmissions in 1918.
So it's 1918.
Yeah.
It's so when Maxwell was born.
But Maxwell didn't invent radio, though. Tesla did.
Yeah, but Tesla is after Maxwell.
Yeah, I know. He didn't use Maxwell's equations to invent radio. He was an experimentalist.
Tesla, I'm pretty sure he studied something at some point.
Tesla, so there was a big lawsuit that lasted way past Tesla's death.
Yeah.
In the Supreme, on who invented radio. And it turned Tesla won the lawsuit, even though he was dead in 1947. But the lawsuit went on for something like 30 years, 40 years or something. So it was Marconi, Tesla, some other guys.
Yeah, but not the radio itself. First person to generate radio waves and prove, show that radio waves move, behave like light. If they reflect, they deflect. It should be Hertz, which is someone who studied Friedrich Hertz, right? It's before. It's before.
He
Tesla.
credited with it that it's doubtful.
A lot of people did. Like
Tesla had comments about because Tesla. There was a lot of guys all doing this. Tesla said, I think that crap was well known. So what he did was create a spark gap, right?
Mm-hmm.
And then he picked it up. He got an electrical current, makeshift antenna some distance away.
Mm.
So he's just like making a high voltage spark real fast, and he gets a current, some distance away. Tesla said it was a bunch of bullshit. Now I keep bringing up Tesla. The only reason I'm not a big freaking huge Tesla nut, I'm just because he was operating at that time. You know what I mean? When all this electrical engineering was first getting off the ground, like radio and all this stuff. That's like the late 1800s. Right? So, like a lot of things happened in that very short time period.
Yeah, but
Indio?
Yeah.
Sorry?
Indio, do you know of any other 2025 radio transmissions going 10,000 miles? Anything like that?
2025. What was the question? The radio going too much?
No, probably not, because I think they don't have big antennas anymore. As far as I know. I mean, maybe. There's so much interference now. Frickin' good luck even. So the 1918 one, it was done. It was Cornwall, UK to Sydney, Australia. 1918. The guy, so there was not a lot of radio interference. So amateur radio operator was picking up radio broadcasts from Germany and Sydney.
Mm-hmm.
And then he told the Australian government, and the Australian government told, because they were a British colony, told got together with the British government, and because it was World War One, they decided we're going to use this for a military application. We'll be able to hey, send more troops. We're all dying. Let's go send your boys to die too. So they set this whole thing up. But the war ended pretty soon afterwards, so they didn't end up having to use it other than to test it.
Do you think radio waves can follow the curve of the Earth, Sonic?
On Mars?
No, we're talking about something else. We're talking about that why mathematical approaches make sense, even though we don't see the fields. We make use of them, and we believe in their existence because we do the math and we do experiments.
But fields are abstractions. You know that. You know fields are just abstract objects.
No, actually, no.
You think fields are real? You think there's little frickin' points everywhere?
Okay, if I say what I believe, you're just gonna I don't know, what's the reaction?
Are you a Platonist or something, or a Neoplatonist? You can't believe fields actually exist.
Have you
they only exist in mathematics. They don't exist in physical reality.
So the reality is a field. That's what I'm saying.
Oh my goodness gracious, dude!
Yeah, I don't want to.
You're a Platonist, dude. You're definitely a Platonist. Do you think math is reality?
No, I don't say that. I mean, actually, it's
I'm asking if you think that.
I had this conversation with my colleagues about what is reality. I was saying, so I don't have a concrete viewpoint in a sense, because as you said, some people believe math is moral, but people who do theoretical physics, I think many of them believe that math is reality. And I don't have a reason to I agree, there's no way that we can say that, because how would you prove that something like a field exists, or something, a mathematical construction exists, that it's reality? But my idea is that when you see all of this stuff explained by math, you can make use of math. Sometimes
sure, we differ. I do not think math explains anything. Think you can describe phenomenon using mathematics. There is no explanation. If I have a whole bunch of equations, they don't actually explain anything. They just they describe what's going on. The explanation comes from us, where we give little stories to the variables, right? And we make it into a cool story that we tell the kids.
Yeah, no, that's
they don't understand the math.
But
so here's a cool story.
Go ahead.
I want to hear a cool story. Keplerian orbits.
Okay.
Keplerian orbits is a kinematic model with no forces. But everybody thinks that they're calculating the force of gravity everywhere and that they're using the inverse square law. Well, they are using the inverse square law. Not because they're calculating forces, but because it's a consequence of elliptical orbits. That if there's a force at a foci of an ellipse, it'll fall off inversely proportional to the square of the distance. And this is where Newton came up with it in the first place. Didn't come from experiment. It didn't come from anything. Came purely from a geometrical relationship. That's it. Okay. So even though you have a kinematic model of orbits with no actual forces, you can pretend that you're actually calculating forces because of this geometric relationship. Now,
but that's the thing. Like, go. Sorry.
Yeah. No. I just. The point is that the way things actually work versus the way people think they work are quite different, and we make these little explanations because it sounds cooler. Like there's a force that pulls all the planets together. That sounds cooler than, if we calculate the time and the period and the speed, then we'll, in a certain period of time, it'll be back at that place, right? That doesn't sound cool, right? It sounds cooler when we say there's magic rubber bands pulling everything together. Right, that's an explanation, but that's not what they're actually doing. They're just basically doing data fitting of a pattern.
Yeah, so that's a very good point, actually. So I want to also give you this viewpoint. So let's say we have a Keplerian, like there's a geometrical construction. As you said, there is no force in the Keplerian orbit, and Newton comes and is like, I think there are forces. So if you assume the forces, you will get the orbits, you get the ellipses. And one of the criteria of the mathematical models and like scientific models is when you explain something, then you also need to predict something. Otherwise, you're just like explanation is not enough because, as you said, you can just fit the data and it explains it. But you also have to make predictions, and it makes predictions. It can predict the orbit of the Halley comet. So I think I'm not sure about this, but I think Newton was the first guy who calculated the orbit of Halley itself. I'm not sure actually, but you can continue the math. You can be like, okay, if I understand gravity, I can understand the motion of stuff on the Earth. Like when I throw something, like I can calculate how fast I need to throw. Sorry,
that's a leap of logic.
Yeah, it is, and it works. You have to take it. If you want to do science, you have to take a lot of logic. And it works. That's the thing. You have to believe in the logic.
Didn't they try to calculate the transit of Venus a couple of times, and they missed it based off of the globe model, heliocentric model?
Yeah, so Kepler made the calculation that was actually wrong. So, but there was error in his calculation. So some other guy called Jeremiah something did the calculation, and he did it correctly, and he saw the transition. So it was Jeremiah.
Yeah. So
you can make errors,
brother. You did the exact same thing I just said people do. You just did it. They're not using forces to calculate orbits. These are mathematical equivalents. They're mathematically equivalent. Right.
So that's the thing. Now,
if I use Keplerian orbital elements or Newton's laws, as long as I don't use too many bodies, they're mathematically equivalent.
Yes.
So,
but now
you're only lying to yourself saying you're using Newton's laws because you're actually not.
So the thing that, I think the thing that usually, when people are talking about like Newton gravity, they usually mention the Apple story, which is not real. Actually, it never happened. But they think that, started this imagine the apple fall on the head of Newton. He was like, "Oh, there's an apple. There's a gravity." It's not real. Like it's a made-up story. It's a fun story. But I think that I heard that real story is that Newton looking at the orbits of the moon, and it's like, what's keeping moon up on the sky? And it's a realization that if you explain the orbits of the moon and the solar system with the gravity, the same gravity explains the movement of objects on the surface of the Earth. So it's that this.
But it's not the same.
Maybe. No, you can.
You're conflating big G with little g. We know little g empirically. We don't even need a big G for any of that.
You can actually, if okay,
And just,
I know
I need to make a correction on how Newton came up with gravity. He came up with it and demonstrated the equivalence using conic sections. Now, there's actually, if you go on Google and type in Feynman's Lost Lecture, he goes through the whole thing of how Newton came up with all this. There's also one on 3 Brown 1 Blue, which is pretty good. It's called Feynman's Lost Lecture. Richard Feynman.
It's a brilliant video.
Yeah, it's pretty cool, but he goes through how he partially goes through it, how Newton came up with it. Had nothing to do with Apple, had nothing to do with anything falling.
Yeah.
And to get to an object falling, right, from this other thing, this planet orbits, that is a crazy leap of logic, dude. Like, because you can actually, because this is a common thing that comes up. You guys don't believe in gravity. Yeah, gravity, what's that? Oh, drop something. That's what gravity is. Okay.
Yeah.
How do I go from I dropped something that fell to the ground to Earth as a ball?
I don't want to say it, but it's math. The path phase at some point.
A logical progression. Yeah, but a logical progression. I make the observation. I see something fall. How do I just from seeing something fall, go Earth as a ball? People have been seeing shit fall for a pretty long time. Okay, so they were all watching shit fall down. How come those people didn't go Earth as a ball?
Because it takes, as you said, it's not just a huge leap in the logic; it's also a huge leap in the calculation and the logical reasoning. So it takes so much effort to make a model that explains shit falling and shit orbiting around the sun, and that's what Newton did. Like, he connected these two different geometrical constructions. One is for objects falling, so Galilei found that.
How was that connected? Wasn't done in his lifetime.
Yeah, he's asking you how.
The connection between things rotating and shit falling.
Yeah.
Yeah.
So
what's the logical connection between the two?
So you if you assume the Newton's law, you say, okay, mass.
So there goes the logic part.
From somewhere. So that's the way science works. Okay, that's
if you assume. That's not how science works. You don't just make assumptions and then say, I'm going to try to figure out how to make it true. It's just begging the question.
There is the bias, but you give up the idea when it stops working. That's why we give up Newton's idea and stick to the Einstein idea, because we're like, okay, now we're saying that Newton didn't predict.
Where did they get the mass of the Earth from? Because this is the crux of the problem. Where did that come from, the mass of the Earth?
Right.
Okay, that's a very good question. You can estimate it if you have the size and also the density, but the density is not uniform. So,
it's not.
But you can do it with a small g and big G, right? You can do it with a small g and big G.
Yeah. So you reverse the equation, right? And then if you assume that 9.8 meters per second squared is a consequence of big G gravity, then it'll get the mass of the Earth, and your equation will work perfectly fine. You could say, hey, we predicted 9.8 meters per second squared, but you actually post-predicted it. You didn't predict a damn thing. You just fit a phenomenon, and you fit a phenomenon into an assumption. That's it. But you still haven't used the scientific method to figure out the cause of a falling object.
Okay, I have a question. Is it possible that after this Discord call, you just wake up and realize that you were in a simulation, or like a really accurate dream? Can you prove that? You can't. You can't.
Yeah,
you can't prove that you're not in a simulation.
Yeah,
right?
I can prove it that I'm not in a simulation.
So you assume
why do these guys always go there?
You guys always run away. You guys just like, oh, I can't have my globe. I'll stick dynamite in all of reality and blow it up.
No.
All of reality. We don't know what's a globe. We don't know anything.
Exactly. So you have to start from somewhere.
See, this guy, he said exactly.
You know, every time they can't prove their globe, they go to, we may live in a simulated universe, or how did you know?
I didn't say that. You say that. you say that, oh, every time you start talking, you guys like, oh, you're making assumptions.
Yeah.
So you don't have any assumptions. You don't have any assumptions about reality. You don't assume reality is real. You just think things are, and you don't assume they're real. There's no reality.
I don't have to assume reality is real. I felt pain before.
Yeah,
So
he asked you 3 times basically to prove your globe, the physical object that you're claiming is true, because you leaping it from things falling on the ground, and he asked you what was the connection, which is basically giving you some observations to show that your point is true, and then you started with, well, assume this and assume that, and here's the math, but you ain't start with any observations whatsoever.
Also, I still have the thing about eclipses, but
why do these guys ignore it when we ask them to prove something in reality? Why ignore it? Can you just address my point?
What's your point? I don't get your point.
Okay, my point is that you're trying to prove something is physical in reality, like Earth being a globe, right? Right. So we asking, what is the physicality of it? What physical observation do you have in this first instance before you even get to the math or get to the assumption?
Okay. Let me think. Why would I assume Earth is globe?
Again, assuming again.
Yeah, we're far. Look, bro. Let's just walk it through. So what we hear typically is, like I just said, what's your proof of gravity? Drop something. Okay, how did you get to a globe from that? No answer. Okay, even if, say I just granted, yeah, little g is a derivative of big G. How do you get a globe from that? What's your evidence that gravity forms things into balls? Has that ever been observed? Has it ever been done in the lab? Is it a consequence of the physics?
Actually, Cavendish did that.
Cavendish did what?
He did an experiment. He had 2 massive balls. And
what fell in that?
Sorry?
What fell in that? What fell in Cavendish? We're trying to figure out why things fall.
No. The attraction. I say there's attraction between massive bodies. So he measured the attraction.
Okay. There's an attraction between massive bodies.
And that's
what is mass, dude?
That's what you do. You just stop.
Because mass is another shit-defined term. And if I ask you what it is, you're going to give me the wrong definition, and then the right definition is resistance to acceleration. And then you go, two resistance to acceleration attract resistance to acceleration, which makes no fucking sense.
What?
Mass is defined as resistance to acceleration.
Yes.
In physics. So when you say mass attracts mass, you're saying resistance to acceleration attracts resistance to acceleration.
So it's called Einstein's correspondence theorem, which is not trivial. It's not trivial why the 2 definitions of the mass are like why the mass that resists acceleration also has to do with attraction. So yeah, it's not trivial.
It's never been proven that they're actually equivalent. So there's that problem.
So
did you know that it's never actually been experimentally demonstrated that the gravitational and inertial masses are actually equivalent?
No, there is an experiment. No, there's experiment. I don't know. I don't know.
Okay. Well, I know there's another physicist that's been researching this for 10 years, and he's got lots of experiments showing they're not equivalent by doing drop tests. His name is Sky Darnos. In case you can watch his experiments, they're pretty interesting. There was also experiments done in the Bremen Drop Tower, which is a 5-story vacuum chamber in Germany, which demonstrates the non-equivalence. It's just was asserted, and everybody just goes along with it. So the point is, we're getting way off the point. The point is, people say Earth is a globe because of gravity. Gravity forms matter into balls. Okay, this has never been observed in nature.
Like the galaxy, like the far away, like we look at formation of stars, formation of galaxies. We see dust.
Oh my Jesus! So we watched we watched a planet form into a ball. We have actual observation of it happening. Now you're going to tell me, no, it happens over too long of a time scale. We never actually seen it.
So that's another thing. You haven't seen one like star forming, but because there are 10 billion, 10 trillion stars in the sky, you can see the stars in their different life stages.
How do you know they're in different stages?
Because you see they're different. One of them are just gas, and you
so
can
what?
see
They're different.
How are you
All
relating
the people
those
on Earth
stages?
are different. Do we say that they're in different stages?
That's actually
sorry. What? I missed that.
Hey man, that black person's just in a different stage of white, man. It's cool.
Good. Time out.
They were saying that about Michael Jackson for about 30 years, dude. They're like, you just turned white already, Michael.
But you see like a baby, you see old man, you see guy, you see they're not the same people. But you see the baby grow.
Is Reg here? Reg's gonna kill me. Reg, I'm sorry, bro. Is a black man a collapsed version of a white man?
I think that's the funniest joke I've ever heard you say, Sheepdog.
It's funny shit, man.
Guys,
listen, how about we do this, okay? Now, you've admitted that there's a lot of assumptions, and that's pretty much, that's what you're dealing with. Is there anything we can actually just say, yeah, this is 100% true, and we don't have to assume anything?
I say no, because assumption of reality existing also is something you have to assume.
Oh my god, dude! What do you mean the assumption of reality existing?
You're assuming your emotions are true. That's your assumption. There's always assumption. You're assuming that the pain is real.
What are you talking about?
The existence. You say reality exists, and you said because I feel pain, I feel joy. Yeah. Why do you feel the pain is real? How do you assume that the pain is real?
It's not an assumption. I feel it.
So it's just about feelings. Whatever you feel is true.
Listen, brother. So the idea. Look. Are you familiar with Thomas Reed?
Sorry, what? Who's Thomas Reed?
Thomas Reed. This this bullshit. I don't even know how this shit's still around.
Yeah.
This Descartesian, super skeptic, freaking brain in a jar. I can't prove there's no external world. That nonsense was created 200 years ago.
So that's the thing. I'm saying you're making this
that
argument.
Worldview was that. No, it's refuted, dude.
You're making the same argument, saying that there shouldn't be any assumption.
No, okay. It was called the ideal. It's called the ideal theory, right? That you can't prove there's any external world. I think, therefore I am. That's the only thing I know is actually real. Is my own mind. I can't demonstrate the external world is real. What Thomas Reed said, they should have known by the place they ended up that they took the wrong freaking path. Because if you spend 2,000 years doing philosophy and you end up like, I don't know anything, you probably took the wrong path. You might think.
Yeah,
because was that where philosophy was trying to end up at? I don't know anything.
Yeah, and
that's where they were trying to end up. Aristotle, Plato, the whole line of philosophy for 2,000 years, they were trying to end up at I don't know anything.
And it doesn't go anywhere. Like if you can just sit, that's exactly what I'm saying. You have to.
You're dodging, dude. No, they weren't trying to get there. That's how you know they ended up at the wrong place.
I'm not.
They start from the assumption that everything starts from the internal world. Okay, where it does not. Everything starts from the external world. Okay, we know this just in biology, right? Have a baby.
Hey, hi guys.
Hi. If you measure the what do you call it? The brain waves, or it's basically a blank slate until the external world makes imprinting on the brain, right? You can't even have thoughts, conversations, logic, and even talk about having an internal world unless you're using an external world as a referent to all those things. That's how you even differentiate it in the first place. The external world exists, and because you have some separation from it, you're like, well, maybe it's just me. Yeah. Do you have something to say other than interrupt?
Hi,
Here's
guys.
your chance.
Say
Guess
something.
not. Anyway, the point is that how would you even know an internal world exists if there was no external world in the first place?
Mm-hmm.
You think you just think you start at the internal world and self-differentiated and pretended in your own mind that there was something external from your own mind? Well, it would still be external from your own mind, even in your own imagination. Thus creating an external world. The very fact that there's a differentiation.
Mm-hmm. Yeah, that's a good point. Yeah, this fact is makes sense.
And you know, all that shit's just a bunch of fucking mental mind games of people that don't.
No, I don't want to do that. Yeah, saying I don't want to care. I don't care about philosophy that much. I just think that
we hear it a lot in this chat, dude. We hear it all the time. As Reg was,
it's a wrong direction. I would say it's not a good direction to. I just brought it up because I was
had a PhD freaking doing that shit, bro. Fucking saying I can't prove I have hands. No fucking hell's angles. I mean, we're way off topic. The point is that. Is there anything we can say for certain about the world? Like, we can find you, right? If we found you, I can take a tape measure. Like, look, he's, freaking 1.7 meters tall.
Yeah.
And I can know that. We're just going to compare you to the tape measure. I don't have to theorize. I don't have to freaking make up shit in my mind. I don't have to have a theory of you being tall or a hypothesis or a model or any of those things. Right. No, my point is there are things we can know. And if we don't you think it might be interesting? Like, hey, dude, we're so far down the rabbit hole. Maybe we should just go reconsider, go back to the drawing board and okay, we went way into our imagination. We made a lot of assumptions. Let's circle the wagons and go, what do we actually know for 100% certain? And let's lay this foundation and then build from that. Because I think we're often to speculative theoretical physicists never land at this point, where we, because of Hume's fucking problem of induction, people have settled for freaking sloppy reasoning.
Okay, so you mentioned the tape measure. So I get the tape measure and measure your height or my height, it's 1.7 meters. I'm like neat, I'm 1.7 meters, and I give the tape measure to you, and I tell you to go measure someone else. Tom, is across the city, you have to go to his house and measure his height. So you go there, you measure his height, 1.8, or let's say 1.7, the same height, and your conclusion is that okay, so me and Tom are the same height, but I don't like that. I want to be taller than Tom. So I say, how did you assume that tape measures stay the same length when you take the tape measure across the city?
Because it's the same fucking tape measure.
Yeah. Do we need to calibrate it?
Calibrate the tape? How do you calibrate a tape measure?
So you always assume that things don't change when you're moving across cities. There's still some sort of something
this
I know
isn't an abstract idea. This is a physical object. You keep doing this where you're conflating things that are actual physical and concrete with things that are abstract as if somehow they're equivalent. Like saying, hey, how do you know that actual thing, that brick over there is real? Versus saying, how do you know the sun has parallel light rays? One is phenomenological, whereas one is just a statement about its existence or not. Right.
Okay, so you know what? Actually, I was right, because when you went to the other part of the city, it was you did let's say you didn't know about
maybe you went near the speed of light and the tape measure shrunk or something. I don't know.
No.
Is that it?
Let's say let's say you don't believe in the math and the physics that I'm describing everything, and you don't know the thermal expansion. And actually, it was like a tape measure made of a metal that expands a lot when it's cooler or hotter, when it's hotter. So actually, the tape measure was expanded because you were in a part of city that's hotter. So actually, there was something to calibrate based on the science.
Yeah, that would be a measurement error, but you shouldn't make a tape measure off of fucking expanding metal. Just like we wouldn't make a tape measure off of out of a bucket of water. Okay, this is fucking fucking stupid.
Yeah.
Hey,
you know how they
hold on real
measure,
quick.
wait. No.
Sonic.
Just finish my point. Just finish.
I have an image, a GIF, or not a GIF, but a meme, I guess, in the side chat, and it talks about rain on different planets. What do you think about that?
Yeah. Okay, the last part probably is not correct. I can show you, but the other one is probably correct.
How do you know?
I read in the news, right? They say it. It's a spectroscopy.
There's no semen on
probably. Shut up, man.
Can we ask you? I want to ask you a question. What are you skeptical of in the mainstream narrative? Like claims that just seem to you just so outlandish and outrageous, or shaky and nonsensical, maybe.
Dark energy and dark matter. I don't like them.
Okay, that's. Do you think that they're post hoc hypothesis to save the gravitational theory from being falsified?
Yeah, and I understand them. Like scientists always do that. They just come up with the first thing that comes to their mind. It's fine. But I believe they're gonna be proven wrong at some point. We probably will have some more elaborate theory that improves the current theory. I don't believe there is dark energy sitting around, invisible 90% of the world. But at this point,
they can't prove it or disprove it because it's just an imaginary thing. So
exactly, unless I observe it, it's a theory, and it's not a perfect one, but it also has some.
It's not perfect because it's not even anything. It's shit. We got this theory of gravity wrong.
Perfectly nothing.
Add some shit in. Yeah. Exactly.
Okay, I just want to say something about the tape measure. Okay, I also want to mention this, but I want to move on. Nowadays they calibrate, the definition of 1 meter is defined by the speed of light.
Dude, you're so full of shit, bro. Sorry, dude. You're full of shit. When you go to the doctor and they take your height, you don't fucking have this conversation with them.
No, but the definition. That's why you trust in the tape measure.
He gets a torch and he measures the speed of light to the top of his hand, which is near his head. Okay. And he goes, all right, so I must be this tall because it took the light to get from the bottom of me to the top of me at this time. Is that how you measure?
What does he use?
He measures his height with an interferometer.
He can. I would appreciate it.
But it's a wonder he hasn't started rattling on about gravity, India, how it's less up near his head, so he stretches a little bit.
Oh my God, your head is your head's younger than your feet, buddy.
Well, I think it's ironic. I think it's very ironic that he's willing to consider that all of reality may not exist, but he doesn't like dark matter and dark energy.
Guys, who makes the tape measure? There's a company making tape measures, right? They calibrate it with another tape measure, right?
Yeah, look, I'm in construction and they always say, you know what the problem is? Always use the same tape measure and you'll never have the wrong measurement. All right.
Most of the time, the problem's the idiot operating it.
Yeah, exactly.
You can't read numbers.
The same tape measure. Doesn't matter.
No, it contracted due to the warping of space-time.
Okay, I really need to get some sleep, so I want to. I will say something.
You know what? You've been really good, man. So come back anytime.
Yeah, we appreciate your civility.
I love this conversation. It was sometimes really hard to continue conversation for obvious reasons. It was we had so many different points of view, but I'm happy I did this. I hope you guys also enjoyed it. But all I'm gonna say at the end is that even if we don't believe that world is described by all of these assumptions and things that we don't feel, things that we don't see, I think that's what we did as humans. We made some assumptions, we made something work, and
You mean imagine things? We imagine some stuff that doesn't exist.
We imagined the fields, and we made the radios.
We created a computer model, and we manipulated that computer model, and did.
You didn't imagine anything. He freaking made a spark gap and got a freaking voltage somewhere across the room. It wasn't based upon equations. You know, most things that are done engineering and experimentally, they're not based solely upon equations. Those are just like starting points.
That's trial and error.
Yeah, they complete each other. So Maxwell wrote his theory based on Faraday, which just did experiment. Faraday didn't know shit about math. He's like one of the physicists that doesn't know it. Yeah, you know that. You're studying enough. But Maxwell
I'll say this, Sonic,
and made it to what, sir?
I'll say this, okay? All of us here graduated high school believing the Earth. A lot of us graduated from college believing the Earth was a globe.
Mm-hmm. Yeah,
we believed the Earth was a globe for most of our lives, and it just comes out down to testing.
I was really impressed. I'm really impressed. I'm really impressed by the level of
if you want, what do you think is going to happen to you if you wake up one day, go out and test the globe, and you find out that the Earth is flat? How are you going to feel about all of the physics you've learned in your life?
I feel bad. I would say that. I would say that. Okay, I'm not making a kill myself. I'm saying that.
Yeah. We're still going to be able to fire a cannonball on a flat Earth or a globe, and it's going to go the same way as it would either way. There's no difference.
Like when you're shooting, like you can ask this. Like I don't know. Do you guys have people in the like do engineering for the like Navy or like military? Because when you're shooting ballistic missiles, you have to.
We never accounted for the Coriolis.
What was the range of the missile, like, or the projectile? I'm talking like about
our kilometer rifle shot.
Kilometer.
So check this out. Iowa class battleships, the big battleships from World War III, can fling a 16-inch shell, 30,000 meters. In the firing tables to fire that gun, which are freely available on the internet, there is no Coriolis calculation. There's no correction for Coriolis. Nothing.
But you do it with the
30 kilometers, brother.
You do trial and error. Like you shoot, you see it goes like to right, you take it to left. You don't calculate it exactly when you're doing it in World War II. You probably.
Well, they have firing tables. They tested them. These boats were still commissioned in 1984. They used them in the first Gulf War. Yeah, they're still around. There was three still around. There was the Missouri, the Arizona, or not the Arizona. What was the other one? The Iowa, and there was another one named after a state. But they used them during the Gulf War. But they tested their accuracy off the island of Crete in 1984. And their accuracy.
And you say they don't calculate the Coriolis?
Yeah, they have firing tables to fire the guns, and there's no Coriolis calculation. Now, in the beginning of it, it says there's a Coriolis effect, but then when you look at the actual firing tables, it's not actually in it. A lot of the artillery stuff that you'll see, right, the artillery firing manuals, it'll say in the beginning that there's a Coriolis effect, but then when you actually look at the firing tables, they don't calculate for it. It's nowhere in the mathematics. Because think of what you would have to do. You'd have to know your latitude. You'd have to know your azimuth, right? Precisely.
You only need the altitude. You don't need that.
No, you need to know your latitude.
Yes, you do.
You need to know your latitude, buddy.
You only need the altitude. The Coriolis effect is only
latitude, not altitude. Latitude.
Oh yeah, sorry.
So your azimuth, the direction you're pointed.
Oh yeah.
Okay, so how are you going to do this under fire? Which way are we pointing? You're freaking running around like a maniac, dude, trying to not get hit yourself, right? And you're like, "Hey, which way are we pointed? What latitude are we at? Here, break out the side roll."
The more people who shoot, like I never shooted like a artillery, but I put armor. But you have a map and you have a compass, and you always are talking about the altitude, like the azimuth. So it's somewhere in the table.
You need a direction. Yeah, you need a direction.
Yeah, so you know the direction with respect to the north.
Well, think about it. But depending on what your azimuth is, okay, if you're shooting east to west, right, your round is going to shoot further or shorter. But as you rotate towards the north, now the Earth is going to spin out from underneath the round. Depending on what your azimuth is, you'll get the max left-right deflection pointing north or south. But if you're not going to be exactly north or south, right? So you're going to be, you could say you're freaking at, what would it be, 270 or something.
Mm-hmm.
No, 270 would be
that'd be west.
Yeah, that'd be west. So say you're northwest.
You could say you're 350 or 10 or 5.
I mean, dude, you're basically shooting a freaking curveball and trying to land a shell.
Yeah, I think
that's how it's going through the air, right? Because it's like, say you're firing against with the spin of the Earth, right? So now it's going to land short, but then you're pointing, say, northeast. So now it's also going to hook. So you're going to hook it short. And dude, I'm not good at golf, dude, but I don't think frickin' Arnold Palmer can make that shot, bro.
Look, golf is different from artillery. Like, it's like the scale of accuracy. Like, I found this table. Like, I mean, just I was scrolling the I don't know what website is this, but it's sort of gilbertsecurity.org. I don't know, but I don't have experience in military that much. But I found this table. Like, they have stuff like this. So
it's spin drift from the inside, the rifling inside of these artillery cannons and the rifle. It's so that it'll spin the bullet when it comes out, so it doesn't do flips and tumble over and over like a curveball in a baseball.
No, this is correction for the rotation of the Earth.
We had these tables also with our headquarters unit. We had our artillery attached, our 16 millimeter artillery, and they never use that shit.
Because it's like really a small correction for a small, like it's not ballistic. When it's a ballistic missile, you have to do large correction. For this one,
yeah, but if you want to hit your target, you want to hit your target, right?
Yeah, but like
yeah, but that's a range correction, right? If you're firing east or west, where's the correction for the east or west drift?
So to cancel out the rotation effect, right? So if you want to,
because the Earth's supposed to spin out from underneath the artillery shell, so the shell's going straight, but the Earth is rotating. And at some point they disconnect it, even though no one can say when or how or what speed or what height or what air pressure they disconnect at. Somehow they say they're disconnected, so the Earth is spinning out from underneath the artillery shell to be left or right of where you aimed at, right? There's no correction for that. Is it going to be to the left 10 meters? Is it 100 meters, 1,000 meters? Like,
no, that's what it says in the table. Like, you want to shoot something like 2,000 meters away.
It says range, dude.
And the correction you have to apply.
Yeah, the range. Right. Like, you have to calculate how far away it is, a different distance, but not the left-right, right? It's not an azimuth correction. Like, the direction you should be pointed so the Earth spins out and you land on the spinning Earth.
Sign before number as measured clockwise from north.
Yeah, like if I wanted to hit a target that was like from my location, let's say 400 meters. We'll just say a kilometer at, let's say, 60 degrees, right? So that would be like north. And in order to hit that, you would actually have to aim at 50 degrees, and you would have to shoot at 950 meters instead of a kilometer. And then the Earth would just spin into it.
So you said that you considered that? Like there was a point?
Hell no, bro. Hell no. If we missed our target, we assumed that there was a wind draft, like a gust of wind that we didn't account for.
Yeah, so the effect of rotation becomes larger when the flight time is also larger. So like this is like very small for
our 101s, 151 for account for you.
So what's 101? I'm not experiencing
heavy artillery.
Oh, dude, I just played Call of Duty. I don't know artillery that much, but I mean, I'll play Arma. It has like interesting, realistic.
They don't have artillery in Call of Duty, so don't worry about it.
Yeah, did you have it in Arma? Right? Play Arma 3.
No.
It's a really it's a cool game. If you like military stuff, you should play it. It's like what do you call it? Like it's like a realistic simulator basically of. Anyway, it's not important.
No, I
yeah,
hear you.
but yeah, it's a good game.
Really, it comes back to the first Cosmic Day. Right? We gotta solve
you're right.
Cosmic Rung. You're assuming the Cosmic Rung is correct, and then you're going straight to the second Cosmic Rung, the third Cosmic Rung, and you're building story based off of math equations that you assume the first Cosmic Rung was correct to begin with. What if it's wrong?
Okay. So you meant the cosmic rung? What do you mean by that? Like the ladder?
Like a ladder.
The first rung on the ladder.
Yeah. So yeah, it's if it's the first one is wrong, you also get you find. But if the idea is that my idea is that if the first step was wrong, I would see I can't talk anymore. Inconsistencies higher up, so the astronomy wouldn't work, or like the solar system wouldn't make sense. The observation would match. I couldn't predict the eclipses. I couldn't predict the orbits. You know what I mean? Like if
it's kind of like a math equation, right? Like you have a really complicated math equation, and if you screw up on the first step in the math equation, and maybe the math equation takes like 20 steps to complete, all 19 steps after that are completely wrong. You got it right because if you assume the first part was right to begin with, you got the other 19 steps right also.
Yeah.
But the first one was wrong, so the other 19 steps can't be right.
No, that's a good one.
I haven't been in this server in probably 5 years. But I a couple weeks ago I came on to either I think it was in politics, and someone on there, we were talking about the Walter Bislin website was down, and I think we were talking about like how much curvature you could see at different level at different altitudes, and I got frustrated because the Walter Bislin site was down, and so I decided to make some visualizations, and so I made a little website that I could share with some things.
How come you need Walter Bislin's website to
now I
know
don't
how much globe there should be or see the globe?
Now I don't.
Yeah, you made your own website? That's kind of cool. Let's see it.
How do I post it?
Voice chat, go to the bubble, and then live stream voice text.
What do you think is the best evidential justification of this curvature that the likes of Walter Bislin are claiming exists?
Well, so one of the things that I found, so I did one that was like it was specifically to be a airplane, like a view from an airplane. And I'm seeing that, at least the way, if I have things set up correctly, that curvature should be visible under a globe. Curvature should be visible slightly from an airplane. And I didn't think this before.
Have you ever been on an airplane?
What is that?
Have you been on an airplane?
I have.
Did you see the curve?
I did not. But what
sense does it make to say? What sense does it make to say? According to this website I just built, it should be possible to see the curve from the plane if there is curve,
but I've actually been on a plane and there is no curve. You've answered your own question.
Very slight. It's very slight, but it's definitely, it would be perceptible to if you took a picture. And a lot of the stuff that the website does, I'm trying to get as close as I can to like what different types of cameras would see.
But they're not. But I mean, that's a roundabout way of doing it then, because even if you want to make the argument that we could take a picture and we could put like a straight edge on the picture and we could see if it deviates slightly, then you're just going to get into the argument of barrel distortion and the window that you're looking through. Right. So then we're inevitably going to come back to, okay, well then what surveying techniques have been used on the ground to evidence that what you're saying you're seeing here is curvature commensurate to a 39-59 mile radius ball is actually detectable when measured in reality? Because the high altitude stuff can be argued either way till the cows come home.
So what I tried to do is build all of that into the visual. So if you look at the airplane one, I include refraction in the airplane window, and then you can also select
in the airplane window
the FOV and the projection type of the camera. And see what different effects would have, and then you can change whether it's a flat or a globe Earth.
All right. But outside of simulation and all of that, why has no one been able to detect this curvature through measurement of the surface?
Well, I think so. What I'm seeing with this thing that I made is that there's a certain curvature that the globe model would predict, that the globe model predicts from a plane. And when you look at images that people have taken from airplanes, on good days with good visibility, it matches the curvature that the globe predicts.
Stop the cap.
Well, I would say that's very debatable, but if you're saying that, then you could also say, well, the globe model predicts a certain curvature over a distance on the surface, let's say 10 miles over a lake. That'd be 66 feet-ish. So why can that not be measured or detected?
I mean, that's a whole other conversation.
No, that's not a whole other conversation. That's the exact thing you're trying to argue. You're trying to say you see that 66 feet over 10 miles curve from a plane. So if that were the case, why can it not be detected on Earth?
Well, that's I don't know. It's sort of like we have to compare we have to take all of this evidence. So
you just have to be able to provide measurement of it on Earth in reality, or concede that it's not measurable, not there.
I see what you're saying. I think to me, the fact that the curvature is of that's seen from planes and with good.
Well, no. But you can't say the curvature is seen from planes though, because I've just pointed out that that's not measured in reality.
I mean, we can look at pictures of we can look at pictures of people who've taken pictures of the horizon on planes and see which model fits it.
Right. But then we're just going to come back again to then why is the curvature, that 66-foot drop over 10 miles, why is that not detected? Well, if what you're showing in these images is that 66 feet over 10 miles, why, when we go to the ground and someone tries to detect it, is it not there?
I mean, this is an argument that I've had it before, and it's a matter of we have to take all of these pieces of information, and there are obviously globers who have taken measurements that they believe to have shown curvature, when they're on the ground.
Right. But is there actually? Well, people can claim that, but is there? Well, which measurement would you refer me to if I'm saying who's measured that 66 feet of drop in reality?
That's the question. We have to look at all of these pieces of evidence, and to me,
you've been here for 5 years. You were here 5 years ago. So in that 5 years, have you found any measurement of that?
No, I mean, I dropped off the debate for a while, and I just got interested in it again. but I
Well,
not.
well,
I
I'll
mean,
tell you,
I've seen.
we've been here the whole time, even
I was
longer
looking
than
at
that, and no one's measured
actually
that.
when I was looking at, like, when I found Walter Bislin was back up again, he did a measurement on, I think it was the Bedford level, that was very exhaustive. Let me see if I can find it.
Well, the Bedford level, that would just be level water. And that was actually the measurement done by Robotham at the Bedford level, which started this whole thing in the modern day again, because he wasn't detecting that curvature either.
Right. Let me find the.
I've posted some of the material from J. Tolan Media One, and also from a pilot, SR-71 pilot, who says he could see the whole of the West Coast, California, from his aeroplane, no curvature. Okay, so there you are. Three videos there for you. You can look at. They're not long, and they're quite concise. All right.
Let me see.
From the horse's mouths.
I'll be right back.
Thank you very much, Cyclone. Well done.
I'm not as. I want to make some simulations like you on this website that try to handle this whole refraction and laser tests and visuals and stuff, but I haven't made them yet, so I don't know. I'm not read up on the topics, but like the one that I can speak for is this airplane one, that we do expect to see a particular curve.
Yeah, why don't you post one of those? Because when you're looking out the window of an airplane, you're seeing a city beneath you.
Yeah.
At most, sometimes parts of a city. And you're seeing curve as well?
Can you explain what you mean?
That's what you said.
So like it's easier. This is what, like, why I made.
Can you explain what you mean? You said you see curve of the Earth,
right?
And you also agree that all you're seeing out the window beneath you is just a very, very small portion of the overall Earth.
Right. This is why I made the visualization. Like if you go to the website, you can see.
No, I'm talking about your original claim that you know the Earth's a ball because you've seen that airplane window.
That's a piece of evidence that gives credence to the.
Yeah, post one of those images. I'd like to see that. I'll be back.
Okay. Someone mentioned Jay Tolan's. I think that I actually looked at some of his videos. Was one of these Jay Tolan's video? Let me find one.
Yeah, you were asked to find a material from an aeroplane window that you've seen, that you've seen. Yeah, that you've seen, because Jay told me that he uses a Canon camera, infrared lens, and the videos I've posted show you what you can see without the glare. So it cuts through the infrared, cuts through all the noise, they call it. All that glare is called noise, and you get a sharper resolution image. And he was able to see up to 1,000 miles.
Okay, yeah.
Hudson Bay, 500 odd miles. Yeah. So, and then the Colorado Rocky Mountains, 35,000 feet above the earth. That's what he could see. I've traveled by plane many times, and what amazes me most is the infrastructure. What man has actually created on this earth is what blows me away. And then now that I'm a flat earther, how flat everything is on top of that. Wicked. Amazing.
Yeah, the distance things, that's something I want to look at too, because I watched a couple of his videos, and he gets really in depth with how far he sees, and I want to see, like, I want to maybe add a thing where on the crosshair of on the website, when you're visualizing, you can see.
Yeah, the only way you could really debunk him is to actually go out and replicate that. That's the only standard, really. Your critiquing here is not really going to work, really. You're going to have to go out in an aeroplane with said equipment and make that same observation, or somewhere similar anyway, and start showing us how he couldn't have done that, because here I am on a plane with my equipment, and this is what I'm finding. Okay? It's got to be done that way. Because that's what he's done. He's taken the time to do that. And we're looking at it and we're thinking, amazing. Okay? Now, and that goes with what we find. We're measuring Earth flat, you see. That's what you must remember, that we're measuring Earth flat. So if you want to say there's curvature, then you're going to have to prove that, show us what you've got. And there's Neil deGrasse Tyson has stated that you wouldn't be able to see curvature from 24 miles off the Earth's surface. That stuff is flat, he said.
And I mean, that's the kind of stuff that's because what with the visualization that I made, I'm seeing that we should definitely have visual curvature from planes. I'm still trying to find. I'm looking through Jay Tolan's videos. I want to get a screenshot.
Apparently, even from the ISS that we know is not up there, when they show the curvature, they show you something that's incorrect, because what they show you is far too much curvature, actually, from the ISS and the images they give us. Apparently, we should only be able to see 3% from that 250 odd miles from the Earth's surface. We should only be seeing 3% of the Earth, right? But they show us far too much curvature there.
Right.
So there's discrepancies all over the place, right?
What I found when I do the math in this visual is that we definitely should see curvature. So whoever was saying,
but can you not apply the maths to the surface of the Earth? Can't you do that? That's the standard, isn't it? To actually go to the surface of the Earth and use your methodology and measure the surface of the Earth. That's going to be the most accurate, isn't it? At the end of the day, because you haven't done that yet. You haven't done that yet. That would go a long way to helping you understand how the curvature is not there. You haven't made that measurement yet, have you? Have you made that measurement?
But I mean, if I post,
I didn't hear your answer. Have you made that measurement?
I haven't personally made a.
No, well, then that's what you're going to have to do, then, aren't you? You're going to have to go out personally and make the measurement, because all of us here have done that. See, when you've gone out and actually endeavoured and spend time trying to find that curvature, it strikes home much harder than all the critiquing and all the maps that we have. That's fine. But you've still got to go out onto the surface you live on and check it. That's where it's at. That's the place.
There's value. So, like, even in Jay Tolan, he's a perfect example. He does a lot of work after his videos, analyzing them and, comparing them to maps and things. And there's value in, even if looking at someone else's observation and trying to interpret it and see. So I just posted a link to a video of Jay Tolan's where it's one of his pictures on a very good day with one of his infrared cameras, and the curve that's seen there matches the curve that my visualizer has for
unfortunately, I'm not going to be accepting that as a flat earther. What I will say to you is this: I will accept you measuring curvature. That I will accept. You spending time actually going out there on the surface of the Earth, doing what I've done and what all the other flat earthers have done, and then bring that stuff to me. I'm willing to look at that. That's what I want to see. Critiquing. Yeah, that's what I'm waiting for. Sorry?
I do want to go try some.
Yeah, please do that, because that's all I'm going to accept as GeneCBR1. That's the standard I put down upon you. Go out, measure the curvature, show me that. I want to hear you critiquing a man of integrity and his work, and then some other video you've watched that states you should see curvature. Not interested in that stuff. That's not my interest. I have no interest there at all. Yeah. I'm interested in what you can do.
I was complimenting him.
Done. Yeah, because that's very important.
He's done some. I mean, he's done a lot of work. He's put a lot of work and thought into these.
He spent a lot of time and money and effort. You haven't done no such thing as yet. You're doing a lot of effort critiquing, but you haven't done anything yourself. And that's easy for you to do, because the outdoors, just open your front door. There's great outdoors. Get out there. Plan a weekend. Take some friends. Rent it. Don't even buy equipment. Rent equipment if you need it. Go rent the equipment. So you don't waste any money, because you may not use the equipment ever again. So go out and make a good day of it. That's what you've got to do,
I agree. I should have done it.
Exactly.
What are if I tried to do measurements during the fall or the winter over like a lake? I live in the Midwest. What are there any tips?
I would suggest that if you can, do it through all the seasons if you can, in different places, and then see what results you get.
Yeah,
really. See, that's what I would suggest. I mean, I can critique J. Ptolemy and stuff because I've gone out to see the Earth and I've seen it as flat. You haven't done that yet. So to be critiquing when you haven't even checked, because actually checking drives home the fact that the Earth isn't a globe. That's why I'm suggesting you do that. Okay? It's a must do. For every person on Earth, must do. That way you know.
I made some, I want to make more, but I wanted to show the things that I've made. So the other thing one of the other simulations that I've made so far has to do with something that I didn't see when it wasn't a common argument when I was here a while ago, but there's this very reflective lake in Bolivia.
Yeah. And specular highlights, they call those, I think, where you're seeing a reflection on the lake that is a mirror image, which proves that lake is dead level, because if it wasn't, then the image would be distorted. Yeah.
Right. So what I did is the simulation I'm using, it's a ray tracer. And so I actually just made a mirrored sphere and then a layer of clouds on top. And you can change the height of the clouds and you can change the size of the sphere and see what distortion you see.
Yeah. In all my life, I've always seen distortion of any image. It could be a car bumper, a chromed car bumper. As I'm cleaning it up, I see my image, it's distorted. It doesn't matter what curved surface I've seen. I've never seen a perfect mirror image ever. Not from a curved surface. Never in my life. A mirror, that's the back side of the mirror, that's chromed. The mirror itself is showing me a lovely picture of myself, but when I look on the back of the mirror, it's distorted because it's chromed and it's got angles and curvature. I don't see a perfect image of myself. I see a distorted image on any curved surface. This is what's so good about God's earth. Simple. The lies just don't happen. It is what it is. A curved surface will never show you a perfect image of yourself. Can't, because the surface is curved.
So that's what he was about to say. Is yes, it's a mirror image, but we would expect it to be in a mirror image on a ball.
So not quite.
Wait,
so
aren't you? Yeah, close enough. Aren't you? Really you're the guy who said. But you started by this whole thing by saying you saw it curved from an airplane.
I've never taken a picture and compared it to this from an airplane. And I think
you're the same guy who said his best Earth ball evidence was you've seen it from an airplane, right?
No, Hawk. I got him to clarify on that. Remember, he said he'd never seen it.
I had to go away. Okay, I missed 20 minutes of it. I shouldn't have. Okay.
He said he'd done a simulation which said, according to the globe, we should be able to see it from a plane. And then I said, well, have you been on a plane? And he said, yes. And I said, well, did you see the curve? And he said, no. So I said, well, there you go then.
Oh, okay. Maybe I'm sorry. I had to go away for a few minutes.
No, that's fair, though. It's a fair assumption. The way he's arguing, you would think he has seen it from a plane.
Yeah, I feel like we're getting back to that.
Though I should clarify that it's harder to say. It's harder to say you should visibly see a curve, because then you need to get into
what. That's just not true, because we've all been on planes and you can't see the curve, so we know that's not true to begin with.
So I should clarify that my claim isn't about being able to see with the human eye, but with a camera. If you take a picture and if you know
even with a camera, you don't see the
camera and the
and that's going against the globe model again. So you're even at odds with what they're actually telling us about this globe in terms of what we should see.
I disagree. Because the simulation has all that all of the math for what you should see baked into it. So if there are people claiming that curve,
but that's where I was that's why I was getting to the point where what you see from the plane is a city beneath you or a portion of a city.
Okay.
And you're seeing the curve of the Earth when you pull out your camera?
City or a portion of the city? I mean, it depends on where you are. Maybe there's a city.
Yeah, you said a 35,000 altitude flight. 35,000 feet altitude flight.
I don't know what you mean when you're talking about a city.
Goodness gracious. What do you mean? A city is where people live.
So yeah, you could I'm sorry.
So all I'm trying to get you to realize is you're seeing such a small portion of a particular state, let alone a continent, yet you're seeing the curve of the Earth. Well, you have a lot of land masses and oceans to fit into this ball, remember?
Right. But
tiny Earther.
Right. What I'm saying though is that even though it's not what we expect when we think like, okay, I'm like not that high over the globe. When we do the math and visualize what it would look like, we should see a very slight.
Who is we? Who is we?
Me. I mean the math in this visual.
Which visual?
I'll post the one that I'm talking about.
So strange. So Entmonk, how do you think
the code is open source, so you can look at the code for each of the visuals to see.
Yeah.
Can you think that Neil deGrasse Tyson, who is the PhD planetarium guy, they put him on TV, he hangs out with the astronauts. How do you think he messed it up so bad where he's saying, no, you can't see curvature from even 120,000 feet? Do you not think that's a bit odd?
I think the realistic answer is that he just did it wrong. I think that a charitable answer was that he was talking about like where you could visually discern it with your eyes. But the claim I'm making here is particularly about cameras that you could take.
But they had a camera. It was the camera that he was talking about where he was saying, no, this is just a portion of the lens.
Right,
but that's what I'm saying though. So how is it that they've messed up so badly that they've got this guy who's PhD planetarium director, he's on TV, he's teaching children all across the earth, he's hanging out with astronauts, but you think he can't do the basic math to figure out when the globe should be seen or not? Like that doesn't make sense.
That's a good question. I don't. I mean,
has anyone called him out on this? I mean, have you brought this to the attention of the people, NASA, or him? Like, who's calling him out on this? Are you the only one, or what?
Sure,
is this under review?
I don't know. I would say that this is kind of like a side thing. If the math sort of will stand for itself. The code is
the math.
There.
You keep just saying the math. What is the math? Yeah. What are you using for a coordinate system?
So I'm just using this visual is just a sphere. It's just a camera.
How is the image being created?
With ray casting.
Okay. In what coordinate system?
We don't really need a coordinate system.
You don't need a coordinate system, so you're not using homogeneous coordinates.
What is that?
Oh, Jesus Christ. So you have no idea, Eddie, you don't have a fucking clue about 3D rendering, is what you're telling me.
Can you explain it? Maybe I used it and I didn't know that.
Homogeneous coordinates, a coordinate system. It's a generalized geometry coordinate system for creating images where you have a projection plane and then you have a 3D scene, and the points in the 3D scene get projected through points on the plane, and the plane is your image.
Yes, that's what I'm doing. Yes. So,
okay.
Yeah, that is how we're.
So what radius value are you using?
So how does that predict what a camera sees versus what a human eye sees? Because what's the difference? The difference between a camera and a human eye is the diameter of the lens.
So, can you?
The diameter of the lens, right? The human eye is like 10 millimeters. If I whip out a P1000, it's something like, I don't know, 4 inches or something. The diameter of the lens. I don't know why you don't understand this. Is this your app?
Yes, I made this. I guess I'm just trying to figure out what the.
Did you use like pre-made libraries or something?
This is all from scratch. This is with WebGPU.
From scratch, and you don't know the coordinates you used.
Well, I mean, I hadn't heard it defined that way before.
In homogeneous coordinates, it's a standard in all fucking 3D graphics.
I just did it kind of just from first principles kind of thing. I don't know what all of the ways of doing it is.
Euclidean geometry then?
Yes.
Like XYZ?
Yeah, everything is in Cartesian coordinates.
In Euclidean geometry.
See, you've also got stuff like, I can see in your code, you've got use flat Earth, and the description is toggle between spherical Earth and infinite horizontal plane.
Yes.
So, I mean, this is...
let me go.
If you've done all this yourself, fair play for the effort, but this is all just fantasy, dude.
Yeah.
Like, what radius are you using here? Like, I don't actually see a number for the radius.
There's a constants file that has the radii of that I'm using. I'm using the Earth radius in meters, whatever that is. I don't remember off the top of my head.
Right, but see, that's what's in contention, because we would point out that you don't actually have a radius of an Earth, and so this would all be, theoretical imagination.
This would be like testing to see if, using the radius that they give us, what would we expect to see? That's what I'm trying to achieve.
No, right. Not what we expect to see there.
But if you're showing any curvature in that, then that's not what we expect to see, because we know what we expect to see when we fly above the Earth, and it's no curve. You already said that. You didn't see any curve. None of us see any curve.
I didn't see any curve with my eyes, like perceptibly. But
your visuals on this are showing a curve.
Yes. Yeah. No,
which isn't what we've seen.
By the way, if I may quickly...
so how can you say this is what we would expect to see, even though we don't see it, and then you're going to depict a curve that isn't seen and say this now makes sense? Like, the whole thing doesn't make any sense.
If I may, and Monk, sorry, gentlemen. Where's your code? Where'd you post it?
It's linked in the website. On each one, there's a link in the top left.
The link is at the bottom. What's it written in?
It's written in TypeScript and in WebGPU shaders.
Okay, TypeScript.
What I want to know is this: how did you get from Euclidean geometry to projective geometry? How did you convert from one to the other to create an image?
What we do is we have the plane, like you were saying, where you have a pinhole, like you have the camera location in Cartesian coordinates, and then you have this plane. Or for the fisheye lens, we just go out based on the angle projection, and then we trace that ray through the plane window and refract against the layers of the plane window, and then that final ray we check to see if it hits. We just analytically check to see if it hits the sphere that's below, and then we return the color after that.
Are you like reinventing the wheel or something? This is a I'm serious. This ain't like a standard way of like doing a 3D engine or anything like that.
It might be, yeah.
It's a standard way for ray tracing, but like, how did you get? You said you use Cartesian coordinates XYZ. How did you get to the plane in the image it creates?
Like, how do I create?
Because you have the 3D world, right? And then you have the plane, right? Ostensibly, let's say that's the eye or the camera sensor, right? The retina or the camera sensor. Let's assume that to be true, even though it can't possibly be true. But let's assume that's true. How do you go from a point out in 3D space to a point on the? Did you say the lens? You were using a fisheye lens?
There's a fisheye lens setting, yes.
And that's projecting it onto a virtual sensor?
Yes, yeah. We use it's different for the fisheye lens. For the fisheye lens, we just go straight from the projection geometry, where the angle of the ray that we look for is just based on the fisheye projection equation.
Also, where have you gotten all the math for the window properties? that you're calculating here. You've got the thickness, you've got the index of refraction, you've got the outer pane thickness, the air gap 1 thickness, inner pane thickness, air gap 2 thickness, scratch pane thickness, all sliders. What math were you using to program the refractive properties of a view from an airplane at however many thousands of meters, which would also take into account that's not taking into account air conditions, right?
That's true. Yeah, I haven't added air conditions yet. I wasn't able to find great sources for like what airplane windows are. If anyone has them, I would be happy to add them. So what I did is I basically we have those layers, and then the most common material, we have the index of refraction for that. But then just to demonstrate kind of what an extreme, what an extreme level of refraction would look like, if you use the simple window model, then you can just select a single layer and then the width of that layer and then the refractive index and see what it looks like. And
have you treated the window as a flat window or a curved?
And why do you got 35 millimeter sensor, dude?
It's a slider.
Yeah, I know, but like a 35 millimeter sensor would be fucking gigantic. Sensors are like tiny, dude.
Oh, the size of the sensor.
That's the actual place where the image is being created is on the sensor, right? So when I move your slider, all of a sudden it stops being a curve, you know.
When you're using the advanced camera and the advanced camera things.
Yeah.
So that's going to change the size of the sensor. You can move it down, I guess. What are the common sizes of sensors that you'd expect?
Like the size of your thumbnail.
Yeah. Hopefully, if the ranges on that are not accurate,
let's see what an A4 sensor is. Oh.
How long did it take you to make this? Could I ask? How long did it take you to make this simulation?
I started working on it a couple weeks ago after I was in here talking to, like when that first started.
So it's taking you a couple of weeks to make that. Obviously a lot of effort went into it. I'm just kind of surprised that, you've gone to this much effort for this, but you're not concerned about the lack of empirical detection of this curvature that you're trying to simulate in reality.
And if I may point out, dude, checking your constants files under core utils, and I don't see anything about Earth's radius, Earth's circumference, Earth specific any geometry or any geometric characteristic. Is it one of the? Do you compute that on the fly with a slider or something somewhere? Rather.
Well, it said on row like 400 or something. It's something about the spherical radius in meters, but it doesn't actually give a number there. But I guess that's built in somewhere under the code lines.
Yeah. Well, there's several files, right? So in the file source/core/util/constants ts, where I would have thought that he would have put a radius because it's a fixed.
Oh, this value. Is under airplane. This is under airplane window.
Okay, source.
Under
scenes, I guess.
Scenes, airplane window, line 402 or 403.
I'm also back. If there's any questions,
Are these working sliders, dude? Do these actually work, or are you adding features?
System bodies. Okay, thank you. Got it.
Which sliders?
Yeah, index or refraction sliders don't seem to be working. Inner pane thickness don't seem to be working. Outer pane thickness, air gap thickness, air gap 2 thickness. None of these seem to change the image.
That's kind of what I found is that the panes are so thin that it's basically imperceptible, the effect that it has on the angle of the light. But I kept it in there just just to test it. But the reason those sliders are changing the values. They really
also, I meant to ask as well, you've got reference to a cylinder surface. We've got distance from camera to cylinder surface, radius of the cylinder. What's that referring to?
Where is that?
That's lines 404, 405 under the airplane window.
Which file?
Airplane window under scenes. It's talking about cylinder radius underneath the sphere radius. I was just wondering what you were referring to there.
Okay, yeah, this must have been, I think I repurposed this part from something else. Yeah, where is this coming from? I must have copied this code over from something else, but this is just an issue where the variable is named incorrectly.
Also, do you think it would be an issue that you've used?
Cylinder. Never mind. The cylinder is the plane. I'm just rendering the plane as a cylinder.
Right. Okay, I did wonder if that was maybe what it was supposed to be. Okay, but also, so you've got flat Earth as an infinite horizontal plane. Is that what you think we're claiming?
No. It's just the way that to make it look flat. The way that the ray casting works is just that it's you take the ray and then you just analytically figure out where the hit would be, and I guess I don't know how else to do it other than just make an infinite plane. But obviously beyond a certain distance, I mean the angular difference between the sizes of the planes are going to be, they won't matter.
Okay, interesting. Well, I mean, fair play. At least you're putting in some effort. That's more than 99% of the Globe believers are doing here. So I'm glad you're engaging with the topic. What I would suggest, though, is not to try and get into simulations of what the globe is claimed to be, as much as seeing if the globe as it is claimed to be is actually showing itself in reality when people attempt to detect it.
Yeah, I definitely want to make some measurements. I still have not tried measurements myself. What I'm going to do though is I'm taking a plane soon, and hopefully if conditions are good enough, then I'll try to take some pictures.
Okay.
And see if it matches. But yeah, so that's the plane one. I also made the mirror sphere ones, which is kind of attempting to address the mirrored surface things, because I was curious too when I heard this argument what different sphere sizes would look like when you mirror them.
But they're only but they tell us that they know what the size of the sphere is, right?
Right. So yeah, if you pull the slider up on the mirror surface one, that max value is the claimed Earth radius. And if you zoom in really far, you do see some areas where I think it's either that things in the sky don't appear mirrored at the very far distances. And so if you're able to get a mirror like a
it's kind of difficult to tell with the pattern that you've put on it, because it's like an irregular pattern. It would almost be better to have like a uniform pattern to make
those patterns. Especially clouds.
Yeah.
Especially clouds.
You can change the scale of the clouds to make it a little easier, and if you change the density of the clouds, to make them kind of so there's fewer to deal with, and it's not as visually cluttered.
Okay. Well, this is a trip.
He still thinks the Earth has a radius. That's interesting.
Yeah, it's baked into. But here's the real kicker, though. By the way, just want to point out, dude. I'm looking at your code and everything. Good work on this. This is really clean, and the app itself is very, very smooth. So I can congratulate you on that. Okay, like Cyclone was saying. Like Cyclone was saying, obviously you put some good work, you put some solid work into this. So kudos to you on. Okay.
Thank you. Yeah, it was a blast. I always learn so much when I get into flat Earth. I had never used WebGPU to this degree before, and WebGPU was very fun to learn. So I'm glad that
this spherical mirror one is like an acid trip. Playing with these sliders, like an acid trip. Watching these.
Moving the I was actually kind of scared. I was almost considering putting like a epilepsy warning on the on it when you see those things, it flashes at you.
Yeah, you start like messing with the Earth radius, like decreasing it and increasing it. That's a real trip.
Yeah, I found it in the code there. You didn't. Yeah, you had it under a different file, so that's there. And it's in meters, 6 point something times something to the e to the 6 or something like that. Yeah, it matches out to 3959 miles there. It's all good.
Do you know what I like about this?
You can change the unit if you on certain ones. You can change the units if you'd like.
You want to standardize it in metric or whatever, and then convert. It's not a problem there.
Yeah.
You know the good thing about this, and it's something that I've thought about for a long time, is like if we made a video game of this topic, basically, and you just made it a fairly rudimentary, you'll either spawn on a flat surface or a curved surface, and you're given some straight edge tools, let's say something that simulates a laser or a line of sight with 2 points that you can make. Everyone would be able to figure it out super quick, because if it's a video game or something like that, people's logic would actually work. It's only when it gets into the real world that people tend to avoid what's obviously apparent here. But this is almost like an example of the world you'd be building, which is these infinite planes or a ball with a radius of a certain size. This is almost the start of our flat Earth video game, end guy. So maybe you can help us out with that.
Yeah, I don't have a lot of faith in this ray casting to perform super well with lots of geometries, but who knows?
No. We just need to use the 3959 mile radius geometry, and then we could assume the infinite flat plane that you mentioned before, and it's like you're dropped onto the surface, and both of them might look flat to your initial observation, but you can plant, let's say, an observer at one point, and then you can move him across the surface to, let's say, 20 miles away, and you can swap between the two views and see what it is, and say, well, if I'm not seeing the laser coming from that initial point that I set up, and I can see the laser going over my head at this distance, I can say this map that I'm on is a sphere of this size. But then if it doesn't do that, they would say, okay, well, this is a flat surface. And I just imagine that a lot of people would intuitively get that right, because it's a video game and there's none of the high stakes involved like what we're talking about here. Because people's logic and reason tends to work well when it comes to a video game, but when it comes to reality like this, they just can't get it. But anyway, interesting stuff. Thank you for sharing.
One thing I'd like to point out, maybe you already spoke about this and I missed it earlier, so forgive me on that, but I'm looking through the parameters here, and I see you've got a index of refraction for the window, right? You have that supposed index of refraction for the medium outside, because a lot of people argue that, light is bending and shit like that through the medium of air, depending on the conditions and all that. Do you have that baked into this somehow anywhere? Like, have you factored that as a thing to account for?
I'm not in the plane one. I'm not doing like continuous refraction through the atmosphere. I'm not doing that.
Okay. Yeah, I figured not there. Like, how do you even model that, right?
I do, although I've made some drafts to try doing it, but it's difficult because the web GPU or like the GPU does all float 32s, and a lot of the like really far distance things. I almost would just rather use like more precise float. And so I've been experimenting with that, but I haven't published it yet.
Okay, no problem. But the other thing I wanted to ask though is, if I'm not mistaken, this window that we're looking through, it itself is curved, right?
Yes.
Okay. So how do we distinguish between the results that we see, the curvature that we see, being a direct result of the window itself being curved, especially if you're, considering a window index of refraction and all that, as opposed, so the window being the responsible agent in creating the apparent curve, as opposed to there actually being curve outside.
So that's what I tried to do with adding this whole window refraction thing is if we can get an accurate enough model of what light would do in a window, then you can like turn on the flat Earth mode and see what the result would look like through the window if it was a flat Earth, and then you can turn it off and see what it would look like without. But the underlying the basic result that I've found after implementing the refraction through the window is that it's for a normal, like for the model that I have for the thin materials, it's a very, very small impact, like imperceptibly small impact on the image result.
Okay. And then what are you actually comparing this to, as people were pointing out before, like the real world observation? Like what are you comparing this to say, oh, well, this is accurate because it actually matches X? Like, what is X?
Right. So I posted a link to Jay Tolan's video, and he has a whole bunch of these, and I haven't gone through all of them, but what I looked at some of them, and in some of the images where the horizon is very clear and there's not a lot of clouds, those are the images that I was comparing them to.
Okay. Yeah. Okay. Gotcha. Thank you.
The only other one that I have up right now, and I will make more, and if people want me to make some certain ones, I'd be happy to. But the other one I made was a simulation of gas particles, basically just kind of talking about what whether or not gas needs a container, that kind of thing.
Right. Could you simulate a collection of particles with gas particles without a container? Could you do that simulation?
Yeah. So I guess it depends on what you mean. So kind of what I was intending with this simulation.
Well, it's very simple. Just listen to the words. Listen to the words coming out of the speaker. A collection of gas particles without a container.
Like, so I know what you're saying. I'm just trying to kind of explain what my intention was.
Okay, more than one gas particle in relative vicinity without a container. How is this, how does this require another 30-minute elaboration on what you did and Web 3D sure. And the constants file, like a collection of more than one gas particle in relative vicinity without a container. Simulate what's going to happen to that system of gas particles.
You could.
Are they going to coalesce into a sphere?
If Newtonian gravity is applied, then yes.
Right. So you could have different switches, right? Turn it on, turn it off. Do maybe some double in Einsteinian with a little bit of tensor calculus, right?
Yeah, sure.
I love tensor calculus.
Who doesn't?
I love it, man. I breathe it actually for finance.
Yeah.
What is tensor calculus?
Of course, in your wet dreams, you do.
Multi-dimensional matrices.
Yeah, in your wettest dreams, you and Pamela Anderson from the 90s are doing tensor calculus together and killing on the stock market. But let's come back down to reality.
So the gas simulation that I have, I'll post it. create particles, and then you can what's happening? And then you can turn on or off gravity, and then you can turn on or off a top boundary for this container. And again, it depends on what you qualify as a container. But there are like I just wrap it around. So like on a flat Earth, I guess what I'm trying to claim too is
physical container, right? A physical container. I think everybody understands what that means.
What I want to try to say is that even on a flat Earth, if you just have downward little g acceleration, you don't need a top to the container. It can be an open lid, and it would still work. So this is not necessarily even a globe versus flat, thing. This is just saying that.
Yeah, we know this. We know that you can contain gas particles using electromagnetic fields, for example. So we know that. That's not new.
This is. I think that's true. You can contain it with electromagnetic. But what I'm trying to say is that even with just little g gravity, you don't need a lid to the top.
Right, but don't worry about this. The definition of gas pressure says it's a normal vector of the force exerted on the walls of a container, right? So if you don't have a container, you don't have pressure. You may be containing the gas using electromagnetism, but you don't have any pressure because there's no wall of the container. So anyways, just show us what happens when there's a bunch of gas particles without the container in your simulation, right? And then let us flip different switches, like,
Yeah, it's there. It's I just posted it. That's the whole.
For example, you could make the gas. You could have a setting for ionized gas, so positively or negatively charged molecules of gas, and then you would allow us to control different levels of electrostatic field, right? Different intensity, and see what happens to the particles.
But the what I'm trying to see is if downward acceleration or gravity, whatever you want to call it, if that is enough. I think that it's if we're not disputing, whether or not gas can be contained by electrostatics, then.
Well, so let me help you. You're a glober, right? So you kind of believe in Einstein and the equivalence principle, right? So you don't need to argue with us about gravity. You can just say, imagine a box full of gas, right? Contained. Now imagine you open the top, right? Well, gas is going to come out. But now imagine that you accelerate the box, that's the equivalence principle, at 10 meters per second squared upwards in the direction of the open wall. Now imagine you accelerated more, right? 20 meters per second squared, whatever, 100. What happens to the gas, right? Will it form a gradient just because of the acceleration? Like you could simulate this as a thought experiment, right? That's what Einstein did in his head.
You can try it right now. Exactly what you described there. That's what I did.
Right. So basically, you could title this equivalence principle and the effect of acceleration on a slightly open container full of gas, right? You could write a little paper here. We're going to review. We're going to be your peer reviewers. I mean, by we, I don't mean me because I suck, but people like Indio. And we're going to go from there,
Sure. I'm
doing a peer review of your performance right now. It's quite laughable.
It is. I'm laughing my balls off.
Peter's a fake flat earther trying to pose. He's actually here to run interference so that we don't talk to you and that he freaking gums up the works. He thinks he's clever, but he's not.
The person who I'm talking to is not a real flat earther?
No, he's not.
Oh, shoot. Well, I got trolled.
Not at all. He actually was in a group called Globe 46 that tried to take us down on the politics server. Not take us down as in get us banned or kicked off, just whatever. Defeat us or whatever they thought.
I see.
Yeah, he's not just a globe earther. He's an anti-flat Earth globe earther that has spiraled so bad. Now he runs around pretend to being a flat earther, so his reasoning is he is sick of bad flat Earth arguments, and since he is a newly minted flat earther, he's trying to fix everybody's arguments.
I see.
That's his.
I was suspicious.
That's the last stick I heard.
When he brought up the upward acceleration thing, because wasn't that something that was on like the Flat Earth Society, that they thought that the Earth was accelerating up at 10 meters per second squared?
Yeah, Einstein wrote about it apparently, that the Earth would be equivalent to a disk accelerating up at 9.8 meters per second squared. That's kind of where that comes from, that idea. But nobody here believes that shit.
Yeah. This is always a question that I've had. Do you think little g is real? Like, what do you think of?
Yeah, I think small that's real. Yeah, sure.
Okay. Yeah.
You know that empirically. We don't need any theory to know that.
Right. So, do you think that means that we don't need a lid to the container of the Atmos then?
Well, see, that's where it gets crazy, because if you look at the kinetic theory of gases, there's no G in any of those formulas. So when we try to predict using physics what gas behavior is, we don't use G. We ignore it.
Right. But the kinetic theory of gases is accurate on small scales, but if you want to predict gas pressure at large scales, and like if you want to predict gas pressure in the atmosphere, then you need to incorporate the hydrostatic equilibrium, and in order to get the.
Who told you that? An astronomer?
No. This is just like the way we.
You see the problem there, though, right? Is that, hey, in the lab we can do all these things. Oh, we can't do that, and our theory that we've gotten from empirical experiment, it can't extend to explain the atmosphere. So we're going to come up with a different theory.
But we can explain, but we can test the accuracy of like the barometric formula or other more advanced versions of it, because we can test air pressure at different altitudes.
Yeah, but it varies, so it's kind of.
But it does vary. It does vary with temperature and things. But like airplanes need to know, like, so airplane altimeters use barometric pressure to know how high they are. So they need to know with high degree of accuracy. And it turns out that altitude has a much greater effect than temperature at higher scales, and that's because of the barometric formula.
High degree of accuracy. I would say they need to know it good enough for practical purposes. I wouldn't want to test your theory of barometric pressure flying an airplane. How accurate is it? What's the precision of our model? Oh, 10 meters, crash.
But obviously, if
you're not testing it to that level of accuracy, buddy. I mean, there'd be a lot of dead pilots.
But if you're close to the ground, then you are going to be using other measures other than like you're going to be using other measures than just your barometer to know your altitude. But when you're really high and you can't see the ground, then it's useful to use barometric pressure to use like the standard understanding of the pressure in the atmosphere to tell how high you are.
Well, I think they would know from the performance of the aircraft how high they are.
Yeah, but
within a pretty degree of certainty, a difference of 1,000 miles at 50,000 feet or 1,000 feet, right? The accuracy. Say you don't know within 1,000 feet how high you are. That doesn't really matter at 50,000 feet. You're in no danger of like smacking into the ground or hitting a meteor.
They need to know it precisely because it will impact performance. Like it's good to know, like, okay, we are at 35,000, we should stay here. And that's what the altimeter is for. And the altimeter is based on, it's like the idea of.
Yeah, I understand. I just don't think the method is that precise. Okay. I just think it's good enough for practical purposes.
There's an international standard for how pressure changes with the atmosphere that relies on.
Yeah, I understand that. I understand all that, but like, how are you going to test that precision? You understand? Like, my altimeter says 50,000 feet. Okay, great. Am I going to drop a tape measure?
You can
see if I'm at 50,000 feet.
You could use.
Yeah, that is an alternative method they use. They do use radar. I don't know what the precision of the radar is off the top of my head. Say a problem is like it doesn't look straight down; it kind of looks up at an angle. So.
Yeah. So this is kind of a side argument because.
Well, I'm only bringing it up. I'm not trying to get. Hold on, I'm not trying to give you shit. Because some globe earther sent me a paper with like 5 different models of the atmosphere, and then they come to the end where they're going to try and validate one of these models, and they're like, "Well, it can't really be tested. We just have to go off the U.S. Standard atmosphere model and compare our models to that." So it's not just me blowing smoke; it's in a paper that someone sent me.
I think that we just have very good reason for the barometric understanding of the atmosphere to be the case. And like in this simulation, when you have gravity, gravity turned on, and you have a bunch of particles bouncing around, they just I don't have the barometric formula encoded in this simulation or anything, but they form a gradient that we would expect from the barometric equation. They form that gradient just from simulating collisions between these particles.
Okay, I've already seen one of these, but
yeah,
no one can actually. The problem is demonstration that it's possible. Ultimately, you can have whatever theory you want, whatever hypothesis, whatever you want. Eventually, it's going to have to be empirically demonstrated in nature. That's the problem.
Yeah, I think that the accuracy we do have, airplanes rely on the barometric.
You seem to be not an empiricist.
Yeah.
Well, I mean, I'm just being honest. We encounter 2 types of people, pretty much. Mm-hmm. People that go with the empirical evidence, what's been tested and shown in nature, and then people that are more like lean towards the theory, hypothesis, physics models, blah blah blah. Right?
Mm-hmm. Mm-hmm.
Regardless of what your stance is, if you want to call it science, it has to be tested empirically. It can't just be like theory. Oh, we have a model of gas, blah blah blah. Great. Eventually, you're going to have to go into the lab or in nature and test it, right? Would you agree with that? You have to verify it at some point? Okay.
Yeah.
So, I mean, you can come up with, hey, we have a model. I made my good old gas particles take hyperbolic arcs due to 9.8 meters per second squared. Eventually, you're going to have to go into nature and test it.
Yeah. I personally
think that's fair.
I don't have the means to test it, but I did live in Colorado, and I felt the air, getting thinner the higher I was. Even in the summer, even in the winter, I felt air getting thinner as I went higher. So that's, I guess, as close as I've come to testing it. And that's an instance where the temperature doesn't seem to be the cause of it. It seems to be the altitude.
Yeah, I mean, gas pressure gradients exist inside a container too. You know that, right?
Yeah.
As long as they're not static.
But they don't.
I'm liking your little mirror thing because I'm looking at this and it's not a symmetrical reflection in your little mirror app.
I agree. It's there is distortion. There's especially at the edges as you zoom.
You're gonna turn a mathematical physics PhD into a flat earther. You know that, right?
What'd you say?
You're gonna turn a dude with a PhD in mathematical physics into a flat earther with this.
Really? Okay.
You really helped me out, man. I should freaking give you I helped out India roll or something. Because I had a debate with a PhD in mathematical physics, and my evidence was the symmetry of the reflection in the Bolivian salt flats. And he asked me if I did out the math, and then I gave him the math, and he was like, well, that's not how we see. I said, so you want it in homogeneous coordinates? He was like, yeah, you did it for me. So
well, what?
He's going to be a flat earther now. It's going to be great.
Yeah. Did you take a screenshot and kind of? I didn't actually implement that. Did you flip a screenshot or something to see?
What do you mean you didn't implement it? I clicked it. It worked.
Well, I guess
taking a bunch of screenshots so far.
Yeah. The question is, if you take one of the pictures of the Bolivian salt flats, and you compare it to the, I mean, the distortion is just very slight. It's a very, very slight amount of distortion. It's only at the edges that it's really visible to the naked eye.
Well, I can see it definitely in your simulation easily.
Yeah,
it's not even difficult.
How high are you? Or if you can just link
2 meters, 1 meter.
Yeah. I was not able to perceptibly see it.
I look at this shit all the time. Maybe that's the difference. I mean, one thing you can do, right, is you can try to use the horizon, and like I did measure difference in distances. So if you measure from a point on the horizon, pixel count, to some point on like a cloud, up and down, they won't match up. That's another way.
No, I agree that there is distortion, that if you measured it in ways like that, or if you flipped the image, you could see some distortion.
Yeah.
But I don't think it's, when I've seen pictures of the Bolivian salt flats, they're usually not like zoomed in, and I've never actually I haven't flipped one to see what the distortion is like, but we wouldn't expect it to be like super obvious distortion to the naked eye.
Yeah, but it'd be visible. Would certainly be visible. That was what the contention was, is whether the symmetry would be visible, the break in symmetry, and it certainly is. And then so I debated this guy. His name is Dr. Blitz, PhD or something. I don't know if the PhD name. Anyway, he was on TikTok. He's got like 1 million followers or some shit. Anyway, I told him, I said, hey, when you flip the image, they overlay exactly. And this dude flipped the image freaking horizontally instead of vertically, or did something like that. This dude does have a PhD, dude. It's freaking almost embarrassing. The point is that at the end, I said, so if I show you that there'd be distortion on a globe, and that the reflection in what's being reflected is not symmetrical, you'll be a flat earther. Did he say yes? I think he said yes. So that'd be great.
Yeah.
Either way, I have to jump into one of his streams.
I need to look at some of these images. I guess I feel like it would be, for one, it would have to be really long ways, and ideally zoomed in, so that you could see the distortion. But yeah, I'll have to try flipping one.
I got one I flipped. Hold on. In FU. So hold on. I'll show you. So here's the image that I showed him. Oh, Sasha got a nice one. There's one with a sunset too. That's fucking badass. But the water's a little rippled, so.
Okay, yeah, I see.
So I'll show you the horizon isn't exactly in the middle, so you have to line up the horizon. You're going to have some over. You'll see. Hold on, I'll show you.
Ideally, what we'd need is like clouds that are far away.
Well, look. You see what I posted with the red X? Right?
Yeah.
Dude, it's like, look the arrows. So like you have a person there. The tips of those arrows are right at the bottom of his feet, and you can see the horizon divides it right in the center.
Yeah.
So this little box, right? You can find the center of a box by drawing lines between the diagonals, and you'll find the exact center of the box. So the corners of the box meet clouds. There's a cloud on the top, a cloud reflected on the top and the bottom in the same place. So I just made this little box so I could find the center, and it also meets exactly on the horizon. So there's a bunch of different ways you can measure whether the image is actually symmetrical. You don't have to just eyeball it.
Yeah.
Now there can be alterations because of tilting the camera and shit. You can't get like, I wouldn't say it wouldn't be symmetrical, but problems when the horizon isn't exactly in the center. There's problems when it's not in the center of the image. As you can see in the image I posted, you can see some excess, right? Excess in the top and bottom because the horizon isn't in the center of the frame in the original image. Right, so I have to line them up to flip it. I have to flip one, line it up, line up the horizons.
Yeah. So when I zoom in my simulation, I have to be at like a 15 degree FOV and be able to really easily see clouds at the very distance, and you can see that some of the clouds are not reflected where in the same place as the horizon. I just don't think that we have enough detail in these photos to notice, because the distortion in the near part of the image is like nil. Like I can't visually see anything, and I can only really see really far away.
Well, I mean, I wouldn't call it nil. First of all, it's not really nil because if you look at if you look in, well, I'll just show you what I'm looking at. This is a screenshot I took. This is the full frame that was shown. I drew X to denote the center, which way the camera's pointed. Okay, so as the globe would have a horizon dip. I couldn't get the fucking.
It looks like your altitude.
I couldn't get the angle. Yeah, I couldn't get it exactly. I turned the mouse sensitivity down all the way down too.
Let me.
And I couldn't get it at 0.
Let me see if I can. Do that. So if you zoom in, something that could make it easier. If you zoom really far in, you can zoom by scrolling. If you zoom really far in, then you can put the cursor right at the horizon and then zoom back out, and it'll stay there.
Oh yeah, that's a good trick. Yeah, but the horizon should be dipped, right? So the horizon isn't going to be at 0.
When the observer is really low like this, like a meter off, then the dip from the horizon is going to be extremely small.
So, but I don't need to be zoomed in to see that they're not symmetrical. It's pretty obvious to me. I mean, maybe it's not obvious to you, but it's very obvious to me. Maybe because I look at like this type of shit going on 10 years and like just looking at an image and looking at the horizon, looking at the sky and the ground is kind of like second nature at this point. Done it probably fucking thousands of times at this freaking point. Jeez.
Yeah.
But I can see it's not symmetrical. I can just look at the horizon boundary and see where ostensibly the water, the simulated water, isn't the same as the sky in a bunch of places. It's not like just one place.
Yeah. If I will say, because of the way because we're limited by the resolution of the screen, if you zoom in and out, you'll see that some pixels leave and some pixels come back, and it's just a rendering artifact.
Yeah, I noticed that. Yeah. So it also does it when you rise in elevation. That's a weird. If you look at the horizon, if you change the elevation, like go up and down, and just look at the horizon, the way it kind of like unfolds is kind of weird. Are your clouds curving too? Are your clouds a sphere?
The clouds are a sphere, yes.
Yeah. Okay. Maybe that's it. Yeah.
Hey, what's up?
What's up, G?
How's everyone doing?
Saturday night says it all, bro.
We're doing great. Yep. How about you?
Doing pretty good.
Have you been here before to our Flat Earth server?
Probably not in this particular chat, but I've been part of the server for a little bit.
And do you have any thoughts about the globe or Flat Earth?
Oh yeah, I have a lot of thoughts about the globe and the flat Earth. For sure. Jeez.
What thoughts do you have? What's the first one that comes to mind?
The first one that comes to mind, to me?
Yeah.
I think it's interesting that people think the Earth's flat.
Why do you think people think that?
I think they have a lot of distrust in institutions and the government, which I think is reasonable.
Really? So I woke up one day, I was like, man, I don't trust the government. Earth is flat.
That's not quite what I said. I think it's reasonable.
Yeah,
you
said,
I get it.
He asked you why you think flat earthers think that, and you said because of distrust in the government.
Well, yes, yeah, but you did apply a little bit more to that than what I just said.
Well, that would have to be the case on how I became a flat earther. I would have had to have distrust the government as the first thing.
Okay.
Do you think maybe it was the evidence that the Earth was flat?
All right. Well, we can apply that to it. Yeah, sure. I'm sure there's more to it than just what I said. Sure, there's evidence maybe to why you distrust the government. I think there's a lot of evidence to that. I agree with you on that. I don't think we're going to disagree on the government.
Jay, all you're doing right now is telling us what you think about flat earthers as opposed to what we think.
What do you mean?
You're telling us what you think. You're telling us how you think we think, but you're way off base.
Okay, but I mean that's because you guys were asking me this question.
Yeah, I know. Well, you're way off. Okay, so you're way off base. Nobody thinks the Earth is flat because they don't trust the government. There's plenty of people that are globe earthers that don't trust the government.
I didn't quite say that. I mean, I would have said more. Obviously, I have nuance to my opinion here, but yeah. I agree. I think you guys believe it to be flat because of evidence, or because of the evidence you.
Well, the Earth looks flat, right?
Sure. Yeah. It looks flat.
Yeah, and someone came around and said, "Hey, that's not actually flat. That's actually a giant ball. Trust me, bro." Why should I believe them?
I think it's a little more complex than that, but yes.
Well, I'm just boiling it down. I mean, we can get in the complexities of the claims, right? So
I think, yes, it is fair to say that most people just accept that the Earth is a globe without doing much research on their own.
But what do you think? Well, what do you think the best evidence for the globe is?
What do I think the best evidence for the globe is? I think I answered a similar question about this earlier this morning. But I was in the politics flat Earth talking to someone.
Yeah, I wasn't in there. I missed it.
Best evidence. I think just all of the different groups of people that work on different things that kind of add to the body of evidence that the Earth is a globe and would go against the fact that it's flat.
Okay.
So I think even outside of obviously like astronauts and NASA and whatnot, I think seismology, like there's things that I feel like seismologists and people who just work with earthquakes and detecting them, like it wouldn't make sense for the Earth to be flat.
Okay. Maybe that's because you're ignorant about what they're actually doing. Have you ever considered that? And that you just made some shit up in your own head about how it works? So in seismology, in seismology, they use something called the hyperbolic wave equation. Have you heard of this? They don't assume the Earth is a globe. They assume the Earth is a hyperbolic disk.
Do they?
In their model.
I mean, I'm not aware of this. But
well, that's what I'm saying. Like, you reach conclusions about things based upon not knowing about that thing. We see this all the time of people. They think it works one way because they think the Earth is a globe, and they go, well, it has to work this way because the Earth is a globe. But then when you actually dig down into the details of the models or what they do, there's no globe in the model at all, such as eclipses, sunrise, sunset times, seismic waves, tides. There's no globe in any of their formulas. There's no globe in any of the mathematics. There's no globe in any of it. People just think there is.
So you're saying they operate off knowledge of the Earth being what shape again?
They don't. No.
I just want to double check
model.
on this fact.
So they have a mathematical model.
Yeah.
It's called the hyperbolic wave equation.
A hyperbolic wave equation.
Yes, right. I can give you a link. Hold on. I'll give you a freaking citation.
Sure. So, and what's wrong with it?
Is the Earth a hyperboloid?
No, it is not.
Okay, then.
So do you understand
how do you
all
reach
the science?
The conclusion that the Earth's a sphere if there's a bunch of seismologists assuming the Earth is a hyperboloid to figure out where waves came from?
Do you think that sometimes they make assumptions to simplify equations, though? So just because there's an assumption, it doesn't necessarily mean that the equations would necessarily be off.
Then how does it demonstrate it's a globe?
Did I say that demonstrates it's a globe? I was just saying there's multiple bodies of people working on different things. So that's why I
think that, dude. You just tell me what you think people are doing. You don't actually know what they're doing.
No, See, I don't. Exactly. And you don't either, do you?
Yes, I do, because I've talked to
you people. Understand this body of science better than these
Which
people.
One?
And let me just get this straight. Do you not think that we're talking about seismologists right now?
Yeah, I've talked to seismologists in this chat many times.
Yes, I've spoken to many too. So the point being, neither of us are seismologists, right? I'm not about to make assumptions on the equations that they operate off of. I think that's quite a big ego to think that for some reason that you've transcended past this like propaganda that we've all been fed, right? You think
they don't know anything.
Propaganda. And that they're operating off of incorrect information, but for some reason,
I never said that. That's a straw man.
You have transcended this incorrect information.
That's a straw man. That's a straw man, dude. I never said anything like that.
All right,
I never said anything even remotely resembling that.
Go ahead and explain it then. Do you think that you understand something that a lot of seismologists don't?
Okay,
is that
understand? What do they understand again?
The point being is that you're drawing conclusions on what these people understand. You're saying that these people are.
Look, they don't know anything. They don't know anything. They don't know if the Earth is a globe. They don't know if it's flat. They don't know either way. They have no way to know. All they have is models and data. And they fit the models, they fit the data to the models. Now, they could assume the Earth is flat and use that as a model. They could use a sphere. They could use a hyperbolic wave equation. They can use whatever they want. They can use a frickin' back of a rabbit. It doesn't matter. They're data fitting to a model. That's it. Now, you're the one that thinks models, it seems to me, you think that the model is physically real. If you talk to any of these seismologists, they don't believe any of that.
Okay. Does that disprove the Earth being a globe?
No, what disproves the Earth being the globe is the fact the surface of the Earth does not curve.
The fact I'm trying to bring here is I assume basically all of these people in their field see these things and it adds to their
What do they see? But what do they see?
So, okay, let me step away
Tell
from
me
something.
what they see, dude, and then we can evaluate their claim.
I'm just saying they operate off of the fact that they are reinforcing the fact that the Earth is a globe based off
you
of
don't
what they
know
see.
that.
No, they're not.
You're just
most of the guys have just got tunnel vision. J-Dog, most of the guys, J-Dog, most of the guys have just got tunnel vision in their own particular fields. My job is to study rocks. I'll study me rocks. I'll tell you all about it. What do you need to know? They're not going out there going, the Earth is a globe, therefore my job is done in a particular way. No, they're just doing their job.
Yeah, you think they're like got a rock and be like, this rock can't exist on a flat Earth. I'm a flat earther now. Like, what rocks prove a globe? When they sit there and they look at seismic waves, a freaking chart with a bunch of squiggly fucking lines, how does that tell them the Earth is a globe?
So let me go to something more.
You're not going to answer that. Nothing they look at tells them the Earth is a globe. You just think it does.
Let me ask you this: do you believe in gravity?
What is it? What are you talking about? I believe in gravity.
Do you believe that the current? Here's a better way to phrase this. Do you believe that the current scientific body that talks about gravity, right? Do you think that they are accurate on it?
No.
Okay, so do you know about LIGO? I'm sure you do, right?
Yes, I do. Way more than you.
Okay, I'm sure you do. I'm sure you do. But do you know more than the people who are working on that? Do you know more?
Oh yeah, probably. Probably.
Wow. That
yeah,
okay.
because I read. Listen, I read.
We're gonna be able to have a conversation here.
Yeah, because you're just assuming I'm stupid and that I haven't read all their fucking primary documentation. If you search my name in this server, you'll see all of LIGO's fucking documentation posted years ago.
Indio.
Okay, let me tell you.
That you
okay, so what is the thermal? What is the thermal variance? What is the thermal uncertainty from LIGO, bro? What is the thermal uncertainty from LIGO? How many orders of magnitude is it larger than displacement? Why are you talking me? You're going to sit there and say, I don't know about LIGO. I'm going to tell you about LIGO, okay? I can tell you in detail what they did, how they did it, how it works.
Can we do one thing at a time?
Livingston and Hannaford. I actually have the civil engineering drawings. You brought up the wrong fucking thing, buddy.
Do you understand what I just asked you?
Yeah, I do know more about LIGO. LIGO employs quite like 1,400 people.
Exactly what I was asking you. Did I say I knew more about LIGO?
You said, do I think I know more than the people working on LIGO? Yeah, yes, most of them, sure.
You think you know more than the people who physically are at that location because you read the same documents.
Okay, there's 1,400 employees at LIGO.
Physically applying what they read in those documents, Indio. Do you understand that there's physical application of what you read on top of just
That's
reading?
Right.
Do you think that matters?
Yeah, that's right.
Or no?
That's right.
You have
this is the most bullshit sociological fucktard argument I've ever heard. All you're making is some stupid sociological argument.
Physically work.
But what about these people? It's better than this person. They know more than this person over here. Give the evidence, okay?
Let it out.
This is about evidence. Okay, you claiming this person knows this or this person doesn't know that, that's not evidence of anything. You're just speculating. That's all you've been doing since you came in here. Speculating. No, shut up. Speculating about what you think people know and what people don't know. You think I know something and that I don't know something that they know, and that because they work here, there's 1,400 people that work at fucking LIGO. Which person? Let's be specific. Which person don't I know more? The guy that sweeps the floor? The guy that tends the electric fence? The fucking guy that washes the bathroom? Which guy that works at LIGO?
Indio, whether or not you believe the people
Answer my fucking question.
Are operating.
I'm sick of your fucking gish galloping. It's at an end, dude. Your gish galloping's at an end. You're gonna stay on one fucking thing. So real simple. Let's deal with LIGO.
Let's rewind 5 minutes. Then Indio.
Let's deal with LIGO right now. Okay, you're gonna go on fucking mute. Okay, you're gonna stop gish galloping and you're gonna deal with one thing: LIGO.
So,
okay.
I hope you understand.
What is the resolution that they measure at LIGO, that they claim they can measure?
Indio, I don't know.
Okay, so how do you know I don't know as much as them? Because I do know the answer.
I was going to ask about LIGO.
Do you know how LIGO was built? Do you know who surveyed it, the companies? Do you know that it took 3 different surveying companies? Do you know how they created the GPS monuments? Do you know? Dude, I know all about LIGO. You brought up the wrong fucking thing.
Do you want to have a conversation or not? Do you want me to get a word out? Because I'm...
I want you to actually make an argument that people that work at LIGO know more about LIGO than I do. Make an actual argument that that's the case. That's what I want.
Okay, so first off, I never challenged you with my knowledge of LIGO versus your knowledge of LIGO. Right?
You're not.
So we spent about 2 minutes on that conversation.
I just asked you for something. You're muted now. I just asked you for something. Make the case that the people at LIGO know more about LIGO than me. And be specific.
Indio, I don't have to... Do I have to
be
how to be
specific.
An adult now too, on top of why they're at this globe?
Be specific.
This is immature from you. Let me get a word out.
Yeah, listen. This is just sociological nonsense, J-Dog. None of this shit's going to work. This tactic, we are well aware of it, okay? Well aware of it. This isn't new. This is old shit. Okay?
Got it out?
You're making just a... Don't... Listen. Stop. You're a joke. You're embarrassing yourself. You don't even realize it. You haven't made a single argument that the Earth's the globe. You basically said, I don't know the Earth's a globe, but there's some other people that I believe that they know the Earth's a globe. I don't know how they know it, but I just trust that they know the Earth's a globe. Somehow LIGO, which claims that they measure 1/1000th of a fucking proton radius, which is fucking impossible because it's 11 orders of magnitude smaller than the fucking thermal noise alone. But no, that's not important. Okay? The details aren't important to you. You just trust some fucking fictitious fairy fucking person. Magic science guy figured it out. You can just go outside, J-Dog, and you can figure it out yourself. But come with something
you totally could.
Logical argument.
Yeah, J-Dog, have you ever heard about the long-distance observations that you could do yourself?
Listen.
You don't care about that. It'd have to be a LIGO guy that did it.
Foundation in here first, right? Because I want to talk, but I'm not going to be able to talk if people are talking over me, right? So we need some basic foundation before I actually have a conversation.
No one gives a fuck. Just leave. No one gives a fuck about you, dude.
Listen,
leave.
I'll mute myself then. You guys enjoy. I'll mute myself.
Well, I just wanted to hear you answer my question. I mean, I just wanted to hear if he's ever... I know. I want the answer. If he's ever heard about the long-distance observations. He still hasn't answered me.
He didn't come in here to address evidence. He came in here to make sociological arguments. There's some people, magic science guy is smarter than flat earthers who just don't trust the government. Earth must be a globe. You're a retard, Jay. If that's your argument. Is that your argument, Jay? Did I just boil it down nicely for you? Flat earthers just don't trust the government, but there's other people that they know the Earth's a globe, and I trust them. No one asked you to trust us. What Dandelion just says, hey, dude, you can go out and test it yourself. But you don't care about that.
Indio, you'll believe whatever you tell yourself.
Oh, yeah, so I've never done my own observations? Have I? Have I, J-Dog?
I'm not just talking about your own observations, brother. I'm talking about your assumptions of me, too. But you keep going.
I haven't made any assumptions to you. I'm just going by what you say. Your argument is a sociological argument. You didn't argue evidence for the Earth being a globe. You argued that there's people with evidence that the Earth is a globe, and that you trust those people. You don't actually know what their evidence actually is, but you trust that they must have it. And you also trust that they must be smarter than me because you're a conspiracy-driven flat earther that doesn't trust the government. Is that your argument in a nutshell?
Right. So you can rewind.
Is that your argument in a nutshell?
One of those questions. And
is that your argument in a nutshell, J-Dog?
Another one.
Is that your argument in a nutshell?
Go rewind your YouTube bot.
Is that your argument in a nutshell? Don't ask me to rewind anything. Is that your argument in a nutshell? Is that basically your argument? What I just said? Yeah, it is. And you know it is. It's pathetic. Go find actual globe evidence and come back with it. We don't care about what you fucking believe about us and about them, because that's all you've told us. I believe this about you, and I believe that about them. So the Earth's a globe. You're a retard. Go have fun with that.
Yeah, we're looking for objective demonstration of curvature that anyone can bring to us, and people aren't able to bring that. I mean, that is why, I mean, I know I'm the one who originally asked you the question of why you think that we think the Earth is flat. So the answer to that question, in case you want to know, is we think it because we went out to find any objective, verifiable evidence of curvature, and we discovered that there wasn't any, and that the globe was entirely built on emotional appeal, logical fallacies, and propaganda. So that's the reason. Absence of curvature.
I would genuinely love to have a good back and forth, but I think the temperature has to lower down a bit in here first. And
no one cares, dude.
I'll wait for that for a while.
So you want to
when you come with an actual argument to support the globe, the temperature will change. We don't care about your feelings about people, because that's what your argument is. It's your feelings about people. It's your ignorant evaluation of what you think people think. that doesn't tell us if the Earth is a globe or flat in any way, shape, or form. All you're doing is telling us about your own mental state. We don't care.
J-Dog, can you be honest?
I'm really trying to be.
So how do you know the Earth is a globe?
I'm gonna let someone else take the baton here, and
This is your chance to be honest, bro. How do you know the Earth is a globe?
He can be honest and say that's what you're taught at school. Outside of that, you've got nothing. Because that's exactly what happened to everyone. You were taught a heap of crap at school, and you just accepted it blindly. Went on your merry way.
Well, I mean, I asked him, like, what's the best globe evidence? And he immediately saying, well, there's a bunch of people that I don't know what they actually do, but I think they think the Earth is a globe because they're doing some globe stuff in their jobs. So Earth globe because those other people. So childish, immature thinking, man. Even if all that was true, okay, that they're making all these claims, they should be testable and verifiable. We should be able to test their claims to see if they're true. And when we do, we find they're not true. It's literally as simple as that. But you can't believe that because you're conspiracy flat earthers. And I evaluate truth by looking at the person that said it, not the evidence. I go, oh, do they know the handshake? Are they wearing blue shoes? Did they vote the right way? Did they graduate from the right college? Do they say the right things? That's how you're evaluating truth, by looking at people. It's a genetic fallacy. Dude, how the fuck is there a mosquito in here in the winter? It's like 20 degrees outside. There's a mosquito in here. It's crazy. Sorry about that.
Interesting, when he brought up LIGO, I thought he was going to be talking about the construction of it, like most of them normally do.
Fucking boondoggle, dude. One of the craziest grift ever. And you know what? I could post the CERN physicist saying that LIGO is the craziest grift. I could post it right in the chat saying that it was a bunch of bullshit because they used templates. They actually didn't get any detections, and they used templates and just waited until something matched the template that they pre-rendered. And they did injections. Dude, there's a whole mess with LIGO, man. They were almost out of money. They did all this monkey business, said they got a detection, then got another $4 billion. It's a scam. And even when they got that, they were like, we invented a whole new area of physics. There's going to be PhDs and PhD students and grants and all this shit, dude. We're freaking in there. But no, they're scientists. They're pure moral characters. They don't worry about money or status or anything like that. They're just finding the truth. None of those things are a consideration to scientists.
You can tell you hit it over the head with this guy because he just quit responding. Once you started saying exactly what he was saying, he didn't want to expose it further by talking.
Dude, we've heard these sociological arguments millions of times. It's just like so boring. You don't go, okay, how do I know it's the truth? Well, this guy said something. Do I look at the evidence for his claim? Nah. I'll look at his ID and his wallet. Oh, he has the right credentials in his wallet. He's telling the truth. His claim is true. It's so stupid.
What was that?
What's an ugly spheroid?
Oblique.
The shape of the, oblique. I don't know how to spell it.
Oh my
Oblique.
goodness!
You know what oblique means, right?
It's that if you ever wonder how like little kids they hear a word one time and then they try to repeat it. He heard some kind of word about ob something and he's like oblique. Oh yeah, it's an oblique sphere. That's like art.
Yeah.
That's like painting or glass.
It couldn't be It couldn't be OBLATE by any means.
Yeah, I'm sorry for spelling it wrong. Oh Jesus.
Oblate. Yeah, that's all right. Okay, so Earth, oblate spheroid. Is that your stance? Is that your position?
That the Earth's a sphere, yeah.
What's the size of the Earth?
You want to give me the you want the radius?
Radius, circumference, diameter. I pick and choose.
I'm pretty sure. Well, hold on, this guy posted it. 3,959 mile radius.
Awesome. So, with something that size, you think we could calculate like drop over distance?
I would say on a local scale you could calculate probably small amounts of drop over distance. Yeah, but it'd be difficult to do on like a.
If you're 6 foot tall and you look out over water, how far away is the horizon?
I'm not sure. How far away is it?
Surely we could calculate it, right?
Yeah, you could calculate that. Yeah.
I mean, a quick Google search will
I'll
confirm
Google,
it, but it's 1.22 times the square root of the observer's height and peak. So take the square root of 6 and multiply it by 1.22 to get your distance to the horizon.
So it's about 3 miles away. If you're 6 foot tall. Yeah.
Yeah.
What's wrong with that?
Oh, it's not. It's further. When we go out to test this claim of a geometric horizon that should be at that calculable distance, the horizon does not appear in this location. In most instances, it appears much further than it should do.
Okay.
What do you think about that? If it's further than that, if it's supposed to be in a certain location, but it's not, and it's further, what does that tell you about the shape of the Earth?
It doesn't really tell me anything, really. I mean, there could be multiple explanations for that.
Well, it can't be bigger, because if it's bigger, that means the story they told you about how far away the moon is and what it's doing in the sky is wrong. Like, everything's wrong. The whole story's wrong.
I mean, how far away do you see it then if it's supposed to be further?
Well, hang on a sec, bro. Because in order for you to have a reason why your globe doesn't look like a globe, right, you'd need to know it's a globe in the first place.
So, did you ask how far we see?
No, I didn't actually ask anything. These guys asked me to start talking about the horizon, so.
Okay. I thought you asked how far we do see, like from a flat Earth perspective. But I apologise if that wasn't your question.
We were just talking about how far away the horizon was. If you're 6 foot, and that's about 3 miles.
Yeah. So the horizon distance is going to change, and that's going to depend on two primary factors. One, the technology you use. You understand that you're probably going to be able to resolve things in the distance better with a telescope or binoculars or a high-powered zoom camera than you are with your eyes, obviously. And the other factor is going to be the weather that you're looking through, right? The meteorological conditions, like fog, rain. If it's clear out, for example, you're going to be able to see further. Now, these are really, apart from how high you are above the surface, these factors are going to determine how far the horizon is going to appear to you. The problem is we're told that the horizon should be at 3 miles away if we're at 6 foot. We can see a horizon with good optical conditions and good high-powered zoom technology like cameras and stuff. We can see a geometric horizon well beyond 3 miles. In some instances, it appears to be about 30. And that's just from about 6-10 foot above the surface of the water.
And what technology would you be using to see that?
So a high-powered zoom camera, so P900 or 1000, you can use high-powered telescopes. You can actually see further by changing the spectrum of light. We can use the infrared spectrum, which kind of mitigates for the atmospheric hazing effect that we get with distance. So we can cut through that with infrared. And when we view in the infrared, we see much further than we do in the visible spectrum. It's because we have more clarity. That's why.
Yeah, then you find out that the horizon is due to. You find out that the horizon is due to the convergence of perspective, not because of the consequence of curvature.
Yeah, but the zoom of the camera doesn't break the curve. It just enlarges what refraction would let through. And refraction never brings back the parts hidden behind the curvature. So.
Well, let's try this one then, real quick, Jedi. Before you go into it, because I know you want to talk about it. If you lower yourself down to 1 foot of observation height, right, 1.22 times the square root of 1 would give you the distance to the horizon. Maybe we should talk about that kind of an observation.
Are you talking to me?
Yeah, how far is the horizon from a 1 foot observer height?
Do you want me to search that up?
I mean, what's the square root of 1 times 1.22?
Man, I'm not good at maths. I
Square root of 1 is 1. 1 times 1.22 is 1.22.
Okay.
Cool. So the distance to the horizon for a 1 foot observer will be 1.22 miles. You just you get the square root of the observer's height. So 1 foot in this instance. So what we can show you, and I'll get around to it a bit, I've just got to deal with this quickly and I'll come back. What we're told is the claim that we can Google to the distance to the horizon. Now, when we go to confirm this claim, we don't see that horizon where it should be. That's the point. You brought up earlier about getting a distance to the horizon. That's kind of hard to do. So we'd have to use like known landmarks to estimate a distance to the horizon. Let's say, for example, we had a landmark out to sea that was 10 miles away, and we could say it was beyond it or in front of it, showing it was less than or more than 10 miles. It would be that type of measurement. You understand?
Yeah.
Cool.
What I would like to say, if we're talking about the horizon here.
Yeah.
Let's say we're looking out towards the horizon over water.
Mm-hmm.
And we're watching the sunset. We're standing at the beach with a telescope or something like that, and we're watching the sunset below the horizon, and we're looking through a telescope, and we see it start to set, and then if we get up to a higher altitude, like a hill or something like that, and then we can still see the sun. You can see it again.
Mm-hmm.
What would you say about that? Because that's really only possible on the curved surface.
No, one. Right. So we have to understand that when we're making observations, we're using our eyes or an optic. Eyes and optics have limitation of what they can resolve at distance. Quite simply, that's the angle, or angular size of the object. So that's the reason why that mountain far away looks small and the one that you're standing next to looks really, really big, right? It's really simple to understand. Things get smaller in the distance. Same things apply to the Earth that you look across horizontally. Eventually, with distance, the angles that you can perceive are going to be too small for you to resolve. This extinction limit is known as the horizon, the limitation of what you can perceive of the surface of the Earth. Now, when you change your angle, climb a mountain, climb a tree, you've changed your angle. That angle with distance opens up because you're further away from the object. It's like putting your hands close to your face. You can't see the entirety of it until you move back a little bit. Same thing like with a huge surface that's thousands and thousands and thousands of miles. You can only perceive 3 miles when you stand up. You can perceive more when you get further away from it. It's like when we were down close to the surface. Like put your face down across the floor, and if you've got a tiled floor, like black and white squares, you'll notice the ones in the distance appear really, really, really small until you can't distinguish the difference until you stand up. Doesn't mean that your floor's curved, just means you've changed your angle. Want to know why you can see the sun again? It's the same answer. You've changed your angle.
Yeah, but where would the sun be going? I don't think it moves away.
Away. Now, again, this is just going to be perspective, as why the sun in the distance appears to go down, where earlier on during the day it was above your head, more or less. So the reason why it appears to go downwards is due to perspective. This is convergence, right? The same reason, like when you look down a hallway or a corridor, the walls appear to get closer together. The ceiling and the floor appear to get closer together. The ceiling and the floor aren't actually getting closer together, right? They just appear to do so. Same thing with all objects that are above your eye line. When they move away with distance, they will appear to you to descend downwards towards the horizon. So that's why the sun appears like it's going down. It's not.
Okay, even if we're standing on that beach and we're watching the sunset, if the sun were just moving away, it would shrink into a tiny dot as it gets farther. But that's
Sometimes
not
it
what happens.
does.
It stays. No, it doesn't. It stays the same size all day, and then it drops
Oh my
below the
gosh.
horizon.
This guy's seen every sunset apparently. So you've seen every sunset on Earth.
What's that got to do with it? Like, I can go out and watch the
Because
sunset.
you're saying nuh-uh, because your experience is that it never happened when you were paying attention. You don't realize that there are other situations. Yeah, I know you've not seen it. Other people have seen this.
Other people have seen the sun go into a tiny dot. See.
Hey, do me a favor. Look in the side chat. I'm gonna post a GIF for you real quick. All right.
Oh yes, my favorite.
Keep in mind,
evidence, a GIF on Discord.
I know, right? It's just a video made into a GIF. It's just a time lapse video made into a GIF. A girl is
And where's the
painting
video from?
on a high.
Oh, let me guess. YouTube.
A girl is painting while a sunset is happening. She's not a flat earther. She's just painting while a sunset is happening. The sun gets smaller as it moves away.
this is all nonsense anyways, though. I mean, if you're going to affirm the consequent with sunsets and sunrises, then you've already lost. At the end of the day, the Earth is flat because everybody measures it and uses it that way. That's how it is. It's measured to be flat. There is no Earth curve measurements. Who cares about the sun? Has nothing to do with the surface of the Earth.
Well, how do different countries see different sun angles at the same time then?
Hey, does that have anything to do with whether or not the Earth is curving? Does that have anything to do with whether or not the Earth is curving?
Because it works exactly on a curved Earth. It
I'm
doesn't work on a flat Earth.
sorry.
Whenever the
It
UK
doesn't.
sees sunset, the New
I'm
York sees afternoon, and the
sorry.
Australians see morning.
Dude, you can keep chanting, but you and I both know that that's ridiculous.
Yeah,
The
because
Earth
are you
is
telling me?
measured as flat.
Sorry, Cesar. Yeah, but are you telling me though? Right. Okay. So if you're closer to, let's say, a tower than I am, that we'll both get the same angle to the top of it on a flat surface. On a flat surface, let's say you're closer to a tower than I am, and we both measure an angle to the top of it, and we're on a flat surface, right? Are you saying that we'll both get the same angle?
Oh, I'm saying, I'm saying.
Okay.
Your version.
So,
on a flat
from
Earth,
different
sunset,
positions on a
I don't
flat
think the
Earth.
sun doesn't work.
Right. So from different positions on a flat Earth, you can get different elevation angle measurements to the sun.
Sorry, what version of flat Earth are you strawmanning us with? What have we presented you?
Well, the Earth is flat, so what version of flat Earth are you talking about? I mean, it's
Yeah, the Earth being
The one
flat. You said
outside.
isn't a
version.
model or anything.
The one outside,
What
that version.
model? Yeah, the Earth under your feet. Yeah, it's flat. It's measured.
Let me ask you, B-Man. The B-Man, right?
Yeah,
Is the surface of water in a swimming pool flat?
it's level.
It's flat, right?
I wouldn't call it flat.
What would you call it then?
I would call it level.
Level is flat, right?
No, level's not flat.
What is level to you?
Level, I believe, is what was the definition of it? I think it's to do with
Having no
Let me
point
refresh.
higher or lower than another one. That's the definition of level.
It's a horizontal plane.
Yeah.
What's horizontal?
Having no.
What's a plane? What's horizontal? It's all flat. It's perpendicular to plumb.
So what's your point?
So my point is, water on the surface at rest is always flat.
At rest, it's flat. Okay, well, level would mean perpendicular to gravity, not
Right.
not
Perpendicular
Yeah,
to plumb.
yeah.
You can't have perpendicular to a ball. There's no such thing as
Call-
perpendicular to a curved surface.
Yeah, there is, because
Right.
on a
Call-
globe,
call it gravity
pulls
if you
towards
like,
the
right?
center, so level curves around the Earth.
Right. Perpendicular would be 90-degree angle. Right. Perpendicular to vertical would mean 90 degrees, yes or no?
I don't know what degrees it is. I just know that
Yeah, it would be
towards the center.
a right angle. Perpendicular would be a right to vertical would be a right angle. And if you're saying the surface of water or liquid at rest is perpendicular to vertical, then you're telling us that the surface of that liquid is flat and horizontal, because perpendicular to vertical is horizontal. Like horizontal is not curving. Okay? So you're agreeing with us.
No, because you're saying the surface of the water is flat, but it's
Yeah,
not
so are you.
flat.
So are you. If you say that the surface of the liquid is perpendicular to gravity, then you're calling the surface of the liquid horizontal.
No, perpendicular just tells
Yeah.
you the angle at one point. A surface.
Yeah,
can be
90
perpendicular to
degrees.
Gravity. It can be perpendicular to
Dude,
gravity
you can't
everywhere.
have you can't have an angle to the surface of a ball.
What
You
sphere
cannot
is.
make an angle to the surface of a ball. Try something else.
No, just because a surface being 90 degree to gravity locally doesn't make
You
it
can't
flat
have
on a
90
global
degrees to
scale.
a curve. You can't put a
Yes,
stick onto the
seen a
surface
really
of a
big-
ball and call
have
it
you
an
seen
angle.
Have you seen a really big circle? If you
Dude,
zoom in
what's
and
the
one of the
angle
lines,
between
it'll
a
look flat.
basketball? What's the angle between a basketball and it's sitting on your table? So your basketball's now sitting on your table. What's that angle?
I don't know. You tell me.
Exactly. There's none.
Well, you can.
You're
If you're
begging
using
the
a
question of the
basketball,
ball anyway. There is no sphere Earth. You'd have to have a curvature for that. So if you don't have any curvature of Earth, I'm sorry, you just stuck with flat water, perpendicular.
no, hold on. You're saying you're talking about the basketball, right?
I wasn't talking about a basketball, but someone asked you about the
talking about a
angular
sphere.
relationship between a flat surface, or you could use a stick. Put a stick and put it on top of the basketball and tell me what angle you get.
Yeah, that's the same exact thing.
Yeah, so saying perpendicular means flat is like saying
we're comparing a sphere
every point
to
on
a
the
flat.
basketball is 90 degrees to the
Hello.
center, but the whole surface is still curved.
Comparing the surface of a sphere to the surface of to a flat surface. That's the comparison. Whether we use a basketball for an analogy, a baseball for an analogy, a soccer ball, or the earth, just know that we're talking about the sphere and the lack thereof.
Right. If you have two lines, right, that meet, right, can you have an angle between them if one of those lines is curved? One or more? Is there an angle? Can you measure an angle between the two lines?
I don't know, can you?
No, you can't. An angle will require the intersection of two straight lines. At least two straight lines.
Okay, well, tell me this. You guys believe the Earth is a flat plane? Yeah.
Here we go.
Negative.
Now we're going to talk about something else.
What do you believe in?
It's not a
No, sorry, it's not about belief. The Earth is measured to be flat by everybody. We know that the Earth is measured flat by everyone. There is no curvature measurement whatsoever. The Earth is not a sphere. It is indeed flat as it presents itself to be.
So where's the edge, and why has no one found it?
What edge?
Well, if
What
it's
edge are you
flat,
talking
then there
about?
must be an edge. Or there
Really?
must be
Says you? Well, you okay? Well, then you tell me where I should find it.
I don't know. If you just circumnavigate the world, see what happens.
Earth is not floating with your other planets in space. So where's the edge at now?
What's going on? So what's going on then? Where? How can it be flat and there be no edge?
Oh, because it's the floor. Yeah, it's the floor of the universe.
It's the floor of the universe. What is that?
I'm just curious why you think it has to have an edge. Where would this edge be at?
Are you fucking stupid? Have you ever seen something flat? You talk about basketballs and shit like that.
Let me tell you about my floor right here. Are you standing on a floor? Is there edges of your floor in your house?
No, listen to me. If you get the top.
No, listen to me. Have I ever seen anything something flat? You said, have I seen something flat? Yes. Okay, so I've got this flat floor in here. Where's the edge of my floor at?
Whenever it meets the wall.
Oh, okay. So it meets a wall. Okay.
Yeah. Where's the fucking wall in the globe?
Is that an edge or is that a limit?
All right. Flat Earth. Where's the wall? Where's the limit? Where can you?
Oh, I don't know. Where do you think I ought to find it? I don't know. Where do you think I should find it?
You guys don't know shit because you can't we've circumnavigated the Earth.
Circumnavigation is in a circle. It's not about going to the limits of anything. It's going in a circle. You should probably think about the words that you use before you say them.
Huh? Yeah. Well, if you go from one point on Earth and make a complete circumnavigation of it, and you return back to where you were,
it's called a circle.
You'll be at the same point. You're not moving around.
Yes,
can you walk in a circle on your floor?
Wait, you're not moving around something?
You're moving around the fucking.
Can you walk in a circle? Can you walk in a circle around your floor and not see your wall and not run into your wall? Can you walk in a circle around your floor?
Yeah, you can, but where's the wall that you guys are talking about?
I don't know. Nobody here said anything about a wall except for you. You brought up the wall. You tell me where it is.
Yeah, because you asked me a question. You said on a flat plane. You were talking about your floor, and I said, "Where's the edge to that?" And I said, "The wall." So how come we've never found the wall? We've explored the entire.
Have we? How do you know?
Dude, you brought up the wall then, just like you said. We didn't bring up a wall, just like you said.
Yeah, I know. I'm bringing it up. We've explored.
I don't know about any walls. We didn't make up a wall. That's on you, dude. We can't answer your question you made up.
So, let me get this straight. My interpretation of something being flat is there either has to be a limit, or there has to be an edge.
Okay.
Or something. Okay. Now hear me out here. We've explored the entire planet, minus maybe like a large portion of the ocean. Yes.
You don't have any evidence for that.
every single fucking landmass we've discovered. I mean, come
Sorry,
on.
What did you discover?
Yeah, tell us about what you
I never said
discovered.
I discovered anything. I'm
Well,
talking
you
about
said
like,
we.
everyone fucking else in human history.
Okay, what are
we
their
pretty
names?
much dominated everywhere.
Okay, great. What are their names, and can you tell us where they went and they found the edge?
No, I'm not. No, what I'm saying here is I don't know their names. You know, Christopher Columbus, the likes of those sort of guys. You know, Alexander the Great, who
Oh,
went around
yeah.
dominating everything, and we've been to every fucking island, every little nook and cranny of the
Did
planet.
you know that we discovered 7,000 new islands
So
off the
where
coast of
haven't we
Japan?
been?
No,
Right off the
he
coast of
didn't know
Japan.
that. Yeah, he didn't
know.
know that they found 7,000 new islands off the coast of Japan because he thinks everything's been discovered already.
7,000 new islands.
Yeah,
That's
look it
correct.
up.
Let me see these islands. Hold on.
This is going to be a surprise to him. He says we already found everything, whoever we is.
Well, flat earthers are
An
stupid.
undersea volcanic eruption created a new island in the Pacific in late 2023. So yeah, it created a new island.
What,
not
one
discovered.
island?
They
No,
were
we're
sitting
talking
there. No one
7,000.
discovered.
7,000 islands, bro.
Hold on, 7,000. Let me see this. 1, 2, 3. Japan did not discover 7,000 new islands. What the fuck are you talking about? There's literally no proof of this. Where did this happen?
Oh, he's a skeptic now. Okay, so let me be a skeptic. How do you know we found every piece of dirt on the earth?
1 second. I'm reading into this Japan thing.
He's reading AI. Whatever AI makes up about it.
PNN travel. Yeah, there's multiple reasons to why these islands have not been occupied.
Well, that's probably the only ones that have been. That's probably the only ones that we don't know about, right?
Because of different.
Yeah, I'm sure those are
territorial disputes and shit. But I'm sure someone discovered it at some point in time.
Now he's sure. You hear that?
Oh,
he's sure of it.
1 second.
It's bloviating, dude.
No,
I'm
5
sure
seconds.
somebody went to your edge at some point.
Yeah.
Okay, so
Say, okay, you guys are right.
Okay, so the Earth is flat. I'm sorry.
because they discovered 7,000 new islands.
Yes, because you said everything's been discovered already because we live on a ball. And we said, no, the Earth is flat, and they discovered 7,000 new islands. And you said, bullshit. Then you looked it up. You said, they did discover 7,000 new islands, and
Oh, here you
the
go.
Earth is still a ball for some reason. And that
You
doesn't
want to
make
know
sense
why they
to us.
discovered 7,000 new islands? Because most of them are just small, barren fucking rocks that go underwater half the time. Yeah, there's
Wow,
still
I
some-
can't believe they didn't find those before.
There's still some shit that
So now
pop up
you're
here
giving
and there.
excuses as to why they didn't find them, even though your argument was that we've discovered everything, and now we found out that we haven't discovered everything, and you're giving excuses for that.
See,
How pathetic.
These are little pathetic islands, okay?
Right, little pathetic islands that we didn't discover.
We've discovered all of the major land masses, and I'm
Oh,
pretty
okay, sure, no problem.
a wall
I need your
surrounding
evidence for
the
that,
fucking
please.
Earth or an age would
Can you
be
give
a
me the
pretty
evidence
major
for that,
landmass.
please? Sorry, I don't know why you're still talking. I just need the evidence for that, please.
The evidence for that we've discovered all the major land masses and continents. in
Yeah,
the Earth.
yeah.
Look at a map.
Nope, that
Okay,
doesn't
so
work.
It doesn't
It
work.
doesn't work.
No.
No, look
I'll tell
at
you
the
why.
Pacific
Why doesn't it
Ocean.
work?
Pacific Ocean doesn't have any land in it.
Yeah, because it's an ocean.
Prove it.
Prove that it's an ocean? Are you stupid?
No, I want you to prove that that's been all explored.
Okay, so let me go to the Pacific Ocean and search for some fucking islands and shit like that. What's in the Pacific Ocean? Like, what does it matter? Where's this big, massive fuck off wall surrounding the globe? I'm pretty sure.
There's your wall again, dude. Your wall, dude. Your wall. You brought up your wall again. Your wall.
Exactly.
It's your
I'm
wall,
not
not ours.
I'm not saying
We didn't make up the wall. You did. Why do you want us to talk about your wall?
So what's going on then? I'm just saying, in my reality, on a flat surface, I'm looking at my desk right now. It's pretty flat. There's an edge to it. I'm looking at the floor.
Okay.
The only thing that
How do you know it's flat? How do you know your desk is flat?
Of the floor.
How do you know your desk isn't curvy?
Measure it. It looks flat.
Sure, why not? Measure something, goddamn.
I don't know what the fuck he's talking about. But once I go to the other side of my room, I see a wall.
Okay.
There's a.
So you think the Earth has a wall? Okay, well, where is it?
You're the guy. You're the people that believe this shit. If the Earth is flat,
No, I didn't. Did I say that the Earth has a wall? Did I say that?
If the Earth is flat, if the Earth is flat, if the Earth is flat.
Okay, finally.
No, we just said it was flat. Like, we didn't make any claims after that. We just said it was flat.
Yeah, you're saying it needs to have a wall or an edge.
The earliest historical charts of the ice age
That's
in the Chukchi Sea.
The Ice Age? How long ago was the Ice Age?
Talking about Ice Age. Not talking about that dumb shit.
That was one of you guys that posted that. So.
Sorry, do you think that we say that there's a ring of ice around the world? Is this what you've seen in like media and so on?
No, I know you guys don't believe that shit anymore. So what is surrounding us, or what is stopping us from reaching the edge? Is what I want to know.
A dense
No
hydrogen
idea.
ocean prevents anything from leaving the Earth.
Okay, that's interesting, and also a claim that can't be validated. The more honest answer is we don't know.
No, we could definitely make a scientific conclusion that it is a hydrogen.
Really, based upon what hypothesis and experiment?
Okay, so on the Earth, we can take hydrogen and get it to.
Is this going to be a hypothesis and an experiment?
Right. But the difference is my hypothesis.
Go ahead and talk to the other guy. That guy's retarded.
Cool, fair enough. I thought you were.
Argue with each
Yeah, don't give up on Phil Platt so soon. I just checked him into our home server.
Oh my
gosh, poor Phil Platt.
He's got to take his turn.
So
I'd rather talk to Phil Platt than B Man. I mean, he's been around
for
here
sure.
so long. My
B-Man gave
goodness.
up a long time ago. Yeah, B-Man should just listen now.
I haven't given up. Fuck's now.
Let me explain it before you dismiss it. I mean, what you're doing is literally what pagans do. If you tried to convince them their worldview is ridiculous, they'd wave you off and say their authority and consensus disagrees. So just listen first before you dismiss.
We're not trying to convince anybody.
Right, but I'm not trying to convince anybody either. I'm just trying to state what I believe it could be. And it's being hand-waved immediately before I even finish.
Oh, yeah, because we don't want to hear about belief systems.
I'm not talking about belief systems. I'm talking about something you
about
could
what you
do
believe.
yourself.
You said you were talking about what you believe. You're not saying that that's not a belief system. Hold on. I don't want to get off, my friend. I don't want to get off on the wrong foot with you.
Scientific process, right? You understand that observation, measurement, repeatability is what declares
Obviously,
empirical
doesn't want the
validation.
olive branch. No problem.
Right? You understand that, though. That's the empirical process.
Okay.
The question was.
So get on
just
with the
for
measurements
brevity,
then.
All right. Well, this is what I'm saying, is that if we can observe a pressure gradient, then we have to look at the scientific laws. What does a pressure gradient require? It requires containment. Right. So now when we look at the containment, we can see our pressure gradient has hydrogen at the top. There's no reason to assume that hydrogen doesn't continue past the magnetic field. And we know
What
that
measurement is the hydrogen claim based on?
hydrogen claim, I don't know. I could use hostile witnesses all day. None of your model is claiming that hydrogen isn't at the top of the atmosphere. They agree.
What model?
The
we don't have a
heliocentric
model.
Are you telling me your heliocentric model doesn't believe a density gradient in the atmosphere?
My friend, we talk about gradient. You were talking,
Right, is there a
specifically
density
talking about one particular gas, hydrogen.
Right, and there's a special property about that gas, and it's a special
hold
property
on, before you run
that
off.
is a big
Hold
deal
on,
in its location.
my friend. I don't want to get off on the wrong foot. All right.
I know. I'm trying to explain to you an empirical fact, and you're dismissing it as if it has nothing to do with my final.
Not dismissing it. I'm trying to walk through it slowly. That's why I keep kind of mumbling and trying to interrupt, because you're going quite fast. So slow down.
Well, slow it down then. Do you agree with me that,
back to my
that the
question.
atmosphere has a density gradient, and at the higher an altitude
that's not in question.
But we're talking about the firmament, so it's important what elements exist around the firmament.
Is your foot constantly down on the accelerator, or do you think you can just ease it off a little bit?
I don't understand. You're interrupting me, and I'm just trying to explain something.
I've already told you I'm trying to slow down and go through this step by step. That me trying to interrupt you is trying to slow you down because I want clarification before we move on.
Yeah, I made the claim that it's probably a hydrogen ocean, and then I was trying to explain why I think that, and that's what you keep cutting off.
Someone else can try.
Phil, take a deep breath. We're trying to communicate with you, but you don't have to keep talking over us. Just you say something, and then somebody else will say something back to you.
Right,
It's
but I
that
didn't
simple.
get to say anything.
Okay, go ahead. Go right now, and then stop when you're done.
Okay, what I'm saying is that it would be a hydrogen ocean. We can objectively confirm that we live in a pressure density atmosphere, and that the higher in altitude we go, the lighter the elements are. Hydrogen, under a scientific framework, you can test it in a lab that under extreme cold temperatures, it gets really dense and it liquefies. And the properties of liquid hydrogen is diamagnetism. It is repelled by magnets. And so literally, if outside the magnetic field is a dense hydrogen cold ocean, then it would be at the bottom of an extremely dense ocean, creating a pressure from the magnetic field meeting that diamagnetic hydrogen ocean. That would create a pressure bubble that we exist in.
Okay.
Yeah.
Fuck you.
Right. That is empirical.
Well, it's empirical because that's what hydrogen does. We can do that right here on the surface.
That's great.
No.
Hey,
What we mean by empirical is, hold on. What we mean by empirical is so far, lovely story. I think we're all kind of nodding along, but at the end of the story, we want validation for it, don't we? So
what do you mean by validation? What aren't you agreeing with?
But have you been there to confirm that your hypothesis in this instance, or theory, is probably better, is true?
That's a fallacy. Science is about scalability. Yeah, it's about scalability. The fact that you say I'm not allowed to prove anything because I can't
to add more clarity if you allow me. Thank you. So at the moment, like I said, we're all nodding along, right?
Right.
We still want verification that this is actually the reality in which we live. So far, sounds like
flat earthers just deny everything because their whole point is that they don't have the resources.
I'm really trying my best to communicate with you, sir.
You're telling me I can't say a word because I can't travel to the firmament.
No, at the moment, I'm really trying to make my point.
Yeah, but you understand that theories can exist in science, but the point is that can't contradict empirical laws.
Yes, I agree that theories exist in science if they have undergone hypothesis verification through experiment. You can then base your theory.
I'm just saying, you would agree that the heliocentric model saying gravity prevents entropy, it contradicts the scientific law.
Dude, right, I'm literally trying to hold out an olive branch to you. If you let me say more than fucking 15 words, you'd agree that I'm trying to reach an agreement with you and hopefully add some clarity. Now, so far, you've given, and I'm like, try my best to steelman you and give you a good representation of what you think you're trying to give. So give me a moment. So far, I'll agree. You're giving me what is probably a good scientific hypothesis. You've a good scientific theory based on a few hypotheses that have been demonstrated to be true. Like you require a container for gas pressure, the observable reality that there is a gas pressure gradient. You're hypothesizing a cause for this, something that you could probably do in a laboratory and say this does cause that. But until you observe the reality and go there, you can't verify this theory of yours to be true, right?
Right. I'm not saying that's why it's a theory. If it was more than a theory, I'd be calling it law.
Yeah, so it's a good idea. I don't think anybody would say that it isn't a good idea.
Right, but I'm not saying it's law. I'm saying it's a theory. You can have theories as long as they don't contradict law.
Yeah, I understand that. I'm just glad we had this conversation so we could add clarity to what's being said. There's no need for us to think that each other's being hostile. We have agreements here, but we also have limitations. This place that you are in at the moment tries to deal with what's empirical. When we get to theories that can't be tested, we must admit that this isn't empirical and underlie it as a good speculation or theory to a probability, an idea.
Right, but a hypothesis is just that. You take your theories and test them against empirical law. If I can
No, you need to get this order. Sorry, sir. Sorry, you need to get this order right. Scientific theories are based on an accumulation of scientific hypotheses that have been demonstrated to be true with verification through experiment. You've basically got to complete the scientific method, have an experiment, and then you can base your theory upon what you've proven to be true, which is what you've done. You've conglomerated a few scientific hypotheses and are basing your theory upon that. Now, at the moment, we must agree that it is just a theory, something you can't actually demonstrate to be true until you go there.
But I could demonstrate the science behind it. That is my point.
Yeah, this is why I said we were all nodding along. Yes, we observe a gas pressure gradient. We were agreeing with you, right? Now, the cause in your supposition, the cause in your supposition, we would also nodding along to, right? Hydrogen in this state, it acts like this. It could be the limitation to our gas pressure and maybe our whole environment. Okay. Right. It's a nice idea, like I said, but we can't go there to verify this theory.
Well, because what I'm understanding is, I heard the question where somebody asked what could, be the firmament or whatever, and I'm trying to give a theory that replaces the debunked theory that gas prevents entropy.
I get you, okay? Maybe, and I'm not being hostile. The question was more specific about the ice wall, the Antarctic ice wall, as in when you go out horizontally. But I will concede eventually you would meet where the sky reaches the earth. So if this is what you were speaking about, yeah, okay. But again, we must caveat it with this is a speculation. And dealing in conversations in this channel where we try to deal with empirical truths, things that we can validate to be true or not, then speculation must be underlined and pointed out.
Oh, sure. I'm not claiming that this is fact. I'm claiming that this is this can replace the defunct theory that gravity prevents entropy. That just objectively can't be true.
Well, we don't need other speculations to replace the already existing speculation of gravity holding gas to the Earth.
But that is the exact scientific process. You create those speculations and they hold if they don't contradict. And there's just
no, that's not the scientific process. That's completely false.
I want to ask Phil this. I want to ask Phil a question. Phil, do you think your hypothesis could happen over a flat surface as well?
Yes.
Well,
yes.
then.
In fact, I look at the Earth as a microcosm, macrocosm. I think it's a direct macrocosm of the hydrogen atom itself. And hydrogen atoms bond to each other, and they would create an inertial plane in between them.
Phil, you don't have any hypotheses.
Well, I'm just saying, you asked me if I believed it could happen over a flat Earth. I told you what I believed.
No, that was a different question. I'm talking about your whole hydrogen ocean.
Yeah.
You don't even have a hypothesis yet. It's not scientific at all.
Well, what do you mean? I can take in a lab and I can take hydrogen, liquefy it, and I can create a magnetic field and watch it repel.
Nobody cares. It's not science. It's not science.
It's literally science.
No, it literally isn't, because if you're going to use the scientific method in natural science in this situation, you would have to have a naturally observed phenomena. Can you give me the naturally observed phenomena?
Yeah, the magnetic field of Earth. And
okay, so
that exists at the top of the density gradient.
No. We're dealing with your original observation. You observe, apparently, in nature, a magnetic field. So what?
So science is
what
about
about it?
Science is about recreating conditions.
That's false.
Right.
That's
to
false.
be
It's
specific,
not about recreating conditions and then
so
manipulating
to
the
be
variables.
specific, when we ask you what you see and you say the magnetic field of the Earth, the next question, because we've got the observed phenomena when creating a hypothesis, is very simply what caused that.
What
so
caused the
do you think
magnetic field?
Yeah.
The Earth. What do you mean? Like, are you saying the Earth doesn't have a magnetic field? Or are we not?
No. Listen, we're agreeing with you that you see this electromagnetic, right? Compasses follow these lines, for example, right? If you're saying that this is the phenomena that you observe, the method's very strict. If this is your independent variable, your dependent variable, then the independent variable, the cause question must be answered, right? So what caused that? What you observed?
You're asking me what causes the Earth to be magnetic?
Yeah, because that's what you gave as your phenomena. Like I said, maybe you should, hold on, my friend. That's why I asked you. Maybe you want to give a different phenomena, because that one's not going to fit into your hypothesis, dude. Not the one that you're trying to give.
Are you saying that magnetic fields are like personal, like they're different? Like if I create one magnetic field and another one, that they're somehow different?
All right, okay, right. And I'm English, and I know my English is British to you, but I know that everybody else understands what I'm saying. I'm trying to understand why you don't.
It's it's about science and doing experiments with scalability.
Okay. First step of the scientific method is the naturally observed phenomena. When questioned about that, you gave the magnetic field of the Earth. The next step is to answer the question, what caused that? Now, you said science. That would be the construction of a hypothesis that we're going to test for experiment. I think so. This isn't a thing that you're trying to talk about.
Well, let's put it this way. Isaac Newton came up with the equations to describe the laws of gravity. He literally said that he can't tell you what causes it, but he can tell you the laws it must abide by. So are you saying he didn't follow any scientific process?
Yes, that's exactly what we're saying.
So the guy that's responsible for every piece of infrastructure that ever existed on Earth didn't even follow the scientific process to come up with that equation.
What equation?
Scientific process to come up with an equation. The only way that you can come up, hold on. The only way that you can come up with an equation, which is the use of language, which is math, to express what has happened within the scientific experiment.
Isaac Newton came up with.
So we need the experiment then.
Gravity must follow. He said he doesn't know.
So what was the experiment then?
What was his experiment?
Yeah, what was the experiment the formulae or equation were gained from?
Observation, measurement, and repeatability. He took physical objects.
So what's the hypothesis?
With their gravitational.
So what's the hypothesis? So what is the hypothesis that Newton gave?
He gave his mass equal, or I'll look it up so I don't get it wrong. But he definitely gave you a hypothesis.
Okay, when you said you were going to give me an equation, a hypothesis doesn't come in the form of an equation.
Use him as an example. I'm not here to argue that, but I can look it up and argue Newton. I'm just saying that he literally says he doesn't know the cause, but he can tell you the laws that it must obey.
Dude, you're rattling around like one of them balls when they draw the lottery. You got to stick to one thing.
I'm telling you. But you're telling me that I must tell you the cause before I tell you the laws. And I'm pointing out that one of the most prominent scientists ever literally did not do that.
No, you're claiming hydrogen, water in the sky, right?
I'm claiming hydrogen is in the sky, and I'm saying that hydrogen at extremely cold temperatures will be dense and it will liquefy. And we can produce that right here on Earth, and we know its properties.
Cool. So act as a container for the gas pressure, right?
Right.
Cool. So that's not the magnetic field doing that now, is it?
No, it's the magnetic field meeting the hydrogen ocean.
Oh, okay. So you now need to observe this phenomena.
Right. Like you can create that in a lab.
No. The phenomena in the natural world.
See, you're pretending like I have to.
I'm pointing out.
The Earth has a magnetic field. It's objective.
Yes.
I don't have to tell you what causes it to say that it has
Phil,
a magnetic
I'm gonna steelman you real quick. I'm gonna steelman you, Phil. What you're saying is the magnetic field is encapsulating liquid hydrogen around the outer edge of the atmosphere.
Yeah, a good way to put it is like, I know this is a silly way. Think of like SpongeBob with Sandy under the ocean with her dome. She's inside an ocean. Picture that ocean as a hydrogen ocean, and that the dome is a black dome, but a magnetic field repelling it.
You have no evidence for it other than just a hypothesis and what you think might be going on in your mind.
Right, that's what I'm trying to give you, a hypothesis, and I can test the hypothesis.
It's not a hypothesis.
I didn't verify it.
It's not a hypothesis.
That is exactly how science works. You create a hypothesis.
No, it isn't. You can't just make it up as you go. You're making up stuff as you go along.
No,
Give me the naturally observed phenomena and then independent and dependent variables. We're not going to do this anymore. Give me the naturally observed phenomena and then give me your hypothesis.
Magnetic
we'll see if it's any good.
And hydrogen at the top of the gradient. Those are
okay. So that totally incoherent. Your magnetic field is apparently your observation in nature. You see natural magnetism, and now you're going to claim that the cause of that is what?
Why would I have to explain the cause for it to be real?
Oh my God!
I'm not asking you whether or not it's real. That's not what science adjudicates. It adjudicates cause and effect relationships. So the effect that you're observing is the magnetism. Exactly. You're observing a magnetic field. What causes it?
I'm not talking about the magnetic field. I'm talking about that is affected by an existing magnetic field.
Nothing else is being affected by it right now. You would have to show me liquid hydrogen being affected by an electromagnetic field or a magnetic field in this scenario.
Yeah, that can be produced on a smaller scale. Why wouldn't you be able to scale it?
Yeah, you can do this on a small scale on your countertop. That's fantastic. We're talking about the grand scale of the Earth, and you don't observe this to be happening. The only thing that you can point to as a naturally occurring phenomena is the gas pressure.
And the magnetic field that the Earth has.
Spot on.
And you cannot connect the two.
I don't have to tell you the cause of something that exists if I'm not trying to explain to you what causes it.
Hold on, my friend. You were giving us a claim to the edge of the Earth, right? And I use the term loosely, as in what contains us.
Right.
That would be the cause of the gas pressure, wouldn't it?
The cause of the gas pressure, yes. And that is...
Yeah, you're saying... So I know we'll follow. You're saying that the electromagnetic field of the Earth meets hydrogen at a high level and creates this container. Yes?
Yeah. Yes.
Okay. Lovely hypothesis, but every single time we ask you for the phenomena, you don't observe it. We've gotten past it's not the electromagnetic field. The phenomena needs to be the electromagnetic field meeting the hydrogen that you claim.
Right.
Because that would be the cause of the gas pressure.
Creates the containment. I'm saying that hydrogen ocean creates the containment. It's being repelled by a magnetic field.
Yeah. So you would need to observe this as the cause for the phenomena of gas pressure.
So you're saying, though, even though I can reproduce it on a smaller scale, that I'm not allowed to scale that up like normal science works, but I'm just supposed to just say it's not a case unless I can travel there?
No. We will reach the conclusion that the gas that's under pressure requires a container. We can't reach a conclusion as to what that container is.
But we can create hypotheses, and that's what I've done.
No, we can make theories. Best guess.
Let's get sure. Why
Yeah.
can't I have that?
You can have your best guess, but it's not proof.
Right. I didn't.
Here's the thing, Phil. Here's the thing. Here's the thing. You create a small scaled down version of that on your countertop. How do you go about proving that up in the sky?
Scalability.
No. You still have to go up to the sky and verify that that's still the thing that you think it is.
Yeah, you need to make 14.7 psi at gas pressure when you do this. Also, don't forget about that.
How can heliocentrists make that claim when Albert Einstein made his assumptions like in 1905 when they didn't even claim to send a probe up until
he used to stick his tongue out. So don't go by his word.
Right, that's what I'm saying. It's like the heliocentrists, they have this idea like they're allowed to make all these hypotheses and theories and nobody's allowed to
No, they're not.
them.
We already threw them all out.
Oh, then what are we? Oh, we're talking. Well, I'm just creating a theory and a hypothesis. If these are flat earthers, I'm just giving you ideas.
You're not.
Yeah. So sorry, right?
It's definitely scalable.
Yeah. My friend.
Claim that gravity can prevent entropy. Like you can produce an experiment right here on Earth that proves that's not possible.
No, you can't.
Yeah, we know.
No, if you create the conditions at the edge of the atmosphere that heliocentrism claims, you can recreate that in a chamber. And then you can put a chamber right on top of that with a vacuum that's not even nearly as strong as the claimed vacuum of space.
No, you can't.
See, now that's just ridiculous. You're just denying the scientific process.
Okay, so let's try this again. Hey, Phil, can you show me that someone has taken a big giant vat of liquid hydrogen and then they've taken some kind of magnetic field and created some kind of magnetic force field to hold back the hydrogen ocean on a small scale? Can you show me that?
I mean, it's producible. There's lots of citations that talk about it.
Just get me the study that they did this, please.
Okay. Give me a minute. I'll look it up right now. I mean, this is how I came up with my hypothesis, was looking at this stuff.
Right. So you saw a liquid hydrogen ocean with a hemispherical bubble inside of it created by a magnetic field. Did you?
In a lab, you can produce it. Yeah. You can take hydrogen.
I want you to show it to me. I want you to show me this exact thing.
So let me get this straight. Are you a flat earther or are you a globe one arguing?
Who cares? I could be an anybody. I could be a flat earther. I could be a glober. And this would still be a great question.
You either not understand the scientific process of scalability or you don't understand what's behind.
I'm not worried about scalability. I'm talking about cause and effect relationships, which is what science is all about.
Listen, dude, you didn't observe an ocean of hydrogen that you're going to scale up to. So
like a cup of water.
You're already done. You lost me at ocean of hydrogen.
A cup of water is just a cup of water. If you scale that up, you can scale it up to an ocean. It's
great.
Are you denying the scalability?
Don't try to run away from this point. I want you to show me a small liquid hydrogen ocean having a force field of magnetism inside of it, creating a bubble. Let's see that.
So you're denying that liquid hydrogen is diamagnetic.
I haven't seen anything to deny that.
At all. Didn't deny that at all. You're taking words and twisting them around and making it seem like I'm denying something. Okay, I'm asking you to reproduce the thing you are claiming is happening.
Trying to steel man here. If you're saying that, I know what you're asking me to do, but I'm trying to understand why you need to see something.
You're not going to be able to figure me out. I'm asking you a specific question about your claim. I've made no claims. I want to see your claim in action. Show it to me.
Well, that's the beauty about my claim is me showing it to you is irrelevant. You can produce it yourself.
Okay, great. How would I go about doing that? Because no one's done this so far, so I'm going to be the pioneer, I guess. You know what? Maybe you should do this.
Liquid hydrogen was diamagnetic.
I didn't ask you anything about the properties of the liquid hydrogen. I asked you to reproduce the thing that you are claiming is happening.
Yeah, you can reproduce it.
Okay, show it to me then. If it's so easy, why don't you just go ahead and show it to me? Don't try to run away from this, Phil. You're not going to be able to filibuster. Show me the thing that you're talking about. I don't want to hear any more words out of you. I want to see the thing that you're talking about.
You're either denying.
Are you still not even steel manning me? You don't even understand what steel man means. You need to get me the evidence for the thing that I asked for.
So if magnets repel liquid hydrogen, how can you not scale that? How can you not make a stronger magnet?
Friend, I just need you to go ahead and show me what it is that you're talking about, since it's so easy.
You're just avoiding.
No, it's totally relevant. Oh, I'm sorry. Let's go ahead and talk about your claim again. Let's see how relevant it is. Were you claiming that there is a hydrogen ocean? This is your quote unquote hypothesis or theory, that there is an ocean of hydrogen being held back by a magnetic field of the Earth, creating a bubble that we can live in, like the squirrel and freaking SpongeBob SquarePants. Isn't that your claim?
Yeah, I tried to explain it with an analogy that was as simple as
What I need you to do is, on a small scale, get that demonstration for me.
Yeah, you can just look up any citation about liquid hydrogen. And
no, I'm sorry. This is you providing it for me, since it's your claim. You make the claim, you provide the evidence.
You can independently verify it yourself. I'm not a monkey or an authority. These are things
hold
you
on.
can independently.
This is your claim.
2 seconds. 2 seconds. All right, my friend, you new to the channel. All right. Now we welcome you, but we have standards here. One of those standards is if a person makes a claim, they provide the evidence, especially from the flat earth side, right? We don't turn around to people and say to them, go and Google it. You should research yourself. If we make a claim, we're going to provide citation and demonstration. Now, so we all move forward in a good manner. Just remember that, right? If you're going to make a claim, someone, whether it's a flat earther or a globe earther, would probably ask you to provide evidence for it.
Can I ask a quick question? What's the order of the word? Give me the terminology of what I'm supposed to look up. I just looked up liquid hydrogen diamagnetic, and I'm not finding a damn thing. Like, I'm finding videos on diamagnetic demonstration, but it's not creating or producing a bubble or anything like that.
It seems to create a streaming amount of bubbles.
It's got to create a bubble with 14.7 psi inside of it, and then you guys got to measure that too.
This is also a problem when someone says you should go and research it, because people are going to find not what you're talking about, and then you're going to have to wade through the minefield of not what you're talking about. It's easier if you just provide what you're talking about.
I'll provide you something here in a second. Give me a minute. Somebody just knocked on my door, but I'll get it in a second.
No problem. If people need time. 5-10 minutes. That's cool.
Open up, FBI.
I knew it. They busted him for knowing that the sky is liquid hydrogen.
Yeah, he let the secret out. We probably all are in danger now.
I mean, when I look up the liquid hydrogen diamagnetic, like, hydrogen is laying flat and level in the petri dish that they're using to test, or the bowl, or whatever. So I'm confused.
How come the bubble just stays there?
What bubble? I don't even see a bubble. Are you talking about when they produce a frequency and then, like, they got the little drop to hover?
No.
I'm confused. Which bubble? I'm not seeing a bubble.
He says you can use frequency or magnetism to create a bubble in liquid hydrogen. Where's the bubble go?
I want to. That's what I'm trying to look up. Like, give me the exact phrase that I need to look up in order to get this.
You gotta look
Well,
up. Just Google. Let's make shit up. That'll.
Well, remember, wink, wink. Somebody
Kimbo
came to the
coming in
door,
hot.
so he's probably looking it up right now. He's having ChatGPT put it together for him.
Is there a problem with asking GPT to provide any citation something I'm looking
As
for?
long, sorry, you can ask ChatGPT anything as long as you actually provide that reference and citation, not just what AI says. So you can use it to find stuff, but that stuff better be the reference material where the citation comes from.
I mean, there is a fun little test that he could actually perform. I know it takes a lot of energy to essentially turn hydrogen into a liquid. So if he could just go ahead and get like a small glass of it, right? Just a glass of liquid hydrogen, and then take a magnet that is 0.5 Gauss, right? So that's the strength of the magnet. It's the same as the Earth's.
You're saying, this is your position, is I got to get farther away to get a better look. And I'm going to look at the whole herd. And once I can see the fucking whole herd, I'll be able to pick out that sheep. That isn't a
The point
sheep.
is, if you look at the whole thing, they all look like sheep.
Dude, the subjective argument was yours. You're the one who said fly to space, look at the Earth. I said measure it.
What am I measuring, Indio? 12 feet?
Whether the surface of the Earth is curving. Is it curving? Is it not curving? If curving, ball. If not curving, not ball.
How much of the Earth do I need to measure to make that extrapolation?
Oh, not much.
All right.
Probably a couple, I would say 10 long distance observations. Consistent over a period of time.
And you translate that into miles, or
it's not a distance because we know what the water does.
Okay.
Have you ever experienced water, a connected body of water, to do something in one place and not in the other at the surface? To any significant degree?
No.
Yeah, so why would we think that somehow the Earth, I measure the water flat here and then go somewhere else, and that's where it's curving?
What do you mean by measure the water flat? What does that mean?
The surface of the water has to curve. So from a level line, horizontally extending out into space, the surface of the Earth should curve away from it, such as eye level. Should curve down and away from eye level.
Mm-hmm.
Okay, so that means at each increment of distance, there's a separation between that level line and the surface of the Earth. Well, let's call it a horizontal line and the surface of the Earth, because you'll try to conflate fucking level with curved. So let's just say from the horizontal level line, okay, and the surface, it should increase in distance. The further you go, the larger the distance, and it should increase exponentially. If that's not happening, then the Earth's not a ball. It's really simple, bro. It's not even complicated.
Okay. I can see how you...
Can you have a ball with a flat surface?
If it's big enough, yeah.
Really?
Sure.
Okay. Well, let me tell you how that's not the case. The definition of a sphere is equidistant from the center. A flat surface can't be equidistant from a single point along its length. Okay? So, I don't know if you need to go back to like geometry class, but a straight line and a curved line can't possibly be the same. Because of the properties. Well, because of the properties of a sphere are equidistant from the center, which is a point. And a line can't be equidistant from a point along its length.
A straight line and a curved line are two different things. I agree. But you said flat surface. That's different.
Yeah, that means a straight line, dude.
Okay, when you say straight line, my definition is
okay, let's switch it to a plane, okay? A 2D fucking plane from a point can't be equidistant from that point. But the surface of a sphere can be equidistant from that point. It must be.
Would you agree there's a difference between a straight line and a line?
Yes.
Okay. I agree with that too. Those aren't the same thing.
Okay. You're trying to just deflect from the point. Okay, and the point is that the surface of the Earth is not curving, measured to be not curving.
And you have a line that's not 180 degrees.
What does that mean? We're talking about a straight line. No, enough with the red herrings, dude.
Just ask.
We're only talking about the surface of the Earth, dude. Is it curving or is it not?
Well, I think it is because I think it's a sphere, but.
And why is that?
I don't. How much time do you have?
No, I'm asking why you think it's a sphere.
That's what I just asked you. How much time do you have?
Yeah, I got plenty of time.
Okay. Well, let's start with everything that we can all see. Let's start with satellite images and go from there.
So, looking at his screen.
Yeah.
What about the world? What about nature?
I don't have any reason to think that they're not real. So.
You don't have any reason to think they are real.
Okay. Well, I guess you could say that about anything, right?
No. So there's two types of claims. There's regular claims and there's fantastic claims. Claiming you have machines zipping around in a fucking vacuum at 17,000 miles per hour is a fantastic claim.
Okay. I can appreciate that.
And there's no reason I should believe them. Can you give me a reason to believe that there's pictures of Earth from space?
No, I can't. I can't convince you in any way.
No, I'm at a reason. What was the reason you believed them? How did you evaluate them is what I'm asking you. Like, you were presented these pictures, someone said, hey, these are pictures from space. What was your evaluation process on that claim?
Well, I didn't vet these images.
What was your evaluation process on that claim?
I just told you I didn't vet these images.
You didn't even for 1 second you didn't do anything.
No, I trusted. I didn't vet it in any way.
I trusted. So you don't actually know the Earth's a globe. You just trust somebody else's claim that it is.
Yeah, if I knew everything, I wouldn't need to do anything. I would just, at some point you have to trust somebody.
What? What do you mean know everything? What's that got to do with anything?
No one is omniscient, so at some point you have to trust someone.
No, you don't. Says who?
Yeah,
where's that
that's
written
ridiculous.
down?
Oh, you don't?
You have to trust.
Do you know who your father is?
Well, I know what my mother says. I know what's written on the birth certificate. No, I don't know.
Right, so you don't know. You just know.
No, I don't.
You, right? Okay. Right, exactly.
I don't know what you're thinking. No, I don't know. And who said I trusted what they told me?
Oh, you don't trust what your mom told you?
Not necessarily. You don't know my mother.
Okay, fair enough.
You also don't know your own. You don't even know how old you are. No one in this chat does. Nobody knows how old they are. Nobody.
You're asking if we trust the same people who told us about Santa, the Easter Bunny. Come on.
But even so, trust is not required. You choose to trust or not trust. That's a choice. It's not required. Okay, you're not required to trust.
Right.
You're not required to trust their claims, dude.
Indio, you asked me a question. I gave you an honest answer. Now you want to fault me on it?
No. What I said. Listen. You said you must trust somebody. That's not true. You don't have to trust anybody.
Fair enough. You don't have to.
Okay, you choose to. So you don't. The point is, you don't know the Earth is a globe. Okay, I just wanted to get you to say the truth. You believe it because you choose to believe it because you choose to trust in complete fucking strangers and their claims, even though you never evaluated the veracity of the claims by your own admission.
India,
you are a religious zealot.
Nobody knows everything, so at some point
That has nothing to do with this. Whether you know something or not has nothing to do with this.
It doesn't.
We're talking about this very specific thing. Don't try to fucking muddy the water where I'm demanding that you know everything. I'm saying this very specific thing. You don't know the Earth is a globe, and the basis that you've admitted that you believe it is because of the claims of other people that you never even evaluated.
I didn't say I knew what the shape of the Earth was.
Yeah, what a scumbag.
I mean, you're arguing against a straw man.
I asked you, and I never said. No, you just straw manned what I said. I never said you knew the shape of the Earth. I asked you why you believed it.
And I told you. So what's the problem?
Yeah. So where's the straw man?
It's like you're fighting against a shadow.
Where's the straw man?
I answered your question.
Where's the straw man? Where was my straw man?
He critiqued it.
No, it just sounds like you're shadow boxing, you know.
Yeah. Now you're going to talk about me. Gimmick again.
I'm not gimmicking. You asked me a question, and I gave you an intellectually honest answer. So
yeah, you gave me an honest answer, and I gave you an honest rendition of the whole thing, compactified. Because you're trying to use smoke and mirrors to hide what the situation is. The situation is, some people said something, you chose to believe their words, and you never evaluated it.
All right, shoot me. I mean, what do you want me to do? I don't know everything. I have to believe somebody at some point.
No, you don't.
There he goes again.
Okay, what do you
Dude, it's like, do you use these gimmicks like in the other VCs or something?
I'm not trying to gimmick anything. I'm not playing any games.
They're rhetorical gimmicks, dude. Did you forget I've talked to you before and you did these same things then and the time before that? It's like they're little catchphrases, right? They're little gimmicks.
What do you want me to say to you?
It's not what I want you to say. Okay? This is really simple. You have a belief, you never evaluated whether the belief is true or not. I'm telling you how you can do it, but you don't care because you'd rather just believe the claims of strangers. You can test their claims, you know, right?
All right.
Did you know that you could go out into the natural world and test their claims?
I don't know. Yeah, maybe part of it. Yeah, I don't know if I can test all of it.
What do you mean part of it?
You said test their claims.
Yeah, test their claims that the Earth is a ball.
I can't test satellite images. I don't have the equipment or the money or the resources to do that.
Yeah, you can. Because if what the image depicts doesn't exist in reality, then the image is fake.
Okay.
So someone showed you a picture of a frickin' pink house in the middle of Times Square, and then you go to Times Square and there's no pink house there, you know the image is fake. You don't have to prove how they faked it. There's no fucking house there. So what they depicted in the picture doesn't exist. In reality, the image has to be fake, right?
That makes sense.
Yeah, so the images that they take the picture of show what we've been talking about, curving water. And you can go check in reality whether the water's actually curving. Because the things in that images, like the Atlantic Ocean, the Pacific Ocean, you can go there. Just like I have, I can go down to the Atlantic Ocean, the thing that's in their fucking pictures, and see if the water's curving. But it's not.
Okay.
So you have a picture that doesn't exist. It's not an accurate rendition of nature.
What do you think?
And how do I know? Because I went into nature and tested and looked in nature to see, hey, dude, does that thing exist actually in nature? Is my Atlantic Ocean out there actually curving?
All right. So if what you're saying is true, what do you think we should do going forward?
God, here we go, the call to arms. I think you should go down to like you should find the largest, flattest body of water and hold up a sign that says, "This water doesn't curve," and chant slogans, dude. Like, what the fuck, bro? What do you mean, dude? Like, what are you talking about?
I'm just saying. What do you think we should do with this information? In your view,
tell people it.
Okay.
A lot of people are misinformed. There's a lot of myths that have been spread through humanity, and this is one of them. This is just a modern day atheist religion. It's a religion without a deity. All the things that people practice in religion, the globe does, but it's minus the deity. It's got a creation story, has a creation of man story. The fundamental claims can't be tested by anybody but the priesthood. You have to just trust what they say. Same way that people read the Bible, only the clergy could read the Bible, and the fucking laymen couldn't read it in the past. It's the same thing. It's esoteric. You have to decipher esoteric symbols on a fucking blackboard, and that actually proves the exact opposite of what you experience in reality. If you understand the symbols, then you understand the true reality. That's like fucking magic, bro. If you look at it for the way it really is, all the things that they say that were left behind by the Enlightenment, they just co-opted with a different type of bullshit.
Fascinating. You sound like someone whose heart is in the right place. You really do.
Well, that being what it may, the fact remains is they have a creation story, Big Bang. They have an origin of man story, right? Frickin' evolutionary fucking black goo. Right? Same with religion. You look at any religion, they have a creation story. And the Lord said, let there be light. They have a creation of man story. God created Adam from the dust. Right? So it's all the same things. Oh, what does God say? Oh, we don't know. You fucking got to ask the priest. Only they're the ones communing with God, the prophets and all those people. Right? You can't know. The priests know. Oh, what's the evidence for space? Oh, how can I know the Earth's a globe? Oh, you can't know. Only the astronauts can know. See, all these things are analogous. The fundamentals of all this shit are almost identical.
It's fascinating, isn't it? I'm going to ask you.
Yeah, there's nothing new under the sun.
I want to ask you one more thing before I go on mute because I don't want to take up too much of the mic time. If you were wrong about something, would you want to know it?
Oh, yeah. Why not?
Okay. Fair enough. That's good. I'm glad you said that.
I ain't wrong about this.
Yeah. No, I didn't say you were. But you answered my question. So we have a good one, okay?
Ah, you too.
All right.
Keep the faith, brother.
Thank you.
I would agree. I haven't really seen any evidence. Lots of stories, but when you dig into the story isn't really the evidence. Like the king hasn't got any clothes. It's crazy.
You know what? I will give you guys one thing. I do think you guys have actually made me slightly smarter.
I will take that as a compliment. Thank you.
Yeah,
Yes.
thank you. Stick around a few weeks. We get into this and more topics.
So, would you agree that history about genocides, or just history is probably all wrong too? Like, history is probably pretty wrong or pretty incorrect too, right?
So what do you mean by history? Do you mean like what you did yesterday? What your dad did before you were born? What your grandparents do? What do you mean by history?
Yeah, like for example, Nazis. They probably got exaggerated about, right? Or
okay. Yeah.
Great
so,
example.
Not that bad.
I help, right? Your reasonable cognitive function could probably understand that if we're talking about, then all of the facts that we're told about the world probably aren't 100% true, because propaganda exists. right? And we see this all of the time. So if you're asking about if we can trust what they tell us about war, probably not. Does it mean that things didn't take place in the way that they could? Maybe, not exactly. Again, this is historical. In the past, I wasn't there. I'm trusting the resources and the historians and reports of the time and so on, understanding from the vantage point of now with social media that most definitely wars and so on, like you said, are most definitely used as a propaganda tool. So, yeah, probably in that regard. Obviously, history is, in that sense, can't be true.
Yeah, we can prove without a doubt that the entire papacy, primal papacy of Rome, was founded on a series of forged documents. So, yeah, we know that there's a lot of monkey business going on with forged history. Don't want to get into the discussion that you wanted to bring up, though, my friend. We are broadcasting live worldwide on YouTube and Rumble
and TikTok
and Twitter.
Yeah.
Wow.
Oh, thank you for calling on Twitter.
X, whatever it's called.
No, Twitter. X is dead to me.
I mean, there was a high priest in the Old Testament, so the Pope is like the high priest, you know?
Yeah, so Rome was one of 5 bishops that was excommunicated from the rest of the 4 during the schism of 1054 AD. And I'm going to say you probably don't want to get into this with me, especially here, since we talk about flat Earth.
I don't know, brother. A simple reading of the Bible would tell you that the high priest is Jesus. And he supplanted the Mosaic law, and because he wasn't from a tribe that was eligible to be a priest. So it clearly says he is the priest. It also says that a change in the priesthood requires a change in the law. Jesus is the high priest. He's the only high priest.
Even better.
So
Thank you,
Pope
AI.
is the high priest.
100%. Yep, the Eastern Orthodox world agrees with you.
I know.
And that doesn't even matter if the Bible's true or false. It's just that's just what it says in there. I mean, you just read it. It says it right in there.
Does it actually just say Jesus is the high priest, or is it inferred?
A bishop is a type of higher priest, and then a pope is supposed to be like even higher, it seems. So.
Well, you can make up. You can make up whatever. Yeah, you can make up whatever club you want, dude. But if you're going to use the Bible as your source document to do it, then you have to be accurate to what the Bible says. And the Bible says that Jesus is the high priest, and there's no other priesthood. So there are no other priests, dude. It's that simple. And in the sense of being a high priest, and then it says every believer is now a priest, serves the role of the priest, and Jesus is the role of the high priest. So. Yeah, it says it
the high priest is the only one who has direct contact with God on your behalf, which is taught by the Jewish rituals around the temple. Purification, making yourself or the high priest pure, so they could go and see God's face, where everybody else couldn't, because they weren't pure enough, they weren't the high priest. Jesus was obviously the high priest representation that they performed, and is obviously the intercediary between us and God, but also reminding us with what AI just said, the removal of those curtains when Jesus died, the rip down the veil, pointing up that now there is no veil. Jesus has pointed that you can have direct communication with God. But anyway,
a lot of people don't know, but there's actually 4 signs that stopped in 30 AD. Obviously, the curtain. And then, so the curtain the curtain opened itself. The high priest of the Levites didn't have to do it anymore. The candle on the left of the menorah went out. Previous to that, it never went out. The crimson cloth that was put on the scapegoat versus the sacrificial goat, that part of it was kept inside the sanctuary. It would turn white. There was one more I can't remember, but all of these were to signify that God accepted the sacrifice that they were doing. After 30 AD, none of those signs happened. That means God no longer accepted their sacrifices. Why?
Jesus.
Because their priesthood was obsolete. Correct. Sacrifice was already made.
There was no point carrying on the sacrifices because he carried on, nullified the
Was
sacrifices.
destroyed in 70.
Now, those 4 signs are actually written in the Talmud. So the Jewish people themselves told on themselves that God's no longer accepting our sacrifices. All the way up until the temple destruction.
And the Holy Family escaped the temple destruction based off a sign and prophecy from God.
Okay. Anyway, I'm sure we
And
deviated
then
off.
James, the brother of Christ, came back and started the James liturgy, which is celebrated today in Eastern Orthodox churches.
They escaped the temple destruction when they went
Yeah,
to
they fled
Egypt?
to Decapolis. Yeah, not to Egypt.
Is Decapolis, is that, from what I remember, there was the temple where the altar was like another smaller temple where an altar, that in Decapolis. Because I know that the Jewish, I have to say that now, I think I knew that the sacrifices stopped in Jerusalem and the temple fell, but they didn't actually stop until a few years later because there was another temple.
Sanhedrin had a lot going on.
Okay.
Anyway, Earth is flat. Christ is king. Well, Christ got the kingship from his father's side and from being God. But he got the high priest lineage from his mother's side. She was from the Maccabean lineage.
So I think the question was, is history a lie? I mean, yes and no. It depends how deep you wanted that question to be, right? Why I asked at the beginning of the question, with regards to history, what you did yesterday, as in your own personal experience, or say a secondary story about maybe what your parents did before you were born, or maybe like stories that your grandparents told them about their parents, and this kind of passing down of tradition and stories and history. Basically, are these histories true? Oh, yeah, for all intents and purposes, these things happened in your lineage. Are we talking about some kind of international history? We're talking about events that have happened. That this type of history is what I was trying to point out. The difference between what we can experience, and the further we go back in time, then obviously there's an awful lot of amount of trust that's involved. So it's hard to verify either way.
79%.
It's interesting what you brought up at the beginning, Yoda, when you said it was foundation was documents. That's interesting.
Yeah.
I think that's one thing that we forget about, is that those that are in control have control of the administration. That means all of the paperwork and stuff, they've got control to that. So when you talk about forged documents, I haven't even put it beyond the realms of possibility that the majority of documents, if people have got them under lock and key, can be whatever they want them to be, I guess.
Dude, how could they forge documents before?
Go ahead.
Yeah, but how could they forge documents before Adobe Illustrator and WordPress?
That's funny. Yeah, as long as they convince the public of their legitimacy, then their documents follow very easily.
Hey, can you read? No. Yeah, this document says I'm in charge of you.
That's it. Meanwhile, the Eastern Church was translating Bibles into local languages since, like the 100s. Fun fact, did you know that the House of David line still exists today in the country of Georgia?
Oh, okay.
Yeah, and they're Christian.
Okay, St George's Cross. I know the flag. It's got 5 St George's crosses on it, red on a white background.
And one of the first widely translated Bibles was in Georgia in the 300s.
Okay.
There is a ton of gravy, truth gravy in the East.
Yeah. Just quickly, I know how very easily we can get bogged down and into the weeds about certain interesting subjects, but I'm interested in your view alongside some other views that I've seen around recently. I think it would be good to get a few people in a conversation. I know DJ's looking at some things with regards to, let's call it, timelines being distorted, floods, and all that Satan's possible little season, all that type of. So I'd be interested in looking at it from an Eastern kind of point of view, to be honest with you. Especially when
Absolutely, it's a bit different than you find with like Tartaria narratives, but yeah.
Yeah, especially when we're like talking about lineages of people and time frames and passing down stuff, especially within the church.
Yeah, we have the lineages of Christ. We know who Mary's parents were from the Proto-Evangelium of James.
And I think that's fine to accept like that. They're all up and point, right? They're not lineages that exist now. From the way that I'm looking at the Bible, very, very, very little is kind of speaking about things that are happening now.
Okay, yeah.
So it's after that 70 AD kind of thing. Anything after that type of time frame, then it'd be interesting to look at, especially like, as I said, with regards to the church, how it separated, the story we're told about how it separated, the Reformation and all of this stuff.
As someone who went to a Lutheran seminary, I'm kind of upset that Martin Luther didn't have better dialogue with the East.
Yeah. I think the main reason why I wanted to ask you is mainly because of the architecture that the church is said to be responsible for, like, let's say, for the last 2,000 years. Right? So magnificent cathedrals, magnificent buildings all over, especially over the European continent. I think it's interesting. In control, the things that they are said to have built, right?
Let me ask you something. Does the architecture involving gargoyles and mothers squeezing their breast milk in fountains into men's mouths and little boys pissing on people, is any of that, do you think, maybe Western Christianity or Eastern Christianity?
I've always kind of...
Man, that's not little boys, you doofus. That's Pootie.
Yeah.
And for those who don't know, that's little angelic pistlers, all right? Little angelic pistlers.
Yeah, little angel pistlers. In Belgium, the mannequin piss. I've seen it.
I think I'm more talking about how the actual structures even got that magnificence, and the goals and the fountains and how they're ordained and so on, the stained glass windows, for example, but the actual huge structures themselves. If we're talking about, I brought this up the other day, Canterbury Cathedral, said to be over 1,000 years old. It's huge, right? The stones are massive. Right? You know the road I'm going down. So being church, St. Augustine, this guy is said to have done this. Okay. But yeah, with this eye, all of these ancient buildings being around, and the fact that they really get there and may or may not have been submerged, blah, blah, blah. How old are these buildings really? These buildings are predominantly owned by the church or a religious organisation, let's say. So again, it'd just be interesting to look at it again.
All right. So broadly, I think we had easily 1,000 years of millennial rule of Christ. And God was so good, he's given us at least another 1,000. As far as the architecture is concerned, a lot of that came out of the Franks, who moved into Europe and birthed Charlemagne, who was an opportunist, started minting and printing his own coins and currency and all that stuff. And Charlemagne installing his own political appointees as popes, and that kind of really started the whole schism. And Rome happened to break off from the rest of the Christian pentarchy and happened to become the biggest, most wealthiest, and most powerful of all the bishops in their jurisdictions, and even sent crusaders into the east to destroy Constantinople and murder Christians. So yeah, who's the whore of Babylon now?
I just, if we're saying, in this,
Hey, brother, why wouldn't the prostitute shut up?
Why?
Because she was the whore of Babylon.
Dude, I'm going to tell that to my priest during confession. Confession is actually practice for your judgment.
Okay, so within the idea that Jesus has already had his millennial reign, that millennial reign was probably filled with some kind of technology, maybe, that isn't portrayed to us in our commonly understood history. Here we've got some depictions of a load of peasants, pulling carts and stuff, and behind them there's a magnificent cathedral with some amazing piece of architecture. Somehow these peasants made this stuff. It's not necessarily the case, although the story isn't really elaborated on. It's more elaborated on because of the narrative of today. But is it possible that these magnificent structures were built during that time? That time has ended, and now that we see these buildings, we're just given a new narrative. The time frame in which they were built more recently than they were further back, closer towards Jesus's life 2,000 years ago.
I think the church being united for 1,000 years easily, and the schism forming, and then for a period of time afterwards, the Holy Spirit withdraws himself from schismatics. That's what I think. And then from there, you see a decline and degradation.
Okay, so is this? Hopefully, I'm not being stupid. I'm just trying to follow up. So this schism and this decline is obviously after Jesus and his elect had gone, so it was no longer that had stopped. Jesus has gone to the land of Christ or ascended to heaven, whichever way the story goes, and the schism happened after that.
I believe the Holy Spirit is active within the church. The church is a physical body that has been given to us by Christ, instituted by Christ and his disciples and all the apostles. And as long as we're faithful to him, he's going to be present with us. That being said, the schism, I don't think, was the single marking point where the Holy Spirit withdrew in 1054 AD. It was probably a long, drawn-out process. And we had seen the construction of cathedrals from before the year 1000, continuing onward for several hundreds of years. And in the West, things just generally turned to degenerate shit.
Okay, so with this time frame in mind, this is where some people have started talking about, and I've been looking at what's called Satan's little season, right? A time where Satan is loosed and is set to deceive the nations, right? That would still necessarily have to take place then, or has that already happened?
I don't know, but I think there's a good case to be made if it has taken place already. That it's probably taken place between the years like 1500 to 1780 or something.
Yeah. Do you think we're still within it? Or do you think maybe that's past and now we're in something else?
Personally, gosh, Not answering for anybody else. I think we might be crawling out of it.
Okay.
I don't know how long that'll last.
Again, if memory serves, because Satan's little season ends with, I think that's when Armageddon happens, right?
Yeah, that's when it gets real.
Yeah. So Gog and Magog, all the armies of the earth to fight against Jesus and his armies, and Jesus comes and wins, and he's swimming around in all that blood.
I also wouldn't be surprised if this didn't happen for another few hundred years, maybe 1,000. So
Yeah. So it's kind of okay. So this is where I've stepped over the last, let's call it 6 months or so. This is kind of where I'm at. So we've had these types of conversations, but I just wanted to be clear in the thought process. I've come to like similar conclusions, dude, as I'm kind of pointing out. So I've changed I've called it my Christianity. Not certain things, obviously, it's still Christ-centric, but with regards timelines, where I am, because of different people's theologies with regards to, let's say, the end times, eschatology, those types of things. Lots of stuff going about, and I was very vocal about this, especially like within the last 2 years, with regards to the Book of Revelation and Jesus is coming back and so on. I don't think I have that position anymore. So I appreciate the conversation, dude. There's quite a few people that I've been speaking to that have. I'm not saying taking this Satan's little season thing on as this is the truth of the matter, but kind of taking things like mud floods and Tartaria and all of these different types of things and coming to the conclusion that we're obviously living in some deception. It kind of fits more. So yeah, I appreciate what you said, man, for sure. It was deeply personal to you as well, so I know you're not speaking to anybody else.
No, it's all right. I mean, I don't know how much more gas I have left here, but something that came to mind as you were talking was, gosh, was it in like 2 Thessalonians? There's a verse about the restrainer. The implication being that there is a worldly power that Christ has instituted that has the function of restraining the Antichrist. Some of us think that the restraining was removed with the murder of the Romanovs, the Tsars of Russia, in the early 1900s. They're Orthodox Christian family, and they have lineage back to Constantine.
The Jews killed them.
So we might be closer than we think. It might be later than we think.
It's the Jews, right? The Antichrist is Jewish, right? The Antichrist will be Jewish.
Some of the prophecies we understand is that the Antichrist will come from a Jewish tribe, and he will be gay, and from the tribe of Dan.
Sorry, I've got to quickly inquire. Can you hear background noise through my microphone?
No, so if your kids are playing, I don't hear them.
Okay, cool. No, it's just we're going through a storm at the moment, torrential downpour, 80 mile an hour. My place is starting to like rattle and stuff, but that's fine as long as you can't hear it. That's all good.
And when you look into who murdered the Romanovs, the Tsars, you're going to find out. Let's just say it's the usual suspects. You know what I mean?
Okay. So I call this in my own head the first. Because this was, if I think you're talking the same time, the time when about 60 million Christians were kind of, executed. Like wars, loads of Christians were killed. The Revolution.
There were multiple. So yeah, like if you looked at Rome, like at the height of like Christians getting murdered for sport by the Romans, like Diocletian, like if you looked at the percentage of the population that was getting hauled off and exiled and murdered for being Christian. And during the worst of the Roman periods, it was multiple times worse during the Bolshevik Revolution.
Oh wow! Because this doesn't
Yeah,
get
like we're
spoken
talking like
about at
10
all,
times
does it?
worse. I'm not even joking.
Yeah, this never gets spoken about. This isn't the sort of stuff.
No.
Which always
And America kind of
made me
slept
question
through it,
that.
right?
Sorry, what did you say, mate?
Oh, like America, the West, we all kind of slept through it. And to think that even the Tsar of Russia, their family, they were cousins of the freaking crown of the UK. That's the husband. What's his name?
What, the German guy? Alfred.
Yeah, so like if you pull up like was it King George V? He's like riding on bikes with Tsar Nicholas II, and they look like identical twins.
Yes, yeah. I know what you're talking about. The British royal family, very, especially with Hanovers as well, but slightly later.
You know who all the kings and queens of England actually got their title from? It was the Roman emperor, the emperor. It was the true emperor. It was the freaking Tsars.
Okay. Because the Holy
They
Roman
murdered their
Empire,
landlord,
I
dude.
always have to remove my bloody jog or sort my jog out, and whether it's the Roman Empire or yeah, of course, that would make a lot more sense, wouldn't it?
Yeah. It's always been about killing the landlord, the emperor. The emperor wasn't Roman Catholic. I mean, sure, there were quote unquote holy Roman emperors like the Habsburgs in Austria and stuff. But no, the true emperor came from Constantinople. And when that was toppled, they fled up north, first into Kiev. That was in like start in the 900s.
Isn't this the time? Again, if memory serves, isn't this the time where they had? Isn't this the time where the Roman Empire split, and they split between in the east and the west, and they needed the religious authority. So it's the religious authority in the east that moved north up into Russia.
Yes, that's right.
Gotcha.
Yeah, that started around 1000.
Yeah. Because the west really declined, like away from like that type of Christianity. They separated.
Yep, and the east was getting beaten up by Islam and coming in.
Oh, okay.
So yeah, they were squeezed and they fled up north. A bunch of people fled into the west from the east and brought with them all the science and technology, and then that later became called the Renaissance. What's funny is like you can Google this, called the Emperor's Throne Room of Constantinople. And in like the 800s, we have artifacts from this. In the 800s, they had automatons, they had mechanical men, mechanical animals in the throne room of the emperor that would serve wine and perform circus tricks for visitors.
Wow.
Powered by gears, powered by steam. And all of that knowledge and technology fled into the West, and they called that the Renaissance. And it was just a recasting, an extension of the development that had already taken place at that time.
Okay, that rounds that circle for me beautifully. Yeah, okay. That makes sense.
Yep, I saw these artifacts firsthand myself in the History Museum in Berlin. They've got a display of this.
Okay.
It's freaking beautiful. Yeah. Yep. And then they fled north, first into Kiev and then to Moscow. And they called this the third Rome. Why? Because Constantinople was the second Rome, and the first Rome was the backwater village in Italy.
Okay.
Yep.
Wow.
Yeah, and so it's really interesting, right? So then history happens, and you've got the Tsars, and then you've got the Bolshevik Revolution, the murder of the Romanovs, and then you've got communism, and then communism falls, and now you've got whatever the hell this is. But at the same time, you've got a re-emergence of ancient Christianity in Russia.
Okay.
Yeah, so now things are getting a bit weird, right?
Yeah.
Because now, I mean, you've got an entire nation of people that are devoutly Christian. And some of the reformers called the Eastern Orthodox Christians basically like truer Christians than we could ever be.
Okay. So
Yeah, things are a bit weird.
So I remember you said that it was when these people were killed that that was the restrainer. So after that took place, then Satan was released, and then vast deception was abound. Although beforehand there had already been schisms within the church, and Christianity had started splitting for whatever reason, but it was after this restrainer was taken out, the true Christian, so to speak.
Yeah, it might be it. It might be it. Listen, I mean, Tsar Nicholas II was the last Christian emperor of the world.
Okay. Okay, that's interesting to know.
Yeah. That's it. There's no other. That was it. The end.
And when was this?
1919. Somewhere around there.
1919.
Yeah.
So just over 100 years ago. Okay.
Yeah.
Oh, okay.
Yeah, exactly. I'm like, oh, it's pretty bitter. And you know, if you ever meet an Eastern Orthodox Christian, there's something genuine about it, and to think that there's a ruling family that could be inclined in this way, it's extremely wholesome and endearing. It warms your heart, and then you see what happened to them, how they were betrayed. So they were led by their confidants because they thought they were escaping the Bolshevik Revolution. They were led to like a safe house. But the people leading them to the safe house were part of the Bolshevik Revolution. And they lined up the royal family to take a picture of them before that they would flee to England to reunite with the rest of their family. And then machine gunners came out and shot them all to death.
That's sickening. Wow.
Yeah.
That's how you seize the power. You seize it by any means and keep it by any means.
Yeah. That's a good point.
Kids. Yeah, and like I said, you find out who actually was involved. It's the usual suspects that did it. And that alone adds another whole layer to this that we can't talk about.
Damn it.
Yeah. So with the restrainer gone.
Sorry.
World War I, World War II, World War III.
Oh, don't get me started on World Wars.
World War I started before, but yeah.
Yeah, thank you. Yeah, okay,
Yeah.
gotcha. World War One's actually World War Two. World War Two was actually
Yeah, World War I shouldn't have ever happened. That's for sure. Jeez. Yeah, and the usual suspects are involved in that too. But it's ugly, man. The history is so ugly, and we are at a very interesting point in time.
Yeah, we've got. I mean, I can speak only from really my experience. We've got a very diluted look back at history, especially coming from Britain, right? British Empire did some terrible bloody things, but it's all right. Tea and crumpets before four. Everything's okay.
Yeah, listen, man. The British. I mean, they were orthodox. for hundreds of years. Yep, they were Orthodox Christian. You bet.
We get told our history is Catholic separation from the church.
Yeah.
Protestant and Catholic wars. Basically,
So
the
even
Protestants
the
won.
fold of Protestantism, dude, like Protestants are still operating from a Catholic worldview and don't even know it. That's the
crazy.
sickening part.
Yeah,
So the
when you
East
try and
has
step away.
these answers.
Because
The Eastern Orthodox Church has no pope.
Yeah, that's why I brought up earlier the separation between you. We're here with the Pope in Rome. We're dealing with that guy at that time.
Leif Erikson. Leif Erikson, who discovered North America, he was Eastern Orthodox.
Wow.
When he made the sign of the cross, he'd go up, down, right, left, not up, down, left, right.
So well, that went by so fast. Can you say that again?
Yeah, so when you make the sign of the cross,
Yeah.
you take your three fingers, your index, your middle finger, and your thumb, representing the Trinity, touch it to your forehead, below your navel, although Roman Catholics don't do this. Got to bring it all the way down, and then you put it on your right shoulder, and then you push to the left.
Okay.
After the schism, sometime after the schism, the Roman Catholics reversed it. And what's even worse, they don't just go from the left shoulder to the right in reversal, but when they go from the forehead, they go down to the heart. And then they go left to right. It's an upside down freaking cross, dude.
Wow, of course, yeah.
Yeah. It's these little things, we call them indicators.
Yeah.
So yeah, Leif Erikson, Eric the Red, Christians, they were doing the full freaking, up, way down, right, left. They're not doing the Roman Catholic upside down cross.
With the right hand.
With the right
I think
hand.
that's so smart, don't they? Doing hand signals that only they know.
Oh, okay.
So there's a monk from California. His name is Seraphim Rose. He's a priest. He's considered a father in the sense that he's a priest. And he's kind of on the short list of people who are up for becoming a saint. There's a whole process for that. He's considered by many very widely to be somewhat prophetic in his writings, and he has written a ton. I think he died in 1982 or 1983. He gave a lecture at UC Berkeley, of all places, back in 1981 or 82. His lecture is called The End of the World, and it's about an hour long. And it is very eye-opening, even for today.
Oh, that's cool because I'm here in California. I'm by
Cool. He was in Platina.
I'm by the Los Angeles area.
I'll post a link publicly here in the chat. So it's a recording. Somebody set up a tape recorder or something in the lecture hall like 40 years ago.
Yeah. I can't hear anything. What is that?
Seraphim Rose used to be a hippie, and he was really big into Terence McKenna and mushrooms and LSD, acid, all that stuff. He was also big into theosophy and Gnosticism, Buddhism, Freemasonry. And he threw all of that away. He had a conversion experience. And I'm bringing this up. It's not about flat Earth. But with regards to the question about our timeline and history, it's a very appropriate topic, and I think I'll leave that there. So there you go. Enjoy.
Down for that, brother. Flat Earth, it's just another mystery school. You heard it here. You heard it there. You heard it everywhere. Most
I
flat
sure hope
earthers,
not.
most flat Earth, yeah. No. Most flat earthers, are nonsensical. Think
Yeah,
about it.
they're riding the goat.
They're all into all kind of esoteric woo-woo that they can't prove. It's all religious, spiritual, creation, nature of God claims. They have nothing to do with the shape of the Earth, right? Like probably more than I would say 90% or more of the flat earthers are like that I've encountered.
No, you're totally right. Absolutely. And so I've got a document out there. If you want it, just send me a message, DM me. So it's on the church fathers. This goes from like 100 AD all the way up to the Reformation, of men who are involved in the church who have written about the flat earth. This includes the confessor of the Emperor of Constantinople. This includes St. John Chrysostom and so on, St. Athanasius, St. Basil, so many Eastern saints and Reformation people. They were all flat earthers. So you can break free of this crazy Gnostic occultism and flat earth and join us, graft yourself onto the branch of Christianity.
That was the other question I was going to ask you.
Oh, okay.
Just because I've seen, I always see how things change. We all do, right? It's just something that I've noticed. Along with my venture into what I classified as Satan's little season and stuff, there are other people that seem to be further down the road talking about Gnosticism and the Gnostic text and a different, completely different way of looking at the Bible and Jesus Christ and who the creator is compared to Jesus' actual father and so on. So I've heard this from other flat earthers and I've kind of come across it before. Have you got any thoughts on this or Gnosticism and what that means? Or should we not bother talking about it because it's really not talking about flat? And I'll appreciate and accept that.
That's a big topic. Like, there's no single one Gnosticism. You've got the Sethians, the Valentinians, the Basilidinians, or whatever you call them, the Bogomils. You've got so many different branches. They don't all agree. I mean, it really all traces back to Greek Platonism, Plotinus. There are people that call. So
No, Yoder. You may be factually correct. It's simpler than that. It's all about boobs and ass. That's what it's all about.
It's boobs and ass. You got it. It's all about. It's not just boobs and ass, but also like assholes of other men. And you don't want
I'm
any
being
of
serious.
that.
So see, some people heard me and they thought I was being tongue in cheek. I'm being serious. Most of these schisms like that occur because people can't reconcile the passions and desires of the flesh with the fact that the flesh is not inherently evil.
Yeah.
They can't reconcile that. They don't know how to square that circle. And so they have to condemn the things that they desire, and then they try to create this whole worldview which justifies this struggle within themselves. So in other words, they're really horny. They can't get over the fact that every time they see a boobs in the ass, they get horny and they want to get it on because they think that's evil. So now they have to create this whole worldview which justifies their brokenness.
Wow.
Yeah, so I got it. So the demi-urge is an urge to fuck and fuck you and fuck everything.
Yeah. Think about it. Think about the great mystery. What is one of the great mysteries in the Bible? Marriage.
Yeah.
It says that the marriage between a man and a woman and they become one flesh is exemplar of the relationship between God and his church, Christ and his bride. It's all one big mystery. So if you can make that perverted, then you can really screw people, because you got to consider like the biological imperatives: eat, defend yourselves, and procreate. So procreate is 1/3 of your imperative. And if you make people think that procreation is evil, the Puritans did this, by the way, themselves. They said, like, oh, desiring your own wife is evil. So when you have sex with your wife, you can't desire her. You have to like imagine she's ugly, and then like do it out of service, not out of pleasure. Like all these people, dude, they're just pissed off that God created man and women to be together, and some of the erotic passions that men and women share for each other are perfectly natural, normal, and holy. And they cannot comprehend the fact that your wife wanted to lick your tip and take a little sip is holy. They can't comprehend it because they're perverts.
Puritans now.
Yeah, they're perverts, bro. the wife that wants to get impaled by her husband and have her mons veneris on the top of her pubic bone get pounded into oblivion, she's not the one that's perverted. The other people who say that a husband and wife's passion for each other is perverted, that's who's perverted.
I got a question. How am I doing on selling Eastern Orthodoxy to a non-Orthodox guy?
It's intriguing me about selling it, dude, but I'm more open to it now than I was, say, 6 months ago. That's for sure. So yeah, I mean, you're explaining it really well, and I understand what you're saying for sure.
Okay, cool. How about you, AI?
I wasn't even paying attention.
Okay, fair. I mean, my foray into this wasn't by any means like from birth or I was forced into it. I was actually at a Lutheran seminary, and one of my adjunct professors was no shit, he was an Eastern Orthodox priest. So we'd be sitting there in the commons having like lunch or whatever. He'd come over, and he was big into the same kind of music I was. So we're talking like heavy metal and stuff. This is like 25 years ago, and he'd be talking about all the coolness of the ancient church, not Roman Catholic. So fast forward about 5, 6, 7, 8 years, and I'm checking this stuff out. No, I never became a Lutheran pastor. So did you know that Bob Marley is Eastern Orthodox?
Really?
Yeah. And Cad Von D became Eastern Orthodox. Pretty sure Mel Gibson's on his way because he went to Mount Athos recently. Out by me, we had an entire Amish community. Yes, I actually do live amongst the Amish. We had an entire Amish community convert to Eastern Orthodox.
You did.
And I had nothing to do with it.
I always imagined you did live among the Amish.
I freaking do. I live in Lancaster, Pennsylvania. Big shocker, folks.
You've got internet in 1889 or whatever you live?
Sorry, what?
You've got internet in the times like
yeah, I do. My Amish bishop allows me to use the internet for 2 hours every Thursday. It happens to be Thursday, and it's my 2-hour block.
Kind of funny how name and titles kind of describe people, because I remember when you joined the server, you had that name Amish, and I depicted you when you spoke as an Amish, but it was just based on your name.
Dude, it goes back even further, Gemsy. You checked me in along with Gospel Bearer, Orion, and Pantomath. And I came in as Sporadic E. And I was given a Globe Skeptic role because I was not unsure at the time. And about right after my check-in, in my rolls, you sent me a whole bunch of stuff about the sporadic meteor complex. Maybe because my name tipped you off. And I only knew about that because my mom was an astronomer. And I know a lot about astronomy from her. She actually worked at the Big Ear, the radio telescope lab in Ohio. Yeah, man, we go back. And then I changed my name to Amish. And now I'm Yoder. And Yoder's like the most popular Amish last name, let me tell you. Like if the Amish could have a phone book, Yoder would take up half the freaking book.
Do you guys sing Yoder Ahi Hoo?
I like Yoder. Still, the sporadic complex and the observations of the radiant sources that we share, that's one of the most interesting observable phenomena I've ever seen.
Yeah. For me too, man. It's the most, yeah. I think it's cooler than Flat Earth, honestly.
What?
Same
I think
here.
meteors are cooler than flat Earth.
Yeah, the sporadic meteor complex is cooler than Flat Earth.
Why?
Let me tell you what, there's a shape of a cross that adorns the night sky every night.
Yeah.
From north to south poles across the equator. You can only see it in infrared.
Right. That's just astrotheology.
Honk honk.
Actually, infrared is one of the better looking, let's say, scans, but there's also radio surveys, which is not infrared, and there is also thermal imaging, and that phenomena is observable in all of those spectrums: infrared, electro-optical, which is active infrared, radio, and thermal. So yeah, interesting.
Yeah, personally, Yoder, I think there's only one cool thing. There's only one cool thing. Everything else is waste of impression. What I mean by that is I'm not impressed at all. The only thing that impresses me is that separate sentient entities exist. Everything else is menial. The idea that physical things can have different permutations or be not what we expect them to be, like that's all subservient to the fact that a sentient entity and another sentient entity exist. But there's absolutely no reason for sentience to be translated from one entity to another. So, like when you give birth to a child, there's no reason for that child to be sentient whatsoever. There's nothing about you that can impart sentience onto it.
I gotcha. I mean,
so
for me,
in other words, if you extrapolate that out,
is the structure.
If you extrapolate that out to my whole metaphysic, nothing in the physical and natural world is impressive. The only thing that's impressive is that God created other sentient agents besides himself. All the other creations, like, whoop-de-doo compared to that.
Oh shit, are you a Gnostic? Just kidding.
No, that wouldn't make me a Gnostic.
Yeah, I mean, Gnostics are like rejecting the natural world because they think it's full of evil.
No, I'm just saying it's not. It's nothing. Like it's no big deal compared to a sentient entity in itself.
No, I gotcha.
Like a single sentient entity is worth so much more than the entire physical natural world put together.
I agree with that. I think the sporadic meteor complex is higher than flat Earth, but underneath that.
Yeah.
How about that?
Like you get the cake for your child that they really wanted, and it makes their day, and they're smiling and they're happy inside. Like that's way better than some arranged stars, by far.
Totally.
Which part of the problem with this heliocentric model, and I fell victim to it too, is where I got so romanticized with deep space that I used to fantasize about all these stupid rocks doing stupid things way out in the depths of space. And then one day I had this epiphany, like, wow, that's retarded. Who cares about that stuff? This stuff's useless and a big waste of time.
Just mention the fantasies you had about green girlfriends from Mars or something.
No, my fantasies about deep space, besides traditional space opera type stuff, was that when
The
I
deep
died.
space on the girl.
No, I'm serious. When I died,
Okay.
then God would show me all of the mysteries. Like he would take me to 3 trillion miles to the left and show me some stupid rock doing some stupid thing. I was like, oh man, it's gonna be so awesome when I see the stupid rock roll down the stupid rock hill in stupid space. It's gonna be awesome. Then I realized, wow, that's
And then
a
he
really
shows you there's a stupid rock in a stupid space. You're like,
yeah,
oh shit.
exactly. What a big big waste of a hope and dream, But really, I should have been hoping and dreaming to like do things with like actual accomplishments, like being there for the people you love and all these other types of things that actually matter.
Right. Yeah, definitely. Like your experience matters. Your experience determines your fate forever.
Yeah, and the universe itself without something to experience it is pretty much useless. No matter what's going on in it, no matter how miraculous it is that it rains diamonds sideways out of Uranus, like none of that matters if there's nobody to observe it. It's literally a big waste of pointless time. Yeah, but speaking of the history of religions, it's crazy how people don't realize that the globe paradigm is like entrenched in religious, uh, back up from the past. They just don't get it. They think like the globe is just like the pure secular, dispassionate search for the truth, and has nothing to do with religious tainting from the past. It's like, dude, you haven't even been paying attention, bro.
Yeah, and the globe and the solar system is all Kabbalah. So, like in the Kabbalistic tree of life, the Sefer Yetzirah, there is a point called Tifereth in the middle. It's below Doth. It's above Malkut. It's right in the center of the diagram. It's called Tifereth. It's called the heart. It's called the solar awakening. It's called the sun. And everything in this tree, in this diagram, which purports to be a representation of the emanation of things, which is a completely heretical, Gnostical thing. Everything basically emanates from it. Yeah, and this precedes any notions of the solar system.
How did they figure this shit out, though?
What?
Like, how did they figure the things that they said back in the day out? Like, from a religious...
They didn't figure it out. It's called the Texas sharpshooter fallacy.
They didn't have to figure it out?
No, like the solar system's completely fake.
No, I'm saying like from like a religious perspective, the worldview that was figured out from that.
So there's no big bang.
Some say it was figured out. Some say they were influenced by other entities that had designs on humankind to steer humankind's evolution through knowledge to a particular result, which will ultimately put Satan as the god that everyone worships.
So,
and then, of course, humans have their own machinations, right?
Yeah, but isn't it like some person sitting down and thinking and then saying something and then people believe it or something? I don't get it.
Yeah, but think about it this way, bro. Where in the world? Let's say you're a person. You have to make fire, cook your food. You have to hunt your food. You have to stab it so it dies. So then you can, so it's not running away. All right. Then you take a pee. Then you take a dump. Then you kiss your wife. And then you're like, oh, that must mean God has 7 spirits emanating out from his backside that all become magical words that float in the mystical sea of the ether. Like, how do you get any of that stuff from there? Doesn't make any sense.
Yes. Right? I understand that. So
Right. So then you're back where you started, which is how did they come up with these ideas in the first place? Well, I think the answer is obviously because there's more things in the world than just human minds. There's other minds, and those minds have influence on human minds. And they know things that we don't know. And they also know that they know better than us certain things, and so they're able to deceive us.
Good morning out there to all the NASA fans and NASA detractors. So am I hearing this correctly that NASA plans to put astronauts into space and orbit the moon? Is that what's happening in 2026? Has anyone made predictions yet? What's going to happen? And when is the ISS supposed to deorbit and burn up in the atmosphere? When's that supposed to happen? So it looks like Flare Fighter 76 has been text muted again. Brand new account created yesterday. Says he's an aerospace engineer and a pilot. 24/7 Flat Earth just happened to be his first stop, I guess. His first stop on Discord itself. Amazing. But his microphone's broken. Imagine that. Why would you join Discord with a broken microphone? Like, you guys ever read those system requirements they have for software? Must have a 386 DX 33 megahertz. I mean, everybody who's anybody knows that Discord is meant for discussing and having Discord. Plenty of people have Discord on their phones too. Is your microphone on your phone disabled? Doubt it. Nah, I don't think that's a new account. I think he's one of our biggest fans, to be honest. He's incognito. I think he's been around this discussion for so long. For so long that he can't believe that it's true. He can't accept that Flat Earth is true. And for many, it's a coping mechanism. They don't want to accept that Flat Earth is true, but they know it's true. So they come in and they argue with us. They argue with us because they want to make sure that they're not going crazy. They want us to defeat their arguments so that they know that they're not going crazy. But they're not ready to accept the psychological and emotional consequences of what Flat Earth means. Intellectually, they fully understand. And this cognitive dissonance keeps them coming back for more, again and again and again. Some people try to monetize this behavior out of them, out of anyone who comes in. Not us. We are volunteers. We do this because it's fun. Welcome to, is that Janus? Welcome to Janus, to 24/7 Flat Earth. If anybody out there is on YouTube listening, feel free to come in, stop in. The temperature is warm. Jay Tolan, he's a flat earther. He runs a YouTube channel called Jay Tolan Media, JTOLAN. He specializes in radio frequency engineering, optical and radio both. He's worked on and designed communication systems and guidance systems. One of his hobbies is to take high-end infrared cameras on aircraft, to look sideways out the window and zoom right on in on the horizon, see what you can see. Let me tell you what, very few people on Earth Very few people have seen what he shows you in these videos. Count yourself lucky if you've ever seen anything like this. It's just incredible because the more he zooms, the flatter it is. There's no curvature, no horizon line separating the sky from the ground for the globe. No, just perspective and atmospheric density. Seeing a range multiple times what the Earth should be if it were a globe. His latest video is quite interesting. He invokes NASA as a hostile witness. He says, let's see what NASA says about the Earth. He pulled up some footage from the International Space Station. Some of you, if you're old enough, you might remember NASA TV. NASA TV is or was a TV channel. It was offered with the Dish Network package if you subscribe to a satellite dish service. About maybe 25 years ago. One of the channels that you got was NASA TV, where they'd show you looping clips from the ISS, the view from Earth and outer space. They'd have some educational content from NASA astronauts and so on. So some of this still exists today. He took some of that footage. He said, you know what? Let's apply some photogrammetry principles to this and see what we can measure. What's photogrammetry? Photogrammetry is basically taking images and taking a known scale factor. So you look somewhere in the image for something that you know is of a specific size or dimension. Let's say you've got an image of a city and you see a Honda Civic. And you see a 2008 Honda Civic. You can look up, you understand what the dimensions are of a Honda Civic. So with that Honda Civic, you know its length and width, you can see what other objects are in its vicinity related to that length and width. And you can do some proxy measurements, can't you? You can say, well, this building is 5 Honda Civics long. It gets complicated because you can factor in your perspective, you can factor in your motion, you can factor in your camera lens, the focal length, field of view. And you can start to get pretty technically savvy. And you can start figuring out how far things are from the camera. I dare say this is one of his specialties because he has numerous videos doing this and providing tutorials on how to do it. It's pretty fascinating stuff. So he took ISS footage and applied photogrammetry. You know what he found? He found that if you measure the Earth, what's visible from the ISS, from its claimed orbit, 250 miles up above a globe, that the circumference of Earth approaches 100,000 miles. It's something like 95,000 miles. Almost 4 times what the claimed globe circumference is. Now, is he saying it's flat? Well, it's definitely not the globe that NASA told us if it isn't flat. And I believe these constraints on a claimed circumference are only given as such because that's as far as his imagery was able to allow him to compute. Could it be a sphere with an infinite radius, in which case it would be flat? Something is definitely wrong with what we've been told, with what people believe, how they conceive the world. Something is vastly wrong. All right, I'm going to read an article here. The article is titled, The Great Disappearing Act, Why Gravity Isn't Crushing Your Gas. We need to talk about the atmosphere. Specifically, we need to talk about the absolute mess that standard hydrostatics makes of gas physics. You know the story. The atmosphere is a stack of blankets. The bottom layer is crushed by the weight of the layers above it. Nonsense. If you treat a gas like a stack of bricks or blankets, whatever, you are missing the most beautiful part of physics, the motion of gas. The gas is not settled. It is chaos. It is billions of tiny molecules bouncing off the walls, off each other, going 1,000 miles per hour. Let's look at the math that makes the weight argument fall apart. We're going to make mass disappear. The heavy misconception. Standard textbook physics wants you to believe that pressure is just weight distributed over an area. And if that were true, a column of heavy gas should crush you much harder than a column of light gas. But look at Avogadro's law. It's empirical. It says if you have a box of hydrogen, 1 atomic mass unit each, and a box of argon, 40 atomic mass units, at the same temperature and pressure, they have the same number of molecules. But wait a minute. Argon is 40 times heavier than hydrogen. If gravity or weight were driving pressure, the argon box should have 40 times the pressure. But the fact is, it doesn't. It has the same pressure. So how's this possible? Is Newton lying to us with mass attracting mass? No. No. You're just looking at the wrong equation. The kinetic reality, watch the math. Pressure in a gas isn't pushing down, it is bombardment. It is kinetic molecular theory. Pressure is proportional to the mass of the particles times their velocity squared. Now here's the secret that gravity causes pressure. Forgets. Temperature is the great equalizer, not gravity. Temperature is a measure of average kinetic energy. If two gases are at the same temperature, their kinetic energies are equal. But because kinetic energy is 1/2 mass times velocity squared, a heavy particle must move slower. The velocity of a gas particle scales inversely with the square root of its mass. Do you see it coming? It's beautiful. The disappearing act. Let's plug that velocity back into our pressure proportionality. We have pressure, so we substitute our velocity term. We square the term, and what happens? Look at this. The mass cancels out. It's gone. I'll share the article later so you can see. I'm not going to read all the formulas, equations. It's going to be too boring. But the mass cancels out. Yep, when you make that substitution, the mass is not there. The heaviness of the argon atom is perfectly, mathematically destroyed by its sluggishness. The lightness of hydrogen is perfectly compensated by its immense speed. The pressure has nothing to do with the so-called weight of the particle in a gravity field. It has everything to do with the energy, that is temperature, and its containment, volume. But what about that barometric formula? You have to look closer. Don't just memorize the formula, but look at it. This equation isn't calculating weight pressing down with the little g in there. It is describing through g a statistical distribution. It is a balancing act between the energy of position, that is so-called gravity trying to sort them, and the energy of motion, which is temperature trying to mix them. Since we just proved that the kinetic energy term inherently accounts for mass in the velocity distribution, the mass in this equation is essentially fighting itself, and that's why it cancels out. Gravity isn't a force compressing the gas. It's just a description defining the gradient of the density. The conclusion, for you skeptics out there, if you take away the container, the gas expands. It doesn't matter how much gravity you have. Without a lid, the pressure gradient dissolves into the vacuum. Do you accept thermodynamics? I hope you do. So next time someone tells you atmospheric pressure is just the weight of the air, you tell them to check their kinetic vectors. Gravity doesn't compress gas. Containers compress gas. Gravity just describes where the particles might like to hang out as they bounce off the walls. For this article and more like it, please visit our server. We've got a repository called Flat Earth Central. You can check my profile for the link. Please join today.
All right, so I've just started an event called Flat Earth Explained. It's just a Q&A if people want to come in and ask us questions about Flat Earth, because most people don't know anything about this topic. So proposal, if you have any questions or anything like that.
Yes. Can I ask where are you from?
Yeah, I'm from Australia, but I live in Poland at the moment.
Did you travel across the world?
Yes.
So what countries did you visit?
Been to Southeast Asia a bunch, Greece, Spain, Sri Lanka, India, yeah, a bunch of places.
So you told the people about the Earth in these countries, or you just traveling like a tourist?
No, just a tourist. Yeah.
Okay. This like a joke meeting, or you actually believe in flat Earth?
Yeah, no, this is a genuine flat Earth conversation, not a joke.
Okay. Do you wanna tell me like some facts?
Sure. So we're not claiming to know the shape of the Earth, and we're not claiming that the Earth is like a flat globe, right? If you think about the globe model, where you have a big vacuum, which is the universe, and you've got all of the planets, and then the globe is one of those planets. And then people hear about flat Earth and they think, oh, okay, so it must be a flat disk instead of a flat ball. That's not what we claim. That's misinformation. And so we're not claiming to know the shape of the Earth. Flat is not a shape, but the Earth is flat. Okay, but we're not claiming to know the shape. When we say flat Earth, we mean the surface of the Earth, mostly covered in water. Okay, the known surface area of the Earth is over 70% water. And then when we test over the surface of the water, over long distances, it's flat. It's not curving.
Interesting.
Yeah, like we're doing laser tests, long distance observations, and we're calculating how much curvature there should be. For example, over 20 miles, there should be about 80 meters of curvature, which is about 260 feet or something like that, approximately. Okay. And that means that there should be consequences of what you would see if you're looking over that distance. So if you go to like a 20-mile distance over the surface of the water, and you've got a landmark that's 20 miles away, and you're just standing there on one side of the body of water, you shouldn't be able to see something that's, you shouldn't be able to zoom in across and see the shoreline 20 miles away, or you shouldn't be able to zoom across and see your friend standing on the other side of the 20-mile body of water, because it should be hidden behind the curvature of the Earth. But that's not happening when we go out and look over these distances. We're not seeing any curvature. We're seeing our body standing 20 miles away. We're seeing the shoreline 20 miles away, for example.
Okay, what it proves?
What's that?
What it proves? You don't see your body getting.
You need to maybe talk a little bit louder into the microphone. It's a bit soft. I've turned you up.
I'm saying what it proves. What you are trying to prove? The Earth is flat.
Yeah, that the Earth is not a globe, and that there's no curvature detected.
Okay, there has a lot of images or something that if you look at into those images, then you will realize the Earth is not flat. It's like a orange shape, this kind of thing. It's not flat.
Yeah, but that's just pictures that you're seeing that NASA gave you.
Not NASA gave you. There has
okay. Which picture then? Okay, find me a picture of the globe that's not from NASA and put it in the side chat.
So, like a video where a guy put
Okay.
on
Can you
a balloon and he
can you see Bruce Khalifa from America?
No, I can't. But hold on a second, right? I just want to talk to one person at a time. So just hold on a second, Arkan. We'll get to that question in a second. What did you say? Proposal?
it's actually Prospal.
Prospal.
Like,
sorry about that.
I saw a video when some guy put a phone on a balloon and it went to the like space, and you can see the curvature that you was talking about.
Yeah, so if you have a closer look at that video, what you're going to see is that the curvature that you see in the video is just because of the lens. It's lens distortion. And what you'll see in the video is that when the camera moves around, the horizon will actually change. And when the horizon's above the center of the frame, when the horizon's above the center of the frame, it's going to look like a globe. And when the horizon's below the center of the frame, it's going to be curving the opposite direction. Okay, and it's called lens distortion. It's because of the focal length of the lens that's being used. You can check that. If you want to find the video now, you can put it in the side chat and we can take some screenshots and have a look through the video because
let me search for it.
Okay. Yeah.
Yeah, your turn, Arkan. Go ahead with your question. Why can't you see forever? Why can't you see for really long distances?
Yeah, I can't see Bruce Khalifa from like India or America. The Earth is curved or round, and Bruce Khalifa is another side of Earth. Therefore, we can see Bruce Khalifa. If the Earth is flat, then we can see all the mountain or the Bruce Khalifa, all the building from every corner of Earth.
Yeah, good question. So if the air was perfectly transparent and you had some giant telescope, maybe you would be able to if you had a clear line of sight. But let me finish.
Okay.
Let me finish. Hold on a second, my friend. Okay, so the air has a visibility distance that you can see through the air because in the air we have fog, we have mist, we have water vapor, we have dust, we have pollution, we have gases. All of these things means that we have a visibility limit. Now, if you go on the internet right now and you type in what is the visibility, the average visibility or the maximum visibility in any place that you want to type in the world, and you're going to find that it's not a very long distance. It might be 10 miles, 20 miles, 30 miles if you're lucky. Okay, but that's the maximum distance that you can see. It's kind of like if you go up on a mountaintop and you look out over more mountains in the distance, each mountain that is further away is going to become less and less visible. And then eventually it's just going to be too difficult to see because the air will make it opaque and because you can't see forever through the air. The air itself is only semi-transparent. You can't see forever through the air. So even if you had the best telescope in the world, you're not going to be able to see forever through the air.
Okay, I don't know what. Yeah, I feel like you are living in a cave or something. You don't have.
No. I live in Poland. Yeah, I live in Poland, and I just gave you a perfectly.
You live in Australia.
No, I'm from Australia, but I live in Poland.
Oh, okay.
Yeah.
You sound really good. Your accent is really good, bro.
Oh, thank you, bro. Your English is very good as well. But this is the thing. Yeah, I don't live in a cave, right? I live in reality, the same reality that you live in, which we experience as flat and stationary. The only reason that we thought it was a globe or think it's a globe is because it's something that we've been taught growing up. And we've seen some pictures on the television.
Yeah, I'm not concerned about whether the Earth is gold or rounded or circled or flat or whatever. As long as I can live here freely, it's okay, you know.
Mm-hmm.
Yeah.
So, can you see the link to the video I posted?
Yes. Yeah, I'm just opening it now. I'll have a look at that. Just got to wait for the ads to play. Just a second.
Yes. Actual video of on the like space in the end of video after so
Yeah, so this is just it's just like a GoPro lens, like a fisheye lens. So have a look through the video and you'll see the horizon changing constantly. It's a wide angle lens. They're probably using an action camera. Okay, so you'll see that when the lens is moving around, you'll see the horizons changing, completely changing. I'll post some screenshots.
Actually, I don't see any lens on this camera.
Well, all cameras. I mean, all cameras have a lens. What do you mean? Okay, so here, right? Hold on a second. Let's go through some screenshots. Okay, so this is 5 minutes 39 in the video, and we can see that now look, it looks like it's curving the wrong way because, like I said, when the horizon is below the center of the frame, it's going to look like it's curving the opposite direction than it should be. Now, as soon as the horizon goes above the center of the frame, then all of a sudden it's going to look like it's actually curving like a globe.
I actually
see what I mean?
What is the horizon and what the effect you are talking about?
Yeah, it's called lens distortion. Okay, so yeah, lens distortion. Okay, so here we go. We got 5 minutes 44 in the video. Okay, so just a second. All right, 5 minutes 44. I'm going to post a screenshot. So just look in the side chat. Okay, so 5 minutes 44. We have a flat horizon. Okay, and then just literally 2 seconds later, the camera pans up a little bit, and then the horizon's above the center of the frame, and now all of a sudden we have curvature. Okay, so we have 3 images there in the side chat. We have the horizon below the center of the frame, and it's curving the wrong way. Okay, and then we have the horizon closer to the center of the frame, and it's flat. And then we have the horizon above the center of the frame, and now it looks like it's curving. So that's proof that this is just the type of lens they're using. They're using a wide angle lens, and that's the reason that we're seeing what we're seeing in the video. It's not evidence of a globe or a flat Earth. It's just a cool video where you could see, from a high height.
I think the higher they go, the more you can see the curvature, and this is not dependent on.
No, the same thing will happen. The same thing will happen even when they're close to the ground. Exactly the same thing will happen when they're close to the ground, because it's just purely a lens distortion effect. So you can send up as high as you want. So the maximum height that we can send a weather balloon is about 120,000 feet. All right, so I'm going to show you some footage from 120,000 feet.
What is this in meters?
Oh, well, there's 3 feet in 1 meter. So, like 40. Hold on, I'll check exactly. So it's like 36,500 meters. That's about the maximum height that you can send up a weather balloon, because they pop. Once they get any higher than that, they pop because of the pressure. So when we send up a weather balloon that doesn't have a wide-angle lens on it, we just see a flat horizon from that height. And I'm not saying that that's proof that the Earth is flat either. I'm just saying that from 120,000 feet, we don't see any curvature. We don't see any curvature when we go out in reality. And then when we go up into a plane, we don't see any curvature. And then when we go up and look at footage from a weather balloon, we don't see any curvature. Okay, we experience the Earth as flat.
I googled like how high-angle lens look like, and the people that making this video are not using it.
Well, I showed you proof. I showed you proof that they're using it. Okay, unless you think that the Earth is shape-shifting, then obviously they're using a wide-angle lens, because you can see just within just a few seconds it looks flat, and then it looks like it's curved, and then it looks like it's concave. So that's proof that it's. So there's two options: a wide-angle lens is being used, or the Earth is shape-shifting in front of your very eyes, which is obviously not the case.
World is round.
No. Or the Earth is a donut, right? Because it looks like a donut in the top picture, doesn't it?
Yes, first option. Why you not taking that options?
Okay, because it's a wide-angle lens, and the horizon is distorting because of the lens that's being used.
Or the world is round.
Because of the lens, it looks like that because of the lens, right? And then it looks flat. Can you see the side chat?
No.
Can you see the side chat?
Yes, I already.
Okay, can you see the middle image?
Yes, I already.
Okay, does that look like a globe? Why is it flat? Why is it
not working?
Okay, so why is it flat in that image?
Because the balloon is not that high that at third picture.
No, yes, it is. It's taken. This is a screenshot. Look at the time. Okay, look at the time that I took the screenshot. Okay, hold on a second.
There are.
Have you not watched the video? Yeah, so I'll put it in again with the time this time. Okay, so 5:44 and 5:46. 5:44 and 5:46. So you think in 2 seconds, 2 seconds later in the video, that the Earth, all of a sudden, you can see all of that curvature 2 seconds later?
Yes. Why not?
2 seconds.
You think like 2 seconds and nothing can happen with the height in these 2 seconds. You can.
Oh, okay. Well, how come it flattened back out again after that?
Maybe the balloon come down.
No, the balloon. You should watch the video first, right? Look, it's flattening back out again. Wow, maybe it's a lens effect. Maybe they're using a wide-angle lens, which is obvious in the footage, and that's why this is happening.
Or maybe the world is the Earth is round.
Yeah, and it shape shifts. It shape shifts. Does it? The Earth is shape shifting.
Why are you not taking this as an option? I just wanna learn about that.
Because in the footage, you see the horizon distorting. You can't cherry pick when the horizon's above the center frame and say that that's proof that the Earth is round, right? Obviously, you don't know anything about how lenses work, and even when it's explained to you, it doesn't click in your brain to just concede and say, okay, obviously it's not shape shifting, and maybe I'm going to check how the lens works. If there's anyone else in the chat, right, that maybe wants to ask.
I don't want to talk to you. You're rude. Sorry,
bro. You're okay. All right, buddy. Well, put yourself on mute. Very nice.
Guys, do you think that Earth is flat?
No. Yeah. Put yourself on mute, bro.
Why? Why?
Why? Because when we go out and test the Earth, in reality, there's no curvature.
Okay, can you prove it?
Yes.
No. How?
Long distance observations, laser tests, where there would have to be a large amount of curvature between point A and point B, and there's not. It's not there. It's never there. And we can test it over and over again. Just like we experience, the Earth is not a globe. Okay, we have tests, many tests that have been done.
Now, there are a lot of people who, are fighting for this. And I don't actually understand what is the purpose. I mean, what is the difference? I mean, who cares if the Earth is flat or circle? Who cares?
Well, people care enough to join a flat Earth channel and emotionally defend for the globe. Right?
Maybe, but
maybe, yeah, definitely.
Let's say the Earth is flat. Okay, the Earth is flat. Let's suppose that it's flat. What are you going to get?
What are we going to get? What, you want to get a prize or something like that?
Yeah.
Yeah, so you get to know. You get to know that. What's the purpose behind what?
Behind all the fucking, all this buzz that's happening because of this stupid topic.
No, it's a great topic. Okay, so this is the thing.
I'm not going to believe anyone until I see it by myself. And who cares?
But okay, so this is what you already see it every time you go to the ocean or to a lake, or anywhere, right? You don't ever see any curvature of the Earth. You experience the Earth as flat and stationary. The only reason you think it's a globe is because that's what you were told when you were growing up, and you saw some movies, and you saw some pictures from NASA, and you thought, "Oh wow, the Earth is a globe," and that's the only reason you think it's a globe. But you experience it.
I don't believe that it's globe. I don't believe that it's flat or not. I don't know.
Okay.
I can't. If you ask me, I'm not gonna tell you it's flat or it's not. I'm gonna tell you I don't know because I didn't see it. I must go to the space and see it by my eyes. Okay.
Okay. Well. Okay then. So you're not sure, but you experience it as flat when you go out in reality, right?
I mean, you can't know. Let's say that you are a small, you are small. You are too
The
small.
Earth's really big. The Earth's really big, and you're really small, and the Earth's really big. So you experience it as flat.
You can't see if it's actually flat because you will see it's flat, but you can't make sure that it's flat.
So you experience it as flat.
You just
just say yes.
But you can
say yes.
Yeah.
See, there we go.
Yeah.
Okay, that's a starting point. That's a starting point. Okay, and now if you want to claim that what seems flat is actually curving, then we need to go out and test the Earth, and we've done that. And it's not a globe. It actually measures flat when we do long distance observations, laser tests over huge distances where there should be many hundreds of feet of curvature.
Actually, the only way for me is to go out.
No. We can't get high enough to see any curvature, even if the Earth was a globe. We can only get up to the height of a plane. Okay, like 40,000 feet high, or we can send up a weather balloon with a camera on it, and it looks flat from that height. Okay, we can't go up higher than that.
But when you go to the space, it's not flat.
No. You didn't go to the space. Okay, you've only been taught a story about space. Nobody is going to space. America faked the moon missions. That they're the only people. They're the only people. Why? Because they wanted to seem like they could do something that no other country could do, perhaps. Okay, we could speculate all day long, right? They got billions and billions of dollars in tax money. Who knows where that money really went? But they got seen as the most powerful country because they could do what no other country could do. They beat the Soviets in the space race, and they went to the moon, right? But if you have a look at the footage is
why would they start
inconsistent.
a race?
I have a question.
I mean, why would they start a race and there's no, end line?
Yeah, well, there was an end line, wasn't there?
Where you say that
America did it. America, the greatest nation, because they could do what no other country could do, right? They the most technologically advanced country did what no other country could do, and they went to the moon.
No, all of us know that a lot of countries did.
No other
After
countries
America, a
put
lot
a
of
man on the
countries
moon. No other country sent a person to the moon.
not to the moon, but to the station in
Yeah,
the
that's not
space.
very high. That's not even high enough to see the curvature of the Earth. That's only 250 miles
But
up.
the
The moon's
pictures from
250.
there.
No. If you look at pictures through
So we are not
a
supposed
wide angle
to.
lens, if you look
We
at
are not
pictures
supposed
through a
to
wide
believe.
angle lens, if you look at the pictures or the videos that are made through a wide angle lens and the horizon is above the center of the frame, it's going to have lens distortion and make it look curved. If you have a look in the side chat, there's a great example there. Okay, if you take a still shot of that GIF in the side chat, when the horizon is curving, right, you'll say, oh, look, we can see the curvature. But as the horizon goes below the center of the frame, you can see that, no, actually, it wasn't Earth curvature. It was just a lens effect. So that's what you're seeing from the ISS footage.
What about the travel of Magellan? Is this a lie?
No, it's not a lie, but it doesn't prove that the Earth's a globe.
He turned around the Earth.
Yeah, so look, let's just say you have a big lake with islands in the lake, and you get on a boat and you go around the lake and come back to where you started. That's a flat surface. You just went around the lake and you came back to where you started again. That's all Magellan did.
And if the Earth is flat, then we need some kind of outlines. Because
outlines? What do you mean?
The water will, because the oceans will just go to the space.
Oh, right, like on a globe where you have all of the water stuck to the outside of a ball.
Oh.
Uh-oh. Yeah, think about it, right? We're claiming that water needs a container. You have to have a container to have a large body of water, like a pool, right? You have the pool, and then you have the edges of the pool, and it's the container that holds the water.
Yeah, that's what I'm talking about.
If you have like a lake, like if you have like a big lake or something like that, right? Obviously you can't fall off the lake, and the water, what's containing the water, right? It's the container. It's the low spot in the land where the water gathers, and then you have a shoreline at the edge of the body of the water. Okay, we say that you need to have a container to have a large body of water. That's common sense. That's logical, right? We're not saying that we have a ball that's spinning through space with all of the ocean stuck to the outside of a ball that's spinning through space at like over 1 million miles per hour in all these different directions. Like that's the crazy claim. But we've been desensitized to how crazy that claim is. Okay, we think of that as normal, where that's not normal. What's normal is that water needs a container, and then the surface of the water is flat. That's what we're claiming. The logical standard, right? The logical standpoint is that water needs a container. The water on the surface of the container is flat. Okay, on the globe, it's all stuck to the outside of a ball. And then you need a magical force called gravity, right, that holds all of the water to the outside of the ball. So all we're claiming is everything that we all experience, everything that's logical, okay? It's anyone can go and test it anytime out in reality. You don't need to have a belief. You don't need to have faith or trust in higher powers like astronomers or astrophysicists or space scientists, theoretical physicists. You don't need to trust these people when you have a flat Earth. Okay, because we can just go and experience it in reality. We can test it. And we've done that. We've tested it over and over again. There's no curvature.
Can I ask a question?
So, anyone else want to speak?
Yeah, we got Mikey. What's up, Mikey?
Right, so I do believe it's flat, and I do agree with everything you're saying. But one thing I don't understand is why the stars are not always visible 24/7 in the sky. Even in those pictures you sent.
Mm-hmm. Well,
Why
I think
can
it's
we
just
sometimes see stars in the sky,
yeah.
but on photographs like you sent of what we call space, they're not there. Where
Yeah,
do
it's
they go?
kind of crazy, isn't it? Yeah, I don't know. The higher you get, the less stars you seem to see. And the lower you are, I mean, to a certain extent, you can see more stars. It's kind of crazy. Like, what the hell are stars? That's another question that we don't know the answer to. We don't think that they're burning balls of gas in a space vacuum, millions of miles away and much larger than the Earth. So yeah, I'm not sure. Stars are a trip. The sky is amazing. It's a big mystery how the sky works. But it could be to do with the exposure settings on the camera or something, why you can't see stars in these pictures. I'm not sure. I'm sure there's an excuse that the Globeside has for this.
Yeah, maybe. And have you seen NASA's first picture of Earth this year?
This year?
Yeah, I believe they posted it on the first day this year.
Okay, now that
basically, if you compare that picture to every other single one they've apparently taken, only that one has all the stars and everything else in the background.
Oh yeah, I can see it now. I just looked it up. Yeah, I'll post it in the side chat. Yeah, I didn't know about this. All right, here we go.
Tell me how fake that looks.
It looks completely fake and ridiculous. Yeah,
it's ridiculous, right? I think they've gone to the point where they're just seeing how delusional people can be. They're really pushing it at this point.
How much they can get away with.
Yeah, that is such a fake photo, and literally no other photo they claim is real looks like that. They all look completely different.
Mm-hmm.
And what actually made me believe it's flat is someone told me to look up a real picture of a satellite in space, and I literally couldn't find one. Every single one looks fake, and that's when I basically started to transform into a flat earther, basically.
Yeah, so anyone listening can just go to Google and type in photograph of a satellite in space or satellites in space and just hit images. And all you're going to see is a whole bunch of cartoons, every single one. There is, in fact, not a single photograph of a satellite in space. Some people claim to have zoomed in on the ISS, and you can see a little blurry picture of the ISS. Okay, but just a regular satellite that we get told about. Every single one's just a CGI picture. That's kind of crazy, isn't it?
Yeah, it's insane that they're just lying to everyone's face.
How fast are these satellites moving in space?
Well, they claim to be moving at like 17,000 plus miles per hour or something like that, aren't they? Depending on how high they are and that kind of thing. But how are we going to confirm that, right? That's just another story that we're being told that we have to have faith in or not have faith in. You're not going to be able to validate that. It's just a claim.
Yeah, the thing with the speed is, it's another thing that just doesn't make any sense. For anyone that doesn't know, a bullet from a gun travels at about 2,000 miles per hour. And, NASA, they claim that we, as a solar system, are moving through space, through this infinite vacuum, at 800,000 miles per hour, while somehow there's also all these satellites surrounding our Earth that are following us too, while we spin in this corkscrew pattern with all these other planets. The more you sort of explain it, the more dumb it just sounds.
Yeah, the more you look into it, definitely the more outlandish the claims become. They throw such big numbers at people that it kind of short circuits people's brains. They don't realize that the speed of sound is less than 1,000 miles per hour. Okay, and then they claim that the globe is spinning at 1,040 miles per hour at the equator, and then it's orbiting the sun at 66.6 thousand miles per hour, and then it's chasing the sun at the same time that's traveling at 480,000 miles per hour, and then that whole system's moving as well at like over 1 million miles per hour. It's freaking crazy, the claims. People's brains kind of just short circuit when it comes to those speeds.
Yeah, and the moon as well. It's circling around Earth, right? They say, so while we fly, somehow the moon is also circling the Earth. It's insane.
They claim that there's 15,000 satellites in space.
15,000. Damn.
15,000 moving 17,000 miles per hour. I don't know.
Damn. We can't get a picture of one.
Well, you can't even find a fake picture where there's two in one.
The only pictures that I've seen of satellites, like photographs, is when they're on balloons, like stratospheric balloons and things like that. They're up super high altitude, and you've got like what looks like a satellite attached to a giant balloon. That's the only ones that I've seen pictures of, like actual photographs of. Never. Yeah.
So just observing when people are questioning flat Earth genuinely and wanting to know, one thing that I've noticed is they can't grasp the fact that they've been lied to. I think that's where it all starts. It's like, why would they lie? And then you have to
that's exactly. And my answer to that is that I don't think people, for the most part, are actually lying. Like the vast majority of people genuinely believe that the Earth's a globe. Even professors and most scientists and things like that. I think they're just, they've been taught it in the textbooks. They've learnt it their whole life. They never questioned it. They've never tested it. They've never been presented, alternative arguments. And, they're just running off a spherical model, a mathematical concept, basically, that was how the globe was born originally. It's not because people went out and started measuring Earth curvature, that's for sure. Okay, they took a celestial sphere and basically inverted that into the globe through philosophical reasoning and things like that. People who were mystic cult leaders like Pythagoras.
You're correct. I wouldn't consider my 6th grade teacher a liar just because that she had been indoctrinated and just doing her job.
Exactly. Yeah, exactly. They're pushing the bullshit because they're experts at memorizing the book of bullshit. And, that's their job, is to memorize and regurgitate information. And then it's the students' jobs to memorize and regurgitate information on the exams. And then you get a stamp on your wrist and a good grade. You got an A, little Bobby. You regurgitated the information just right. Well done. You're smart. Top of the class.
I think you're doing a great job, DJ. I think you're doing a great job.
Cheers, Charlie. Just trying to get some information out to some people, that's all. Not trying to convince people. Just like, hey, check this out.
One thing that I've noticed too is that we tend to look up when trying to prove that the Earth is flat. I think it'd be best if we just stay on the ground and explain how the Earth is measured, rather, because that's the first thing that they go to is, well, what about the moon, or what about space? And that is all irrelevant when it comes to how the Earth is measured, in my opinion.
Completely agree. It's usually the globe side that will do whatever they can to try to divert the conversation back into outer space where none of us can really validate anything empirically. While we're trying to keep the conversation on the ground, it's like, this is the one thing that we can test, and this is the one thing that is required for the Earth to be a globe, and that's that the water is curving. Most of the surface of the Earth is water, and that water has to be curving at a specific rate. So we can just calculate that. Okay, and while we may not be able to see the curvature because we're so small, and if the Earth were a globe, it would be so big it would appear flat to us, but there would be byproducts of that curvature in the form of a geometric horizon at a certain distance, and then things that go beyond that will start to become obstructed behind that horizon. It has to happen if the Earth's a globe, and that's how we check for the curvature. And there is none when we check.
For sure. I completely agree. I got to go, but DJ, like I said, you're doing a great job.
Cheers, Charlie. Catch you next time, man. Thanks for, yep.
So you see that video that Miguel posted about the stars?
Yeah.
That still doesn't really answer the question of how when we do go really high up, you still can't see them. What Miguel is showing is if we, outside of cities, they're nice and clear. But once we go really high up, they're still not there.
Yeah.
So that's what really confuses me. And it's a question that I just struggle to answer when someone asks me about the stars.
Yeah, it's crazy. Why would that happen? It could be something to do with the camera exposure settings, I guess, but I don't know enough about how that would work. Yeah, and it's interesting the astronauts, when they interviewed the astronauts about can you see stars when you're up in space, how some of them would say that when you're up there you can see all of the stars, like way better than you could ever see from the Earth. It's like you can see everything. And then other ones are like, I don't remember ever seeing a star the entire time I was in space, like Neil Armstrong, for example. Says, I don't recall seeing a single star. It's the blackest black you could ever imagine. Contradictions all over the place.
Is there anything that might make you believe it's a globe?
Well, not really at this point, because there's been so many tests on now showing that there's no curvature. Now, the only explanation to the tests would be some kind of crazy refraction that we don't know about, right? Because when you learn how refraction works, you learn that that's absolutely not an explanation for why a laser would hit its target over a huge distance in all different locations all over the Earth, completely different weather conditions. Why would a laser beam bend hundreds of feet or dozens of feet, depending on the distance, to perfectly hit the target every single time? How come every single time we go out to do a long distance observation, that geometric horizon isn't anywhere to be found? Okay, we've just got probably thousands of observations and laser tests and things like that that are being done now, all showing that the Earth can't possibly be a globe. So they would have to prove that it's a globe via the same type of method, right? Empirical testing, measurements of the surface of the Earth, right, over the surface of the water, and then they would have to somehow explain away all our tests, and then they would have to repeat their tests to show that it is actually matching up with the claimed globe mathematics. So They got a bunch of problems that they need to explain, but it's always going to go back to the curvature problem. Whatever's happening in the sky is irrelevant if the surface is measuring flat, right? Because whatever's going to happen in the sky is not going to change. It's not going to make the water start to bend. So yeah, it's pretty much something I could say I know it, as a fact, because it's been empirically tested, and anyone can go out and verify these tests themselves. We encourage people, go out, do your own tests. You don't have to believe us. Just go and check. And then you get people like Dr. John Dee, who's a PhD in optics, spectrophotometry or something like that. So he's an expert when it comes to optics and light and how light propagates through mediums and things like that. And he went out originally to try to debunk flat Earth, doing different types of tests, using different spectrums of lasers and using super zoom cameras and things like that. And he became a flat earther in the process. So we encourage people, go out and check and then post your results, and then we can all go over the results and analyze it and, be intellectually honest analyzing it and come to a logical conclusion. So this is where I'm at, basically. Like, we all have a baseline. We have a base axiom that we all experience, and that's that the Earth is flat, stationary. And then when we go out and test it, that checks out as well. So until someone else can provide something that goes against all of this logic and common sense and common experience, then it is what it is.
What do you think the sun is?
Absolutely no idea whatsoever.
Because I see flat earthers post different videos of what the sun is, and I see videos of people trying to show us the sun being local, where clouds literally go behind it. Have you seen those?
Yeah, I got a whole folder of them.
Then there's videos, like the screenshots you sent from, where you send a balloon into space, and the sun is beyond everything else. Right. So how do you know which one is the actual sun? Do you know what I mean?
Well, okay. So, what the sun is that we see is an apparent light in the sky, and it has to do with the way that our atmosphere works as well, or atmo. Not atmosphere, really. It's not a good term, but it has to do with the way our atmo works. Now, David Weiss, not that I like David Weiss that much, but David Weiss has a great test that he did with his wife in his house, and they kind of gave a good demonstration of how the sun that we see is apparent to each individual person. And if you have something that represents the atmosphere in a demonstration like he did, he sort of showed how the sun can appear in different places for different people, and that what we see is an apparent sun. So what he did is he stood on one side of his living room, and his wife stood on the other side of the living room. They had a big sheet set up, and then they had the light source, right, to represent the sun behind the sheet. Now, from David Weiss's perspective, when he looked at the sun, he marked where he could see the sun. He could see like a round sun that looked like a sun on the sheet. The sheet is to represent the atmosphere, okay, because we're looking through a medium, a big, thick atmosphere. So they put the sheet there just for this example. Okay, so he pointed onto the sheet and drew a little mark where he could see the sun. Now they moved the camera over from where David Weiss was standing to where his wife was standing, and he said, "Okay, where can you see the sun?" And she's like, drew like a a little mark on the sheet where she could see the sun. So they could both see.
You're watching 24/7 Flat Earth Discord live.